yeah.
We are live with APEC, so I'm just going to shut up and let APEC talk.
1 millimeter? Yeah, that's considered a big thing. Centimeter, maybe? No, 1 millimeter. That's not even enough to cars drive slow here. It's like southern Japan or something? Well, there is no southern Japan. Either east or west. Kind of a strange thing. East or west. Hokkaido is I would call it northern Japan in my colloquialism. Or east. Yeah, but that's where it's a colder part. Hokkaido is interesting because they have like icebergs, iceberg breakers, and stuff like that. But no, this is Nara, which is kind of in the middle. And it's surrounded by mountains. So it's the weather, like the snow and stuff, stays more on the Osaka side and less on the Nara side. Or it skips over Nara, goes over to the next prefecture. And so they actually do get like for the snow or something like that. So, but for some reason, Nara area, it may be. And people put chains on their cars. Coming from Missouri, it's kind of strange.
We're just waiting for APEC to go live momentarily here, guys. So please bear with us. APEC will be live in about 5 minutes' time.
What do you plan to do with that? This is for lots of experiments that involve RF, the all-spawn experiment. This is a 200-watt amplifier. 200 watts. Okay. I have returned. Nice to see you, Jim. As the great General MacArthur once said. Wait, did he say that? He did say that. I have returned. For every person alive has ever said that. MacArthur said that after he got kicked out of the Philippines in World War II. Yeah. He was more of a politician than a military leader. That was his problem. So I believe it was the Japanese wiped the floor with him and kicked him out. And he went home and begged for a giant army. He came back and said, I have returned. He came out in Australia, actually. Did he? Yeah, he never came back. He was close. It's horseshoes and hand grenades. I've returned close. I'm almost there. Well, he actually did return to the Philippines and liberated it. But as Tim went back on big on he was a politician though. Most of his stuff was highly leveraged for publicity. That was compared to like most of the other military leaders, he was no publicity now. So definitely was. Yeah, half the work and twice the press time. I would say almost publicity / military politician. Well, wasn't he the governor? Didn't they put him in charge of occupied Japan though? If I remember right, he actually did a ton after the war. I'm trying to think if that's the person I'm thinking of. I'm not really sure if that's true or not. And then he put his political skills to use, if I remember right. But I think that was what he leveraged his World War II victory into was the being in charge of Japan during Reconstruction. Well, the smartest thing that he
would have done is that all of the soldiers that came into Japan, none of them ever seen battle with the Japanese. And America was pretty sure to have exactly 2% people. So.
Oh, I see what you mean. So they didn't have a lot of hostility there. Yeah.
So.
Yeah, because Americans who combat vets, if they'd come in, they would have had a lot of grudges to bear. So.
That's right.
Yeah.
So they kept all those people out.
Hello.
Okay.
So we got a minute left until I'm scheduled to go live, so I'm just gonna.
Yeah, go for it, man. And then I will count it down, and I'll do my thing too.
Yeah, I just got one question for you, Jim. Is it true that Hutchison became a woman?
No, it's just a publicity gimmick. He just cross dresses. I asked him about it. He just does it for publicity. I think it's some kind of a artistic statement.
Do you mean Miss Carla Nipton?
Yes, I mean Miss Carla Nipton. It's
a riot, man.
It's unexpected, but at the same time, it's the 21st century, so.
Exactly.
You know,
Exactly.
point, right? Yeah.
Just curious. Okay.
Klingon Baroness Carla Knipshin Hutchinson.
He's got a huge crush on Paris Hilton too.
I think he knows her. He knows a lot of. He used to be best friends with Michael Jackson. That's true. He was best friends with Michael Jackson. Okay, yeah. Give me just a sec. I'll be right back. Here, let me center that. Yeah, that's okay. I'll be right back. Yeah. So if you want to start it off, and then we'll go.
And we are live. Thanks, guys. APEC starting up soon. Welcome, everyone. How's everyone doing tonight? Everyone having a happy New Year so far?
Okie dokie. We have a full house today. So what I will do is put this on speaker mode, and I'm going to mute everybody out. Okay. And then I'm going to, let me see, you guys be able to hear me okay? Yeah. And you guys can all see me, right? You raise your hands, see me? Okay. Awesome. Okay, so I will do our intro, and then we will take it away. So 3, 2, 1. Welcome to APEC. It's January 1st. And I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Charles Crawford III will present on Alexey Chekurkov's Graviflyer kit. Mike Gamble will be discussing the Tesla Resonant motor, and I will be presenting on the Hutchison Effect material samples. We'll be finishing off the event with an open discussion and ad hoc presentations by conference attendees. So let me give you a couple of quick reminders. You can view conference replays, details, and speaker info on our website at www.altpropulsion.com. Please save those questions for the Q&A session after each presentation. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. You can also type those questions in the chat, and we will go through them all after each presenter finishes. So let me introduce you now to our first guest. Charles Crawford III's engineering education started in high school with electives drafting electronics. He graduated high school with most outstanding student in technology, graduated top of his class with a Bachelor's of Science in Electrical Engineering Technology from Dubai University. And he's currently a PhD student in electrical engineering at the University of Texas at Arlington. He'll be presenting today on his continuing work with Alexey Chekurkov's Graviflyer kit. So without any further ado, let's welcome Charles to today's event, and I'm going to hand things over to him to get started. Okay, and Charles, I am asking you to unmute. Go ahead and take it away, sir.
Thank you, Tim. All right, start sharing my screen. How's that look?
looks great.
Okay. Start here. Okay. Okay. Yep. So let's check that out. Charles Crawford III and his Alexey Chekurkov's Graviflyer kit. Kit design explained by me. It's January 1st, 2022. So happy New Year, everyone. I have my contact information here. The shavec2@yahoo.com is my email, my Facebook, my YouTube, and a Thingiverse page. There's also the share drive for all these files I'll be going through today. In case you're not familiar, Alexey Chekurkov, shown here, is a Russian self-proclaimed garage scientist, where he's invented this Graviflyer, which is based off designs from 1922. And he's combined several different ideas to make this device called the Graviflyer work. And as you see here, it flies and it could lift itself pretty high by adjusting the parameters of all these electronics. And he's also got a lot of controversy on it because he's the only one that's seen it fly, and he's posted his videos on YouTube. Some people have asked him, to go outside without trees and where the device would not interact with metal reinforcement in the floor, as he's shown in his earlier videos. So in his more recent videos, he's out in the field with no suspension around him, no trees around him, and he's put loops around the Graviflyer, he's put his arms around it, he's leaned over it, spun around it. He showed there's not a bolt suspending it up. So it looks to me like it's alternative propulsion that hasn't been seen before. So it's using a form of high voltage AC, DC, and ultrasound to create this lift. And here are some different designs he's shown in some of his videos. This is the earlier Graviflyer, which was stolen from his garage, and we still have that one has been returned. And this one was one he showed later in his videos, but barely lifted, kind of fell over in some of the videos. And this is the latest one he's been showing in his videos, and this is actually the one he shipped to me when I bought this kit for 2,000 euros. There's a slight difference in the bottom here. He modified it since then, and he's since cut off these little edges, but other than that, it's pretty much this model. And in the field, I took a screenshot here from this video showing the electronics he used. And here he had it powered all on his car battery, 12 volts, so it's a low power system. This is the Slater Exciter Tesla coil, or also catcher, and these are the electronics for it. That's the power bar for it. This, I believe, is the ultrasound device, and this is a high voltage device. And this box just has the regulator to convert the power from the car battery into 12 volts for these systems. And this Tesla coil and electronics for that are part of the kit he sent to me, but these other ones he still has. Alright, so here is the Graviflyer design. Graviflyer schematic shown by Alexey Chekurkov from his channel. So his design's already free and open source since around 2017. He started showing videos. This video was after that when subscribers were asking to share more of the design. So there was one change I made here is this NPN transistor. It was a comment he made where the transistor was drawn with an error when resizing it, so when he redrew it. But this does not mean that it was assembled with an error. So from the schematics I've seen, this is how the transistor should look. So I'll break it down to the four main components of this. The first here in blue is the high voltage circuit. This green part is the ultrasound. And the red part here is the Tesla coil, or catcher, as he calls it. And the fourth part is more of a mechanical frame than an electrical schematic. But here he included it all together with that. And all these combined is what creates the lift of the Graviflyer. And what I got with the Graviflyer kit, I updated the circuits. So after getting these kits, I took them apart, understood them better, and updated the schematics. So they were very close. One thing we noticed about the flyback transformer, the high voltage circuit, was included the diode and capacitor, which is actually included in the flyback transformer. So you really didn't need to show that. Chris Hardeman and I spent many months trying to reproduce the diode and capacitor configuration, but it wasn't needed. Later, I showed him this updated schematic, and he said those diodes and capacitors were included in this flyback transformer schematic. And here's the ultrasound circuit. So the one he sent me is a little different. He's using this regulator to control the voltage of the motors and power to the ultrasound circuit. And I updated the part numbers, which will go into more details into each circuit. Slayer exciter Tesla coil, I updated those values as well. And this he actually sent me with the kit. It gives more details of the construction of the Graviflyer frame and the motor distance and the layout of all the components and the wires. So we'll go into more detail on those. The other component besides those four was the gravitometer. This is only to measure the field around the Graviflyer. And it shown here, I have showed the schematic for it, and the electronics are mostly inside this compartment. The potentiometer, the capacitor, red and green LED indicator lights, and he also updated me on instructions on how to use this measuring the Graviflyer. You see in some of his later videos, he's using it to tune the device. Since the electromagnetic fields around the Graviflyer are visible to us. So there's more construction of the gravitometer. They have 3 antennae, and they're about 9 inches long. And I'll apologize that I switch back and forth between inches and metric and imperial. So the thickness of these are about 0.79 millimeters. And again, these are inside that component. And the back just has a little hook to hang everything, and the 3 wires go to the antenna, and a shovel handle modified to hold it. I reverse engineered the design, and it's available on my Thingiverse page, Charles III. And you can 3D print this rather than making that other frame to help hold the meter and electronics. So these are the instructions. He emailed me on how to use it. To quote Alexey, he said, "Hi Charlie, I'm sending instructions for the gravitometer. The device does not need batteries. It works from external electromagnetic fields. 3 antennae help to determine the field boundaries. The device has 2 indicators, red and green. Below that is a potentiometer for the analog meter. High frequency energy emitted by the Graviflyer is captured by 3 antennas. The red indicator lights up indicating the presence of electromagnetic field. The green indicator lights up when the upper and lower discs begin to form torsion forces. They are not shielded by anything and affect electromagnetic devices. The analog meter begins to go off scale. In this case, you need to start reducing the power and electromagnetic field captured by the 3 antennas by turning down the potentiometer. If the arrow of the device continues to go off scale, then you need to turn off the middle antenna by opening the switch on the right side. If, in this case, the gravitometer continues to go off scale, you need to move the gravitometer away from the device. This means that torsion fields have formed an energetic cocoon around the device, which has a certain intensity of shielding gravitational waves. It is important to point out that the zone of powerful torsion fields is harmful to the body. It is necessary to limit the time of the experiment. The antennas placed in the field of the Graviflyer will show an intense zone of the apparatus, which is not desirable to cross. The indicator should be adjusted when all 3 antennas are turned on and the analog device is positioned in maximum sensitivity. As the electromagnetic field increases, the sensitivity should be reduced. 2 lit indicator signals that the device is tuned to the levitation effect in which gravitational waves bend around the body of the Graviflyer. Alexey Chekurkov on October 30th, 2021. Okay, let's go into the high voltage circuit. And the data schematic is again shown here. It has a switch, 2 resistors, a transistor, and a flyback transformer. Here's kind of a side view of the transistor, which is connected to the schematic heatsink, and it does produce a lot of heat, so it needs a lot of heat sink to cool it down. 2 resistors are 5 watts. Zoom in here, they're 5 watts, 220 ohms JW, and 5 watt, 220 ohm JM. So that one is the 22 ohm, and this is the 220 ohm. This is shown here. This is the power adapter, so I thought adapter is for by the US plugs. And it can do up to 2.5 amps at 3 to 24 volts. And behind this board is how he soldered those resistors to the rest of the circuit. In its container, looks like that, and he labeled it as 20,000 volts. And the negative is blue, the red is positive. Input power is an on-off switch. And here's the signal that comes from that. It's a sawtooth with a high rise time, slow fall time. So that is pretty popular for lifters. So that is I think helps a lot with the lift Graviflyer. But unlike lifters, this thing weighs a lot more. It's about 2.5 pounds or 1 kilogram. The ultrasound device is on the top cone here, under the cone. I'm sure I took that off. Just curious to see what it was. And under that, there is a stand which was glued to the cone, but it had fallen off, I guess, when he dropped it. In some of the early videos he was testing to see when he unplugged the power, it would fall from a height of a few feet. Underneath that stand, there's the piezoelectric device, which is just glued to the bottom of that. And when I re-glued it back, it's about the distance from the cone. It's about the middle of the cone. And the piezoelectric device he's using is 27 millimeter diameter. And the whole circuit he sent me is here, and this knob controls the volts to the motor speed, and this potentiometer on the right is controlled the frequency of the ultrasound. So kind of two circuits in one box here. And again, that's here. The power brick was this, and it does from 16 volts. And this original circuit showed 12, it's probably around there after it drops. It's kind of an older power supply. Alright, so let's go more into detail into that circuit. When you open the lid, it's a bit of a mess here. This is where the power brick is, and the two potentiometers. And behind the circuit boards, is solder connections to that transistor, and there's your solder connections to this capacitor, which is 160 volts, 100 microfarad capacitor. And I really like this toroidal transformer he hand wound. So he took a inductor that was already wound with copper twisted enamel coated wire, and he made his own transformer by winding that with this wire, and that helps with the piezoelectric high frequency. These are the potentiometers he uses, 10 ohms, and he got most of his parts look like from scrapyard. They were repurposed, so these were used parts, but they work well still. And these are the LM317T. It started to get damaged because this component gets really hot when running this circuit, and it's on a heat sink here. This is the other transistor used in the ultrasound switching. It's the power resistor for that circuit, 240R JBA7. So he said it's another quote from Alexey. The ultrasound start was from 200,000 hertz and above. If you listen to the piezo element in complete silence, then your ear can hardly distinguish a barely perceptible rustle. I took a diagram from the internet. Here's a link to the site, and here's a Russian link to that circuit. So the device has a built-in adjustable power supply unit from 1 to 30 volts, but the voltage must be set within the range of up to 9 volts. And I replaced the constant resistor in the ultrasound circuit with a variable one to adjust the ultrasound. Unfortunately, I do not have a frequency meter to measure the parameters. You must not only look for the frequency, which resonates with the torsion vertices created by the spinning disc, but also adjust the duty cycle of the pulses from the catcher, and also adjust the voltage of the high voltage generator so that there is no breakdown between the plates and the current is not too low. I myself have been dealing with the physical processes created by the apparatus for half a year. It's on Chekurkov, December 31st, 2021. So just yesterday, can you help me that? So here are the Tesla coil, or side or Tesla coil is the more distinct name for it. Chekurkov calls it the catheter. It I measured having 1.2 megahertz with no wire down the center, but the center wire is needed to supply the voltage to the center plate. So when you have that in, there's 1 megahertz at 2,480 volts AC peak to peak. AC signal looks something like this. And the plate gets about 1 megahertz, 270 volts AC at peak to peak. So the primary on this Tesla coil has 4 turns at 18 watt American wire gauge. And the secondary has about 1,055 turns at 24 American wire gauge. And it is 15 inches tall. And this is the transformer he's using, the main component, which is a 2N3055 transformer. And this more, someone asked me that they had trouble reading the schematic diagram and they were confused with the transistor layout, so I drew it like this. It shows more picture diagram, how to construct it. Inside the container, Alexey's zero electronics for controlling it, so it's a little messy, but everything works in the end, so I'm happy with it. The two, it's very important to have the exact dimensions for building a Tesla coil, so if anyone is trying to reproduce this, give more dimensions on the Tesla coil. Alex Chekurkov at me. It's about 2 inches in diameter. The thickness of this wire is 0.36. The height is about 15 inches. And here underneath the primary is the connection to the secondary. The diameter of the primary is 62.9 millimeters. The thickness of that solid copper wire is about 1.06 millimeters. And the height here is 88.12 millimeters for the primary. And again, I put designs and other parts and schematics on the Thingiverse page. So you can 3D print. I redesigned and printed this container and stand for the Tesla coil. So the fourth part is the Graviflyer frame, which with updated designs from Alexey, showing the piezoelectric elements under the cone. Strangely enough, this top part is mostly solid, so the sound somehow bounces around this cavity. Maybe Todd Desiato thinks it's reflecting off this whole circular top part, which you can see here, it's light green color. And you can draw here the wires here in this green crayon. Drew it to go down. That's the motor power cable, which is also connected to the ultrasound in a twisted pair combined wire. So 2 are for the positive, negative, the 12 volt for the motors that are connected parallel, and the ultrasound positive and negative, which run up to the top there. And then the other wire you see in the video is the catcher, the Tesla coil wire. It goes directly from the bottom, connects to one of the legs of the Graviflyer. And the other wire is the high voltage. It's a twisted pair, about 18 gauge, positive and negative. That is in this. So in the video you see the 3 wires, but inside those wires have several other wires shielded there. And this is the brand for the top and bottom motor. They're the same, even though the bottom one looks different. He's just using a siren, which you get like a 12 volt siren put on your car. You modify that plastic casing to just go around the bottom motor and to help just hold the frame. But there's no electronics from that circuit underneath it. It's just a motor. And it said the voltage about 30 kilovolts. The speed of the disc is about 2,600 to 2,890 RPM. But there's nothing else to measure. Under measuring the disc, though, that's an important thing. A lot of people are asking, what are the diameter of those discs? About 8.5 inches, roughly equal. And he has the north-facing up magnets, 6 of them evenly spaced at near the edge. And there is some steel casing around those neodymium magnets, particularly there and N42 neodymium. Measuring the diameter of those, about 25.21 millimeters. And the height is about 7 millimeters. And the brushes make contact with the outer sides of the plates away from the center plate. And they're connected with this brass brush, which is for the bottom plate, and This is for the top mount. It just has a load connected to that runs along the side of the frame. It's for the high voltage. Alright, underneath we have all the connections for the high voltage, positive and negative, for the splicers, the ultrasound and motors, and the Tesla coil goes directly through the center, out the side, and connects to a leg. This is the diameter of the center plate. He had to bend it to ship it to me. So he said, so I had to unbend that to get it going back to work. And it's about 15 and a half, almost 16 inches diameter. A lot of people were asking about this oxidization and threw it off for a long time. We thought it was some type of steel plate, but it's actually a aluminum plate, and this oxidization is actually some residue from epoxy or something, probably WP, when he found it from the junkyard or whatever. That's what we got on it. So the motors, the top motor was completely cut off the fins. The bottom ones were badly damaged as he used like a Dremel to cut around this acrylic insulator, and he labeled 1, 2, 3 holes for the screws that go and hold the bottom plate onto this. So a lot of people were saying, was it the fan blades that were suspending it up in the air? No, definitely not. The top blades are completely missing. The bottom blades are badly damaged. These are the other hardware components, the 3 legs, which are stainless steel. The rest of the components are slightly magnetic, so a mix of steel and other metals. And they just gave washers and nuts, no lock washers, no lock nuts. So you have to make sure that they're very tight on the frame, or else the spinning of magnets, electromagnetic fields will start to unscrew those. Those nuts. Again, I have a design on my fingers for the frame, but that's a little older design. I was using brushed, the 3-phase brushless motors, which is not a good idea because the high voltage near those, they use PWM signals to control the speed of those, and any high voltage or spinning magnetic fields or the AC field from that Tesla coil all interferes with that signal, so it'll just randomly speed up or stop, stall to use that. So I recommend using the fans, the mains you shown. So Alex Chekurkov also gave me an update on the Graviflyer frame. So he said, "Hi Charlie, I saw your video where you're trying to tune the Graviflyer to remove the neon lamp from the catcher. It extinguishes the power. And now how to tune the parameters for the levitation effect. The levitation of the apparatus is based on the interaction of magnetic and electromagnetic fields. 6 round permanent magnets interact with the electromagnetic field twisted in different directions. This interaction begins to create torsion fields of different directions. The middle distance to which the impulses are supplied from the qualitative devices does not allow the fields to mutually neutralize. The ultrasound passes in these fields at a certain frequency, creating a swing of the medium in which the gravitational waves of the Earth do not have time to influence the Earth and push it to the ground. We just need to create these conditions. 1, select the duty cycle of the pulses from the kicker. Set the required voltage on the high voltage generator. Set the correct frequency of the ultrasonic generator. Combine all the adjustments until the parameters of all processes have shifted to other values. As you can see, it's like picking a code for a save, stumbling upon my combination of these parameters after 3 years of experimentation. Unfortunately, I did not have necessary instruments to measure the characteristics of the processes. It took a lot of time when I first learned to just make the apparatus jump and then freeze and finally stabilize at a certain height. This device is undergoing processes that I myself still do not understand. Perhaps you will understand it better than me with your equipment and improve the apparatus. My plans for the future are to build an apparatus of a Mercury engine, like the discs of Nazi Germany. I already ordered Mercury. I collected quite a bit of information on anti-gravity technology of the Third Reich. Many subscribers to my channel shared secret technologies, and I already understood some. Good luck with your work. Alexey, December 21st, 2021. And again, these are the links to Alex Chekurkov's YouTube channel, where I've first seen all his videos. He doesn't have any other videos I'm aware of, except for maybe a YouTube for some of the deleted YouTube videos put on there. This is my email if anyone has want to contact me for questions or concerns, and my Facebook where I've been showing updates, but mostly on my YouTube channel. And if you want to start building your own Graviflyer, you can use some of the designs on the Thingiverse page, 3D printed parts like the graviton meter and the Tesla coil. The Google Drive also have pictures, more detailed instructions on all the pictures shown in this presentation. I'd like to also do a live demo showing I've got the whole complete kit here ready and set up, so let's jump to that. I've also wanted to go back to, this is the link he sent me, and this is Alex Chekurkov's website. These are the share folder with the different parts and parts list, cells, photos, going more into details, and pictures are all there. So this is free and open source. So let's switch to sharing the video. To switch this, I can maybe switch on my phone if we need to get a better view of some of the equipment. Switch to might have to share full screen. Okay, highlight it. Okay, yeah, in the chat, maybe if you give me a thumbs up if you can see it well. Video.
Okay, and so you're doing you're trying to play video, Charlie, or?
And here we go. All right. Try to get you guys closer. Here is the kit, and it is connected to Graviflyer, which is down here. All right. So in order to run everything, turn on the power. We have power going to the motors, turn them up, turn the bottom motor, and we have the wireless energy to test the coil. So you can see when I get near it with the neon bulb. And I believe the setup order is to first turn on the motors and then get the full speed. If you wait and turn everything on at once, then the high voltage and the AC and the kind of plate will interfere with the speeding up of the motors. The drag going up all the places hard. So once I get to full speed, and then I will up the power to the high voltage to suggested 9 volts. I've also got this radiation meter and a LED set to help with detection while pumping. So far the meter hasn't detected much while tuning it. It seems like once you get the correct setup for limits, that there's things with higher voltage to that generation out of it. Alright, so to the motor and ultrasound circuit. This is a voltage for the motor speed, and the frequency of the ultrasound is about 200 kilohertz, so human hearing is about 20 kilohertz, which is much higher than human could hear. So adjusting this is kind of the more complicated part of it. Here we have the meter. It does light up red near the tester coil. And let's see the meter starts to rise a little. Okay. And the wire down the center is not physical contact with the output, which is collecting the wireless energy from the tester coil. A lot of people would ask how to touch the center plate if there's high voltage AC. That's because it's not in direct contact with the power system. So it's a high voltage, low current, and high frequency. I've also got other equipment measuring like the speed of the rotation of the disc. There's good equipment to use, suggested by John Hutchison. There's actually an AM radio. You can hear the hum. That's actually some radio waves of the testicle. I can prove that by turning it off. So you'll hear it. It goes back to static. You want to put that on. You can help kind of audibly hear the field that is out now. Graviflyer. That's on there. Also, infrared camera. Actually, I can show you clear one infrared video from the electronics that helps you get a view of where the heat is coming from the circuit. And now it's not too hot, but the heat can't hear. Turn the heat up. And the electronics here, as well as the heat into the pump, to the tester coil. That's pretty hot. The tester coil generates heat near the top, less than frequency of it. That's it. And yeah, I want to be clear, I haven't gone to lift yet. I'm still experimenting with this tuning this device, doing practice with that. So only thing I've noticed is it's spinning here and vibrating. Sometimes there'll be different variations of vibration. Whenever I double check to make sure there is an AC signal center plate, then I replace the magnets that were originally given. They were cracked. They were damaged from shipping, or maybe from Alex shipping from testing. And the rest works quite well. The electric is working. I connected to a different ultrasound circuit with check the lower frequencies here that was making noise. Another thing I'd recommend is when building a Graviflyer to stick with the 3-leg design. It's really good for being that it's 3-point contact stability. And for the 6 magnets, it might have something to do with the effect of when the magnets line up each arm. And also made some stainless steel. So the rest of the parts are aluminum, and aluminum. So this is what it says most of the time. And as Alex Chekurkov has shown with these cables, you can have much longer and they require much higher. Not keeping them a little shorter to make sure the signals are reduced down. But one thing I did learn is a lot of the electronics and circuits and theory of it is really low power. So a lot of people overdo it. It's too much high voltage to the circuit, and it will start to overheat and arc to arc. So you actually have to do high voltage low current circuit. And I recommend the 5x transformer with this electronic configuration for the velocity wave being where you want to achieve. And then for the coil, the height is what really is affected. So the amount of current for the secondary, primary. So I built some replicas of it. So that they have a smaller box, only about this size. So it has a large enough. So tuning Alexey analysis is taking several hours. So I don't will see anything in this short video. But you get the idea of the setup. One of the places I'm running. But I believe he must have spent many hours doing this and now I'm still showing the substrate and stuff. Also, I'm running in the background. I can go back to sharing the videos of the thermal imaging. Chekurkov also said that there's a high voltage field that goes somewhere on the downside of the electrical equipment, so he stays about 10 feet away from it when it's getting near and lifting up. You can tell that from the parameter signals that is much. But currently, when I use the parameter on it, it doesn't light up at all. So it's still a forthcoming tuning process to develop that field. Go back to share screen. Here's the thermal video, 01. So this is the player type tester coil. And the piece up there at the top here, so we're looking at the big curve, shows different than we're looking at the tester coil. Some of the equipment that I use that Alexey has got to do with equipment, yes. And this is the electronics to the player type tester coil, where the heat sink is near the stack here, that transfer which gets pretty hot. Where the heat comes out. Power break for the high voltage. Here it's about 11 volts. And the transistor switch get hot as well. So the circuit gets hot. It requires a lot of power to switch that transistor to power that the flyback transformer. Here's the transistor and the solid heat sink. This is a different ultrasound circuit. I was using pictures of the electric devices working at lower frequency. This is Chekurkov ultrasound and lower frequency coma. And then that transistor that's located near the front is supposed to be. Once you get closer to tuning, that you'll see more around the Graviflyer. Alexey has shown that the plasmoid frequencies are like 90 years of whole energy that somehow helps with glitch effect, which I haven't noticed yet. But if they would appear, then they would show up in the infrared sample camera. Mostly the heat on the Graviflyer is just front, it's 12 volts, so that's kind of 12 volts too fast. And there's a bit of a vacuum force, which is going to get through the luminous plate. And the thickness of this plate is 0.69 millimeters. the legs and the arms are all electrically connected to the AC signal, and it goes in the C along with the center plate. From the spinning of the sexy disc, there's a bit of a cool breeze coming off the side, and that cools down the center plate a little bit. High reflection off the metal. You can use that. Switch back to video. And it's still doing as before, a little bit more vibration. Focus on that sound. I'd still like to share some other videos. I created a playlist of all the other Graviflyer groups working on this. We have a WhatsApp. Anyone interested in going to 24/7 APEC WhatsApp group to help discuss and get updates from there. I also post on American Anti-Gravity Facebook page and my Facebook group. When we update this, as soon as I get this thing fine, I'll definitely share with everyone. Do that update.
Hey Charlie, we're getting some mic interference. Is that?
So this is
Can you work on your mic a little bit?
our YouTube channel where it shows the playlist of the videos. I've put together clips of all the flights for the Graviflyer. This latest one. It's now been about 7 months since we've posted anything since we received this Graviflyer, and he's been working on different designs. He's trying to build a larger one that he's getting ready to be quite busy on that for a while. This was the 2017 video. And he's done another series of videos. And to translate his videos, questions to English, use the subtitles, auto-generate, auto-translate to English. I helped understood most of the videos, and this is the best to translate. So we had Daria, which instruction helped translate the videos more fluent English. Among those videos, I've also included Nancy, which is a 2-hour lecture on his understanding of the Graviflyer. That's a little older now. It's been a few years since most of that. But it's also posted it into Chinese.
Hey Charlie, it's Tim. Sorry, we're having trouble with your mic.
This is Alexey, wants to be able to break down understanding. He's still working on his model of the Graviflyer. System also shows his version of the Graviflyer. Hopefully this explanation of the kit will help these groups work on their Graviflyer design more detail. Here's a guinea pig book. Was working on a 3D printed spinning disc. This system wasn't quite right, as Alex Chekurkov said, you probably shouldn't use 3D printed discs that explode there. So the thin aluminum using is good, and probably not sitting as fast as the video. Probably 2,500 RPM. Yeah, I think it's around 10,000 RPM. So yeah, that's what I'm at. Too dangerous to get that over the magnet. That's why you have to screw down the center of the magnet to help hold the plate. Here's another pink picture. There's something about pipe design. Magnetron. Another Chinese group. I don't speak Chinese, so I don't know what they're doing. It's also the one that got a lot of people ground scales using the slider. So using a digital scale is not recommended because high voltage will usually restore the electronic scale and the vibration. So that's another issue. So you want to use mechanical scale to have vibration suppression. After my testing, I've just been testing on the floor to see if I get the lift. I have tested it with the scale. Actually, some weeks ago, another group of Japanese, maybe Chinese group, that's been working on their design of Graviflyer. We're using actual chips. The translation Russian to English to Chinese is what he was talking about is the textured aluminum. They literally thought it was a heated, which caused so much of there. Here's Johnny Body. Was the hardened now with some space motorcycle and then New Jersey lab. We got pretty close, pretty accurate to design, not even like his rubber insulated. Larger Amazon motors, affordable, FCC. I believe we should get this design to fly and figure out the tuning process for our Chekurkov. We'll have to revisit that. This is some of my earlier tests. Using a 3D print frame and the phase encoders. And even then it was stored in the flashlight TV high voltage would turn off and turn on. You can be careful with parking and sparks the high voltage on the plate. Now we're using this type of pressure coil originally, but any wires put down that will set on fire if the resonance of it is not adapted. The coil will have to change to self-resonating will adapt to a wire down the center. So I don't recommend using this type of pressure coil. Other groups have talked about it along with other anti-gravity experiments. Yeah, I'm not the only one working on this. So far as the deep dump field, we were trying to understand the downside of it there. Quick prototype of it, and they showed that even like the pulses, the high voltage would create lift the magnet. Kind of led him to think that perhaps the Graviflyer was real. And just looked at what if I could see electromagnetic field on your magnet, they jump, let you go off the ground.
Okay, guys, let me do this. We're we're having some trouble here. We can't get through to him, so I'm going to. Oops.
All right. Well, I think that's about
Okay.
everything I want to share.
Whoa, Charlie, here.
Oh.
Hang.
Probably the ultrasound or the background noise.
Oh, okay. Charlie, sorry, it's Tim. Can you hear me?
And we're going to go to the question section, and I'll let this run. It's a bit of a noise. I'm turning off. It's too loud for you. We'll just finish what the testing looks like, and I'll experiment with it so we get the width.
Oh, okay. Charlie, can you hear me okay? Yo, Charlie. Yeah, Charlie, can you hear me okay?
I can hear you too.
Okay, let me see.
Experiencing
Charlie,
technical
your mic is
difficulties.
having problems. Yo.
Okay. Yeah, I guess the high voltage near some of the
We've got Charlie back.
Okay.
might have worried some of the
Charlie, can you hear me?
while we're working with this.
You're
Yeah.
talking.
So we should be good for this. The question doesn't also be the headset. Yeah, plug in. Put it back in.
Yeah, please switch headsets. Okay, can you hear me, Charlie?
Yeah, I hear you now.
Okay, yeah, no, you've had audio issues for like 20 minutes, and that's okay. That's okay. So, okay, well, let's do this. I'm going to put this thing on gallery view here. Everybody, please give Charles Crawford III an enormous hand. We did have some audio issues. I do think Mark Sokol said chat it was probably the Tesla coil. And I think it was. When you turned it off, your audio got way better, but the receiver still wasn't working. So again, my apologies to everyone for the audio issues. Let's go to Q&A session now, though. So who wants to go first? And again, you can raise those hands with, let me see, Option Y on Mac, Alt Y on Windows.
I know the high voltage, or the delta, will go more on.
And let me see, Nils, go for it, sir.
Can you hear me?
Yeah.
Okay, cool. Yeah, Charlie, well done for putting together all the components and getting something to move. My question is, how important is the ultrasound to make the effect that the Russian guy is claiming? Can we do without that, or is that a really essential part?
Good question. In our podcast, the other studying.
We can't hear your voice very clear. Can you move the mic closer to your mouth?
Sure. Let me try to. How about now? Can you hear me now?
A little bit better. It's a little muddy, but it's not horrible.
Can you hear me now?
Sort of.
Can you hear me now?
Yeah.
Okay. So, yeah, I believe the ultrasound is necessary to take away the outside bounce that is needed. That's one of the key you mentioned when you adjust the bandwidth, the ultrasound frequency, you adjust it to the right way. It's one of the more complex part of it, such that this ultrasound can't hear it. So, you want to go ahead. And then part of the other enforcement is try to verify the high voltage on the plates and AC on the center, and before you move up to AC, and you don't.
Okay. So Charlie, I think one of the things that would help is if you enunciate a little bit better, speak up and enunciate a little bit better. it seems like the mics on your machines might be having some issues, and that's okay. It happens. But just try and maybe project your voice a little bit and enunciate a little bit more. So if it's okay, I would like to ask you, before I go to our next question, I want to ask, I missed a lot of your presentation. You have this kit from Alexey Chekurkov. I know he's been sending you bits and pieces of information along the way. Have you gotten any results that indicate that this thing might work?
I myself have seen results. I haven't been testing it on the scale, so I've only seen it do it with. And even if it falls over or jumps, that would be a result for us.
Okay.
I can check out the electronics, and that would probably help with hopefully the noise cancellation and the high voltages.
Yeah, please.
I have one more question.
Yeah, go for it, Nils.
Okay. Charles, can you share that YouTube playlist that you showed on the video today? I'll be interested to watch some of those videos. Just the playlist. Where can I get that?
You post it here in the
Oh, that would be great. Yes, thank you. And,
Okay.
and just on the ultrasound to be done, is it a yes or no on the question? Is that an essential part?
Yes, Chekurkov sent all the designs he's used that Cradle was using ultrasound.
Wonderful. Thank you, Nils. Okay, let me go to Michael Boyd next.
Hey, Charles, can you hear me okay?
Hello, yep.
So, just the observation as far as the audio, if you would remain totally still when you're speaking, because it sounds like you're using a condenser microphone somewhere, and if you move the direction, since it's so directional dependent, it distorts your words when you move. So I suggest you remain as still as possible. That's just a suggestion, of course. So my question is about, you broke down the different components, but one of the things I heard is you didn't have a way to measure the frequency, was one of the things I heard. And I'm curious if you have a way of measuring the field strength of the Tesla coil.
Yep, I have oscilloscopes and other measuring equipment that I use.
Do you have an electric field meter of any sort?
No.
Okay, so I have this device that's called a tri-field meter, and what it does is it measures EMF, ELF, and RF. It costs about $100. It's called a GQ EMF-390. I put the information in the chat, and I would suggest you use that. Get one of those meters, and the advantage of this meter is it uses a USB interface to your computer, and it comes with a data collection algorithm, so you can collect the data, and that way you could actually measure the frequency and the field strength of both the electric fields and the magnetic fields. And I think that would be very useful. My concern with what you're trying to do is you have so many variables that you're trying to align that it's kind of difficult to resolve it. So what I would suggest is you start off with the basic equipment, your RF source. Also, how are you measuring what's it, ultrasonic frequency? Are you measuring that?
No, currently I don't have any meter per second detected ultrasound.
But you're using a piezoelectric coil, correct? So you can use one. What I suggested is get another piezoelectric sensor, and that one is the one that you measure with, because the way these piezoelectric devices work is you either apply a voltage to it to make it. So basically, a crystal oscillator is a type of piezoelectric device. It's like what they made the first radios were made with crystal oscillators, quartz crystal oscillators. So you can either drive it with a voltage, or you can measure with it. So if you have two of them, you have one that you're driving, and then another one that you're measuring with. You can actually measure the frequency of your ultrasound. That would be another key parameter for you to be able to tune this, because basically it's a tuning operation, and what you're trying to do, my understanding, is create a harmonic, basically where the phases match, so that they cancel out the gravitational field effect. Basically, my understanding is it's kind of like a gravity filter, kind of like what Ron Keto is doing, but from a different approach is kind of how I look at it. So I feel confident that this device is real, but I think there's an issue with the parameters. We don't have a firm grasp on what's going on at the system level with this. So these are just some suggestions I have. Get another piezoelectric crystal for a sensor, and get one of these EMF meters that I described, so that you can actually record your data. Okay, and as far as the piezoelectric sensor, that's something you can plug into your oscilloscope, so you can collect the signals on your oscilloscope. Okay, and my final question is, we're talking at one point about 2,480 volts was one of the parameters I saw. How do you measure that?
So I had a high voltage probe. I measured that.
So you have a high voltage probe that'll measure that high voltage. Very good. Okay, thank you. That's all my comments and questions.
Thank you. Yeah, I actually do have a meter here that helps detect.
Yeah.
It's still like two.
Charlie, I should jump in really quick too. So for future presentations, because I absolutely want to have you back, you've done a couple, we should probably keep all of the high voltage and stuff off, because it really trashed your mic, and I wasn't even able to really break through, which was sad, because you have such amazing material and you're so diligent, so.
So I'm still curious, what was that meter you were showing?
Similar to the one you were saying, it records the radiation, and you can look it up later on.
That's a GMC 320. Is that a electromagnetic field meter?
Yeah.
Okay, and that should have, does it have a USB port on it?
Yes.
So you can interface that with your computer, correct?
Correct.
Did you download the software that goes with that?
Just been recording, haven't downloaded it yet.
Yeah, I suggest you do that. I think that may be equivalent to the 390. I don't know if it's a tri-field meter or not, but I can't really tell from there. Okay, thank you.
Yeah, you're welcome. And the oscilloscope, yeah, multiple channels on that, so I'll be using that to measure multiple signals at once to see how they interact with each other. I'm still working on that.
Yeah, that's what you need to get your harmonic resonance that you're going to need to get lift.
Yeah. It's a good idea with the piezoelectric. I've been measuring the AC signal it's used to power the piezo, but it's a good idea to use another piezo to resonate at that frequency, and then I could be able to pick up the voltage and signal on that number 1 year. So I'll try that.
So I have a question. This is John Reed. Charlie,
John, could I get you to turn on your camera, John, if that's okay?
I'm sorry that the camera's not working.
Oh, okay.
So,
Yeah, well, go ahead, sir.
yes, Charlie, because many of us could not understand you clearly in what you were saying, I'm wondering if you would happen to have a transcript of your presentation, or maybe an outline that you could send to us.
Okay, I could send the PowerPoint, but
Yeah.
no transcript.
Charlie, you could put that right into chat, actually. You can upload files to chat if you wanted to do that, and everybody could get it there.
Sure. Yeah, I'll do that now.
Thanks so much, Chad.
Yeah. And again, Charlie, I can't thank you enough for presenting. Technical stuff happens. It is what it is. So.
Yeah, it was actually pretty good because the Graviflyer is known for its high electromagnetic fields, so I was worried it would even distort the Wi-Fi and disconnect me, but luckily it didn't build up enough to do that. So you do see that there's fields that are invisible that are interfering with electronics.
Yeah. Well, let me go to Morgan next. Morgan, go for it. And again, if you could turn on your camera, sir, that would be wonderful.
Yeah.
Oh, thank you.
Okay, cool. Yeah, sorry. So nice presentation, by the way. I wanted to just, I don't know if I missed this, but what actually is occurring on the Graviflyer itself? I see that you have like rotating magnetic fields and voltages applied to it, but what's actually like, can you describe a little bit about what that actual device is doing? You know what I mean? Like, what, if there's some, whatever, because I mean, we're talking about phase matching and things like this, but what's actually happening on the device? You know what I mean?
Yep, so there's three main forces: the high voltage sawtooth on the top and bottom discs, and AC signal on the center disc, and the ultrasound above, going above it. And there's also the spinning magnets rolling north facing up, which does create like another AC signal on the center plate.
So is this like
theory exactly what's creating the lift?
Is it like a capacitor?
Is still.
You said two plates with a sawtooth. Okay, so capacitor with a plate on the inside and then a rotating magnetic field below it?
Yeah, part of the capacitor is the bottom rotating disc that has the magnets on it. So you can say the bottom portion of that capacitor has the magnets. And then the center AC signal Alexey says is to use to separate the spinning magnetic fields on the top and bottom.
I see. Okay, so the magnetic fields are inside of the capacitor, and then you have an additional sawtooth electric field on the inside of that as well?
Well, there's the plates are the capacitor, so there's a charge on the plates, sawtooth, high voltage.
And it's DC or AC? Oh no, okay, that's AC. And then for the capacitor plates, is that DC or AC?
Well, on the plates that are the high voltage, AC is sawtooth, so it's like AC, and the center is AC for Tesla coil, high voltage, wireless energy. So the capacitor, there's no real other capacitor in there. The whole thing acts like a capacitor. There's a video on Chekurkov's website that he draws out the fields when he makes the two torsion field video.
Okay, yeah, that's on that list of those YouTube videos. Yeah, okay, I'll check those out. There's one, I saw there was a presentation where you kind of explained what's going on with this, right?
Yep, I can share my screen here to show it. Here it is. It's after the schematic, and the effort for translating it to English. Later it goes into what the fields look like.
Actually,
slide here.
Can you go back there? Is that one picture? Can you of the actual device itself? Can you kind of explain what's going on the device, just for a point of reference, or like with this diagram here?
Sure. This is an older one, so it shows magnets on top and bottom. But in later designs, he only has the magnets on the bottom disc. So it's kind of like acting as a capacitor. It's the top positive, the bottom negative, the center has AC.
If I could jump in, one of the things that kind of stands out to me is a lot of people have accused Alexey of being a fraud, but the amount of work that he has put into documenting this is pretty insane. You know what I mean? I've seen my share of frauds, and usually it's kind of surface level with a couple of cheesy schematics, and that's it. He's built several models of these. He keeps testing them, putting videos up. He's got detailed schematics. He's trying to outline fields. I guess it's possible, but it just seems like the time and energy investment that's gone into this is more than I would expect, I guess, if he was making it all up.
And I also would suggest going to Rex Research, if they have a page explaining their theory of the Graviflyer here in more detail. This is the sawtooth signal that they show was a little different than what I observed. I actually measuring it. They took screenshots from some videos and they go into the construction. Yeah, a lot of written text on the description. But they're using the older version of using magnets on top, which isn't in the later designs.
And do you have any idea what the magnets are actually doing?
They're spinning, but besides that, I don't know. I've tried to measure the plates when there's no high voltage applied and there's a signal created by the spin magnets.
And then is the voltages that are, excuse me, the frequency that's on the, so you have the two plates with the one in the middle, are these things at the same frequency, or what's the relationship between the frequency of the middle plate and then the frequency of the two plates on the outside? Is there some relationship with those?
Alright, well, they're all different frequencies, but somehow they have to kind of resonate together according to Alex Chekurkov. So that's the part I'm still trying to figure out exactly what, and he doesn't have an oscilloscope, so he hasn't been able to measure the exact frequencies of what's lifting.
Because it does, I mean, at least kind of makes sense, because if you have some, I guess, a charging capacitor, you got an electric field on the inside, and then if you have the middle plate where you're putting charge on that, that can create a lift. You know, I don't understand what the magnets are doing, but yes, but that would be at the same frequency. You know, if you have both of those at the same frequency with some phase, I guess you have to get lucky with that, but it seems like that could create a lift. It's interesting stuff. Okay. That cool presentation, actually. Thank you so much.
Thank you as well, Morgan. Okay, let me go to Michael, who has been patiently waiting. Mr. Sullivan?
Hello. I was just curious if you ran any simulations to help you troubleshoot it.
I myself haven't. I've looked into simulating some of the circuits earlier on, but I found it was very difficult with Spice, is what I was using, because the high voltage is difficult to simulate. It was better to just build a quick prototype to show that it's working. And I was able to build early models of the Tesla coiled high voltage equipment before.
So P-Spice, you mean?
Yeah, right. The free Spice program for making models of the electrical circuits.
I was just curious. That's all I had.
Yeah, but in our WhatsApp group, there is some that have been studying it more from the theoretical and maybe done more with simulation than I have to show mostly the electromagnetic fields around the Graviflyer, which I don't quite understand, but from their results it shouldn't fly, basically, what the simulations say. So isn't that something new to the theory that needs to be added?
Yeah. Well, and again, Charlie, from what you've seen so far, you haven't seen any effect yet, right? You haven't, I mean, now, have you seen anything strange? Have you seen anything that might suggest that something is going on?
All the components are working individually, and I've been happy with receiving the kit. So nothing strange like that.
Okay, I wasn't sure. Well, I was thinking like some kind of weird, I mean, Lord only knows, right? But like a glow or some kind of discharge or something that might be like, hey, something's happening here. So.
Yep, I've been keeping an eye out for those. Just like the Hutchison Effects, what happens.
Yeah. Okay, awesome. Well, let me see. And Harold is here. Harold, don't be shy, sir. Harold had a question. There we go.
Thank you. I just have problem with this spectrum internet. But I want to ask if Charles, if he has done a free body diagram of the forces in the system and the physics behind the creation of those forces. I mean, the analysis, the super analysis is beautiful, perfect, great detail. Good job on that part. But what about the physics behind the thrust output?
Yeah, I myself haven't done the physics behind it. I'm more electrical engineering student, so I prefer to build and test the electrical components. That's why I focused on electrical, mechanical, and not so much the math and physics of it at this time. I believe once we get it flying, electric, then we'll be able to study it more and understand it better, the physics side.
Do you know if anybody has done it? Because so far, I came across an analysis by Russians about a few months ago, in which actually he claims that his analysis proved that Alexey's machine should not work. And that's what I'm wondering because, I mean, plastic marketing for Alexis is a great machine. I mean, he has opened a lot of doors. I mean, a lot of interest, and everybody around the planet is looking for that, the golden trophy, the working machine. And he has done a good job of that. So, which is good for the profession in a way. It stimulates a lot of interest. But that particular design, I mean, has anybody, do you know anybody who have done the physics behind it? Apart, from Todd Seattle, I know he made a good presentation a few months ago.
Todd's been working on that, but even his theory doesn't completely explain the function of the Graviflyer. Even in ultrasound, there's nothing in the physics or electronic books that would explain its interaction with the field. So if it doesn't work, then there would be new physics to understand why it's operating. And Ben Solomon is another professor researching Graviflyer. He's done some of the physics of why it might be lifting, and he was part of a meetup, Anti-Gravity Today or something. I've joined that group, but they haven't met recently, and they're trying to figure out the physics of why the Graviflyer would work. But there's still a lot of people speculating and not that prove why it should work. Right now,
have you tried out Dr. Paul Abbott, subquantum kinetics? He was here earlier. I think he's left. He was here earlier on. Paul Abbott, subquantum kinetics.
Yeah, his theory might explain, but I'm not familiar with that.
Yeah. Well, let me go. If it's okay, let me go to Theo, who has his hand up.
Yes, hello everyone. Just switching my video on. Thanks, Charlie. Great talk. Very interesting. I have a question concerning the bottom plate. Is there a reason why you connect this to the minus? I mean, it seems to be important. You have the minus below in the bottom plate, the bottom disk, and the plus in the upper one. Did the Russian guy tell you if that's important and why?
Yeah, he said it was important. What inspired him was he said the Earth is negative, and the sky is positive, and he wanted to repel the Earth, so he put the bottom plate as negative. But also, the lifter circuits mostly use positive on the thin wire on the top and negative on the bottom. You can get lift the other way, but it works better by having positive on top. So either just by trial and error or studying some of that theory, what led up to that. I believe that's the better way to go.
Thanks.
And thank you as well, sir. Let me go back to Michael.
So I'm curious. At one point, you were showing an IR imaging of the device when you were operating it, and I noticed that. So basically, there were a lot of places in the circuit within the device that appeared to be heating relative to the background ambient temperature. I could see the cooling effect on the edges, like you mentioned, due to the spinning of the disk. I worked in RF electronics, and in RF electronics, we use a lot of surface mount devices. And I saw a lot of the connectors and stuff you were using in there. They definitely were not surface mount. And those could be the points of your resistive loading that's basically causing it to heat up at the wrong place and make it so you don't have a sufficient field strength. Basically, it's leaking current. And so that's a good thing for, I think, you to look at is look at any of the internal circuitry where you're using where you're not following RF requirements for your interconnection. I'm curious. Do you have any experience with RF circuitry?
Yeah, well, all these circuits were designed and built by Alexey Chekurkov. I think he chose them mostly because of the availability of them. They're some older electronics, but they're more heavy duty and lasted over the years. So he's selected the simpler circuits to power the flyback transformer for old TVs and for the switching transistor for the Tesla coil, and also for most of those transistors he's using are at very high frequency, and that's when you're heating up. And he just solves that by putting that onto a heat sink. So even if you have circuits on it, it would.
I'm a little confused. What I'm talking about is the actual Graviflyer device. You were showing imaging, IR imaging of that, and I could see heat loading in some of the imaging. Specifically, it looked like it was in the ultrasonic cone that you had on the top there. It looked like there was something heating up in there. Why would that be the case if it wasn't due to basically a bad a non-ohmic connection is what I'm concerned about.
Okay. Yeah, the motors he's using are 12-volt brushed motors, like for fan cooling, and he's spinning them pretty fast, and they're designed to have a load on them. So he screwed on the plates, which have a charge, and there's backwards torques on that, so that's what's causing the motors to overheat. I believe that's most of the heat on the Graviflyer, where you're seeing. There might be some from the piezoelectric device that's resonating at very high frequency and therefore heating up, but I believe most of the heat you saw was from the motors that are overheating.
From the motor, and why was it look like it wasn't? It was offset to one side. It wasn't like central. It wasn't like in the middle. That's what. So basically, it needs to be symmetric. That heat should look like it's in a symmetric ring, not off to one side. That's what was I felt concerned about that, because that could be due to a bad connection, is what I'm saying.
Yeah, it might have to do with how the thermal camera works. So it's also using the camera from my phone, which is slightly offset, to compare it with the thermal camera that's connected to the bottom. And maybe when those two images are overlaid, it looks a little offset, but should be more symmetrical than it actually is in the video.
Okay, thank you. These are just some observations.
Okay, Michael, thank you as well. Charlie, that is a hardcore looking phone, and that's enormous. That is an enormous phone. Is that a Samsung? It must be a Samsung, right?
Yeah.
Yeah, it's giant. It's like, okay. So let me see, who else has questions? So Dawn had mentioned in chat that tweaking until something works can mask an accumulation time. And so that's something I'd like to speak to that a little bit. That's something that Mark and I and many other people, I'm sure Charlie, you're probably familiar with it as well. One of the things that we've all seen reports of are what are called nonlinear effects, right? Where they scale, and they tend to scale exponentially, and below a certain threshold you see absolutely nothing, and then once it gets above that, then it can become quite pronounced. So that would be to his comment. And then let me see.
Steve, that's a very accurate statement you made. That Steve made, and you made it better with your analysis, even better.
Oh, well, thank you.
And
The person that I got that from was laser physicist John Daring, who studied this stuff for many, many years. He worked with Dr. James Coram, and James Coram he retranslated Einstein's unified field theory. He did the 21 and 27 versions. They also worked with the guy who wrote the book, not William Moore, it was William Moore, and he worked with Charles Berlitz. They worked with the guy who wrote the book on the Philadelphia experiment. And so they tried to reverse engineer a ton of little projects, and they were also aware of several others. And one of the things that Daring told me again and again and again was, he said, all of these effects are nonlinear in nature. You won't see anything until it starts to happen, and then once it happens, it starts to scale very rapidly. So,
thank you.
well, guys, we have more questions. Okay, good. We're running ahead of schedule. Let me go to Michael next. Sir?
Hi there. So I agree actually with Michael Boyd about the EMF meter. There's a whole bunch of RF equipment it's like a probe. You move it around in space. You don't. Thing with oscilloscopes is you're going to get a ton of parasitic capacitance on the probes when you're working with RF frequencies. I mean, if you're working down in the kilohertz, it's not going to matter too much. But if you're using anything megahertz or even gigahertz, you're going to want an EMF meter. I also recommend the software-defined radio, SDR. There's tons of them on the web, and that will give you the whole EMF spectrum of things putting out in the megahertz and gigahertz range, and kilohertz depending on which one you buy. So very broadband thing that you can scan through all the frequencies that are coming off the thing. It's very useful for RF stuff. And let's see, the nonlinearities. It's not just like a build-up or whatever of some effect. You can have chaotic behavior where you've got some random thing that happens and goes away, happens and goes away. You can have all sorts of things with nonlinearities. It's not just like build up over an extended period of time. And well, I mean, we should expect there's a nonlinearity of some kind, or at least a way to create entanglement based on what our body was saying the other time. Those nonlinearities, you basically need variable capacitance and variable inductance. And really, I mean, I can see how the piezo gets you variable capacitance a little bit, but I don't see anything where that's changing the inductance. You might want to try like using spessartine garnet or something, which is slightly paramagnetic, or you can use pure gadolinium, something that's paramagnetic that won't have a loss tangent. Gadolinium oxides. Point being though, you're going to want to look at nonlinearities. You're going to want to try to create nonlinearities. And there's probably some nonlinearity in the system that you're looking at. Probably a mechanical thing, I'd have to guess, if the ultrasound has anything to do with it. But beyond that, you're going to want to get yourself the NMR spectrum of aluminum and steel and all these things, and the EPR spectrum if you can find it, because then you'll be able to see the frequencies where you've got a nuclear like an NMR or EPR response in the aluminum, and that can help with NMR entanglement at room temperature with macroscopic objects. So that's a way to create entangled states that might have participate in the effect. If it's gravitational, if it's something else, I don't know. But the piezo doesn't seem to provide enough power to produce that amount of lift. If it's just like air or pressure waves or something, and I don't see how the spinning magnets do anything just based off of that. But yeah, I mean, just some ideas of where to go, what to look at, what to think about on the theory side, and that'll hopefully help you direct the experiments a little bit.
Yeah, thank you. Yeah, I'm going to stick with Alexey Chekurkov's design for now, but I have a few ideas of how to improve and test different designs.
Yeah, I mean, at least get the NMR and EPR stuff. That'll give you some idea of where to look in terms of frequencies to operate stuff at.
Definitely check the fields around it. Yeah, there's no difference.
Yeah, thank you. So let me go to Tyler next. Tyler, go for it, sir.
Hey there. I apologize, my camera's inoperable at the moment, but my question is, as far as the mechanical operation of the system, how important is the balance of the rotating mass as far as excess harmonics that can affect other parts of the system?
Okay, good question. As Alex Chekurkov's design, he hand cut the plates, and they're not well balanced, so there's a bit of vibration caused by that. I'm not sure if that vibration is needed to create the lift. Some people use laser cut. It's much smoother when CNC or laser cut materials are used. So it's still unknown right now if that little bit of wobble is needed for just defect from its
Yeah, Michael just posted in chat that mechanical vibration could create non-linearities, and and then who knows? Maybe there's an overlay. Maybe there's some kind of a beat frequency with the ultrasonics, right? So, okay. Well, let me see who wants to go next. Does anyone else? There's Nils. Nils, go for it, sir. Oops. And I think Nils I think we just lost his connection. Does anyone else have questions? There's Theo. Theo, go for it, sir.
Yes, maybe this. I hope you can listen to me. Just one observation. In one of the videos, I saw the device floating in the air. There was no vibration. It was kind of static, which was very weird. You know, when you have a helicopter or an airplane somewhere in the air, there is some moving. But that thing, when it was testing that there are no cables around it, that device was like stuck. It was not moving. So that was for me kind of very strange. It could be an anti-gravity effect because it's another space-time continuum. But if you really look at the video, it's really like, not vibrating as you see it on the floor. So maybe that gives some thoughts. Thank you.
Good point. Yeah, I'm not sure what happens when it looks up, but it looks like it is more stable. It might look much like a electromagnetic lift, like a maglev trains. They're very stable.
Yeah, it looks like locked. You know, when there is this magnetron, this little thing that you can spin, and then it has magnetic field against the opposite magnetic field, and it levitates. The levitron, I think it's called the levitron. And when that thing is moving, you can see it spinning a little bit like unstable. But this thing is just there, sticking in the air. That's amazing.
You know, Theo, that's an interesting comment. That reminds me of the lifters. The lifters were the same way.
Right.
They had kind of their own inertial. They had their own inertial field, you know. And with the lifters, we had them tethered, but I noticed they resisted motion. They would resist air currents, right? If air current was trying to push it, it would resist that. You could take a stick and touch the tethers, and it would resist change in axis. So yeah, with Alexey's thing, it does seem like the same thing. And then the other thing that I've noticed is in his videos, there is some kind of, it looks like a discharge time, right? When he turns it off, you'll notice there's a lag before it drops. So
it's like a gravitational locking mechanism. It's like you have the static Earth's gravitational field, and then the device locks into it. And that's why it looks like it's static, because it's not subject to like vibration modes, and it's not subject to the wind or anything like that, because it's like locked into the gravitational field. So, but it's not, it's levitating. At the same time, it's levitating. So,
yeah,
I saw that effect too, and I think that's that shows that there's some kind of something's being aligned there between the magnetic and the electric fields, along with the gravitational fields. That's why, in this case, I think what's creating your gravitational energy is actually the ultrasonic source.
Charles, do you think that there might be ion wind effect produced by the middle plate in combination with the ultrasonic and the magnet going on? Have you considered or measured anything in that area? Ion wind, just at least a small portion?
Yeah, I've done other lifters, and those use much higher voltage grade lift, and this device weighs about 1 kilogram or 2.5 pounds, so much heavier.
Yeah, Harold, if I could jump in, an ion wind may contribute to some other kind of effect, but there's from experience, there's no way you can produce enough ion wind with that device to actually levitate it. I mean, ion wind does a few ounces, at the most.
I agree with that because if it does, it would be, major discovery, large amount of ion wind. Probably a small percentage, like you say, is agreeable, unless otherwise, Alexey explained there is more. But what you said is reasonable. Thank you.
Let me go back to Nils. Nils, go for it, sir.
Can you hear me now?
Yeah.
Yeah, sorry, I had my mic turned off. Apologize. Charles, have you heard of the term cargo cult science? Sorry. Okay. In 1974, Professor Richard Feynman held a speech on how some people, they try to go straight to the end result and skipping the middle part of the processing the theory and the physics of how something works, and you always end up with nothing if you do that. There was a small tribe of humans on the Pacific Island somewhere during World War II, and they saw the American cargo planes coming in with supplies to the military, and they wanted to copy them. So they built airplanes out of bamboo and grass, and headsets out of grass straws and things, and they were hoping to, build something that would allow them to get food from the aircrafts coming in from the sky. So back to your Graviflyer, if you're trying to just put together a device with a bunch of parts and some instructions, isn't that really a very, very inefficient way of going about things? Shouldn't we be spending the time trying to understand the physics and the principle and build a hypothesis behind this device before we even get to adjusting the frequency of the Tesla coil or anything else? That's my question.
Yeah, that's a good point. I heard that a lot. There's a lot to say. Physics should be kept up first. Even my dean of engineering said it was up to the physicists to first come up with theory before experimenting with it. But I said we've already got a working device, so let's test that and then measure it and come up with a theory to explain it. But there's several cases where first discoveries have been made and then the theory comes later, like the heavier than air flight of the Wright brothers flyer, the Wright flyer, was something that theory, was on the fence if it's possible or not, and there wasn't much to explain it. There's a few aerodynamic theories observed from water tests for that, but in this case, I believe there's first the device will come first, and then the theory will later explain. There might be some theories already out there that do explain a little bit.
Yeah, no, I agree totally. But there's so many moving parts in this device. You got the ultrasound, you got the magnetics, you got the high voltage. Shouldn't we just focus on one part and then see if there's some effect that we can measure and produce a hypothesis around that?
But there are some groups that are doing that. Odessa is an example.
Do you have some links to any of those groups?
Sure. Subscribe to the channel.
Yeah, I've been doing some work on this electrogravity for years, and I think the effect we're seeing here is a B cross B field effect. It's a divergent field, but I'd like to see what your contacts are saying about the physics or the principle behind it.
Yeah, I believe those warp drive tech. Was that in the?
Yeah, that's Todd's, right? I think that's Todd's.
Yeah, he's doing the approach of bottom up, where he's testing each part individually to see if that's creating the lift, or the top down approach where I bought the kit and just full setup.
Let's so if it's okay, let me go to Mark Sokol next. Oh, it's Aiden. Okay, yeah. Sorry, Aiden.
It's fine. Mark's disappeared from the lab for, but the backtracking a couple minutes ago, we were talking about the ion lifters and the stability. That brings to mind the 1952 Kingman, Arizona UFO case where like a vehicle came down and it had they sent out a recovery crew, but it was still powered, and they were having they were trying to pick it up and then tilt it, put it on a trailer bed. But as they were trying to tilt it, the vehicle resisted, and the crane ended up pulling itself up off the ground. So there's flux pinning from within the vehicle, and that the crew of the vehicle had to go in and power it down in order for them to load it onto the trailer bed and take it into the deserts of Nevada. So one of my aerospace mentors has been on this. He's talked about that. He said that there's in more advanced vehicles, there's some sort of flux pinning that's going on, which keeps it oriented. And then the other term that has come out of my research on ufology is like gravity envelope. So perhaps the field stability or the vehicle, when it's in resonance, is creating this gravity envelope. You're seeing macroscopic flux pinning around it, which would describe describe that stability that the platform, Chekurkov's platform, seems to exhibit when it's up in the air. So that's what I wanted to throw in.
Yeah, good point. I know with superconductors, on very cool temperatures, you get that flux pinning. So there might be something what's happening at room temperature.
Yeah.
Also, some of the go ahead.
Oh, it seems to be like some sort of macroscopic Cooper pair with the counter-rotating discs. So that would be part of what's going on. But anyway.
Yeah, Bob Greener studying Hutchison Effect mentioned ball lightning and objects inside the ball lightning, like the sand and water, are unaffected by the temperature, time, and even the gravity around it. So maybe something like that's happening. There's a field building around it that's taken out of the gravity field of Earth on it.
Okay. I don't know. That's just why I wanted to put that into your discussion. So, okay.
Yes, well, Eden, thank you. So let me see, who else has questions? We've got about 15 minutes left in our Q&A session. And if we run out early, I'm sure Mike will grace us with beginning his presentation early. So but let's see.
I have a question.
Yeah, go for it. Yeah.
So I'm curious what you were talking about what the rotational velocity was of the two discs.
About 2,500, they're counter-rotating, so almost around 6,000 RPM.
So, but do you know what the linear velocity? Could you measure the linear velocity, say at the edge of the disc? If they're actually spinning, how do you know they're spinning counter to each other, the same rotational velocity?
Yeah, these DC fan motors only spin one direction. You just plug them in first, so they only spin. So they're the same model. So they're spinning the same, and they're connected in parallel. So the same voltage and currents going to each of them. And they're rated about 3,000 RPM each. And that's how we know. I have a tachometer as well that could measure. I need to put a reflective tape on there. Alexey drew some Sharpie on the bottom to get a dark band on the reflective plate to measure the frequency and measure around 3,000 RPM.
So is there a dependence on the rotational frequency of the thing?
Yeah, that's a good question. Yeah, I think too fast, you won't see the results, and too slow also. So, but in his circuit, he had it going full speed, 12 volts directly to the battery.
So in my experiments with my invention, there's I was using linear velocity, and in my case, I was doing inches per second. As most of the measurements were at 500 inches per second. And the reason I did it that way is because the nano bumps and nano bits that were on the radius. So I was on inner short distance of the radius, I wanted to maintain the velocity at a constant value. And then I also did it up to like 890 inches per second. But essentially, in my case, there wasn't really much effect on the magnitude by the speed. It had more to do with the size of the nanobump or nanobit. So in any case, I think there's some importance there to make sure that both disks are synchronized. And then I'm curious if you considered some kind of variation in the speed of or tried it at different rotational speeds, essentially.
It's Chekurkov. Yeah, its design has the potentiometer for adjusting the speed of the motors. Mostly because when they first start, there's a bit of a backwards resistance to magnets on the bottom discs, so you better to start at a lower speed, ramp up to 12 volts, actually until a full speed. But I believe you're right that the size of the disc, man, that's why I went into detail of what the kit size was about 8.5 inches. So that would be able to reproduce it better. And I think at smaller scale, there'd be a lot less charge on the plates versus the larger size discs.
But the weight would be less, right? So there might be a sweet spot for that. Yeah. So okay, well that's thanks again.
I hear some background noise now. Little one waking up.
Yeah.
Well, let me see who has questions next. We have about 10 minutes left, and again, if we don't have any, we can probably go to Mike. Oh, there's Nils. Nils says nothing. Okay, go for it, sir.
Just a very quick question, Charles. Where are you going to put the links you mentioned about the YouTube playlist and your contacts to the guys doing research on the physics, on the principle?
I have the links in the chat here, but I can also share it.
Did you post it in the chat to everybody, or
APEC on Zoom?
On yeah.
It's been a big file, maybe still download.
Oh, maybe that's it. Yeah, I'm not seeing the links either. So
I could open it and just copy the link page.
so should I just wait until the link is prepared?
yeah. I think he's still working on it.
Yep, so that's the YouTube from Alexey, Facebook, my YouTube, my Thingiverse, and Google Drive is the last link. Probably what interests people the most, has more detailed pictures, parts list, and video of me getting the kit first.
Wonderful. Okay. So let me see, other than the links, and I know he's working on those, does anyone else have questions?
I do. I have a question.
Hey, Lulu.
Hi, everyone. How's everyone? Happy New Year. I have a question. Your meter, like your the one that's Michael's telling you to download the app, and so you can run the program so you can see the frequency, the oscillation of the frequency, right? Well, when you're downloading the app, aren't you somehow like connecting to the outside world, which is the net, the internet, the world? And if anybody has any counter program, you're just like giving off information that, hey, I'm working on this, and now I'm downloaded the app, and gives them a trigger. So it can't be connected to the internet. It's got to be connected to its own computer. If you really, something that's not connected to, anything else. So you get real readings. Otherwise, you don't know if the readings manipulated by the app or by the internet connection, or Wi-Fi band, or and there's so many different variables once you plug into the world. So you have to have it in your own system first, and then compare it with the outside system. outside systems, all these little gadgets that you need, you know, to connect to some outside server to, you know, to have it work. I mean, you don't have the server, you don't have the control, you know, like it's just giving it into somebody else's hands, you know, everything. You know, you worked very hard for it, and, you know, for these big companies that, you know, have warehouses on running these, you know, different modules and these different operators. You want to have your thing, don't do it that way yet. Do the older technology. Like, you know, they like the other day, I saw this on Facebook, like an oscillator, $50 or selling. It's like something built in, you know, maybe 1980s, maybe. I mean, just ones that work on, you need stuff like that first. And then, you know, you go to the modern day and you cross-reference. And, you know, these things also have a core, like an oscillation core. The older ones have the pure stuff in them. Here now, the newer days, it's just, you know, commercial mass production. There's not any more, you know, extreme. It's just a machine that, you know, runs all of these. It's a block, you know, like there's no pockets. There's no variables. Old stuff work way better. You know, there is a human touch to them. It just, you know, keeps it more personalized. It keeps your invention yours, not everyone else's. You know. Anyway, but just start with your stuff first. Don't give it to the world yet. It's good.
Thanks. I'm not sure about this model, but I think the signals recorded from this could be viewed offline. I'll have to double check to see the app. That'd be good to double check that it's offline to make sure nothing's changed before uploading it, checking with an app that's connected.
Yeah. Well, yeah. Thank you, Lulu. So let me see. We got about 5 minutes left. Do we have any more questions? And every time I ask this, we have one that pops back open. So. Oh, there's Niels. Okay. See. Okay. Go for it, sir.
Okay. Charles, we're still not seeing the links in the chat. Can you just post your email so I can send you a message or something?
Sure, it's shavec2@yahoo.com. Yep. I know YouTube blocks other people from posting links. I'm not sure how Zoom does that without admin control. Maybe that's it.
Yeah.
Maybe I can send it to
you know what? Let me find it because I have it written down.
it is. Yeah, I can see what it is. It's up to everyone.
Yeah, that was my worry. Okay.
There it is. Let me post that again.
I will put that in there as well. Yeah. Yeah. Oh, and now, actually, Charlie, if you can post the links now that you've got it set. There we go. Perfect. Perfect. We're cooking along.
That's what it was.
Okay, so I think we are just about there. We've got about 4 minutes left. And, let me see. Gordon Hughes raised his hand. Gordon? Let me ask Gordon. Gordon, did you have a question, sir? Okay, it looks.
Yeah.
Oh, perfect.
Perfect. Yeah. Happy New Year, folks. Just a general question. Where do you need to be, and what do you need in terms of sort of resources going forward to actually get this thing to maybe work? Is there a plan going forward that you need to get from A to B from where you are just now that will actually produce some sort of result with this? What sort of resources do you need? Yes, was it need a set of and lab stuff and that type of input, or maybe some I know up in the stuff earlier saying it might be useful to use some of the folks that are involved in this channel, like Mark or other people and some of the expertise they could bring in from sort of lab side of things and doing, sort of experimental work that might be able to not interfere with what you're doing, but maybe put some sort of add-on to what you're doing that could maybe produce a result. Because at the end of the day, that there seems to be something there with this. The question is, does it do what it claims to do? The only way you're going to be able to do that with that is probably with additional resources, not where you are now.
Question. I'm currently working with Mark's team development space. We have a weekly meeting. We'll be to talk more about the updates and then question and feedback. So I've been testing myself, but they've also got their versions of Graviflyer they're building based on the schematic designs I got from my kit. So we're all continuing to work together on that. And mostly I'll be building testing by myself for now, and then building a newer version for some slightly some changes and testing two simultaneously.
Wonderful. Okay. Well, and so guys, on that note, it is just about 2. So Gordon, thank you, sir. And what I want to do here is, in fact, I'm going to mute everybody out right now. Okay. And I am going to put this on gallery view. Everyone, please give Mr. Charles Crawford a giant hand again for a Q&A session and a wonderful presentation. My apologies for the audio quality of the presentation. At least we got that fixed. I think that we know now we should probably have electronics turned off as much as possible. I didn't, again, Mark Sokol figured that one out. I missed it. So let me see. Now we have Mike Gamble with us. He is going to be presenting now. Let me see if Mike is ready. I will do ask to unmute. And you know what? Before we do that, let me do an intro. So Mike Gamble began his engineering career as an auto mechanic, later earning his bachelor's degree in electronics from Northrop Institute of Technology, where he graduated magna cum laude in 1978. He was recruited by the Boeing Company to serve as the principal electronics engineer for the next 30 years. In that capacity, he worked on a range of classified and unclassified projects, including commercial aircraft, military aircraft, and aerospace systems. His last company position was managing a Boeing research and development lab, working on a variety of traditional and exotic aircraft and aerospace technologies. So Mike is now retired, and he is a widely published author on energy and space propulsion systems. He's pursuing his hands-on love of engineering through select citizen science projects in his home lab. He and his wife, Ellen, are 2 proud parents of college-age children as well. So he is living the life of Riley, and he joins us now to talk about Tesla's Resonant motor. Mike, are you ready, sir?
Yeah, I think so. Before I get going there, Bill Alex has been waving his hand with questions. You guys been missing them.
Oh, I haven't seen. I have my screen set because I have to record, right? So I can't see everybody. It only shows me a few people. But maybe he can put those in chat for Charlie.
Well, you got a couple of minutes. If he's got a question, go for it.
Well, Bill, did you want to wrap up one final question for Charlie?
I just wanted to. Can you hear me? Okay.
Yeah.
Okay. Yeah, I just want to mention in our research here, we noticed that these type of systems, they have to be in resonance. Okay, so that maybe Charles' device there and the Russian maybe achieve this resonance action, because the phenomena occurs when your system is in resonance. If you fall outside of resonance, the effect completely vanishes. But when you're in resonance is where the effect occurs, and you have what's called the scalar effect, okay, that Tom Bearden spoke about. And that's where it emerges, when your system is in resonance. And the scalar effect, when you do the mathematics of this, it doesn't show up under conventional mathematics. Okay, it's you have to go to the old physics, this quaternion math that Tom Bearden spoke about, where the effect, the scalar component emerges. And when you work out the equations using this quaternion math, guess what? The system works. The scalar effect is there. And you can actually see it on your oscilloscopes. Okay? Now, the thing is that when you start loading down this effect, it shifts the resonance. And when your resonance shifts, it becomes a conventional system and your effect completely vanishes. Okay? So maybe in these lifters or in this gravitational device, these type of devices where the effect emerges, your system has to be in resonance and you have to be able to track that resonance. Okay? So I just wanted to make this comment to Charles that this type of device would have to be a resonant system. You have to be able to track that resonance. It's real tricky to do. Okay, tracking that resonance. And I think that's maybe what has to be done in this case. So I just wanted to make this comment about that.
Bill, thank you, sir. Okay, so now let's so we have that one. Let me jump back to Mike. I already did the intro. I want to just hand it right over. Mike, it is yours, sir.
Well,
Bill, thank you again.
I'm going to build on that a little bit more here. Since my last presentation on linear propulsion there, where I did some documentation on the German Hathaway, I got a lot of emails from you guys about that. I'll give you a little history on it. I spent about 3 years researching the lift mechanism and running simulations on it. And it shows that the EM propulsion system would work. However, I don't have any blueprints of the craft ready for building, so you're going to have to put in a lot of engineering if you're going to do that. But I would encourage anyone that wants to play with high voltage and high frequency to try and build a demo model of it, the lift mechanism. And like we've been discussing, the one key point you're going to run up against is tuning or resonance. The Hathaway and the lifters you're playing with, along with the Tesla motor system that I'm going to document here in a few minutes, they all operate on this resonant principle. And the object of the game is to hit the sweet spot between frequency, phase, bandwidth, and Q factor. And that's what I'm going to talk about a little bit more on the resonance, so it might give some help in that area as well. So let me get this thing booted up here. Oh, lost it. Screen share. Where are we? There we go. Okay. Slideshow. Can everybody see that?
Yeah, it looks great. And so this is not in, let me see, this is not slideshow mode, right? And I think that's okay. If you do play from beginning, that might solve it. That's the top left button.
You're breaking it up, but okay. You want to go back to this one?
Oh, no, there should be a button. If you click play from beginning,
That's what I did. It's in slideshow mode, and right there is from the start.
Do you have multiple monitors, Mike?
No, I only got one.
Oh, okay.
That becomes two.
Okay. Well, yeah. No, I'd say let's do it. Let's do it. Yeah, I think it works like this. So there we go.
Okay, if you can see it, I'll start then. Anyway. This is on my research. After I retired from Boeing, I started doing research on the Tesla's fabled electric car, and I entitled it "Batteries Not Included." Anyway, this presentation, it's basically standard reverse engineering. I don't do anything funny or just standard procedures. Basically, it's in 3 parts. The first presentation is background material on radio systems. The second is on reverse engineering of Tesla's car motor. And the third is building a demo model based on the results of that. It's a little bit long, it's about 100 charts. Hopefully I won't bore you with all the details. I kind of get into the details being an engineer. I'll start with basic radio. This tutorial here is 2 charts on background material for understanding electrical systems and resonance. Basic radio, you have 3 parts. First, you got the transmitter, which is a wave generator or source. And second, you got the transmission media, which is your wave conductor. And third is the receiver, which is the wave producer or sink. And engineering definition is if the receiver is working correctly, it gives a good reproduction of the transmitter's signal. However, most people just turn the radio on, the rest is all black magic. We'll start with the transmission media here. Over time, this has been called various names. Around here, most of you guys use the term ether. It also has gone by essence, space, cosmic carrier field, electromagnetics, or if you want to go over the religious side, the heavens or the water. However, they all point to pretty much the same thing. Digging a little deeper into it, it's pretty much a lossless elastic medium of infinite strength through which both matter and energy pass. It has both scientific and religious aspects, and only some of the properties are measurable. In this case, you got the permittivity, permeability, and resistivity that are documented. Moving on to the radio receiver. It's the most basic circuit here. It's crystal radio. It got its name from the germanium crystals that they used to use for the detector. However, nowadays you can build it with silicon diodes. I used to build lots of these when I was a kid. But it's got basically 4 parts. You have the antenna part, tuner, which is the resonant circuit, the detector, and the output, in this case, is the headphones. Normal radio design adds a couple more sections here. You have an intermediate amplifier and an audio amplifier, and that makes a transistor radio, which has enough power to run a speaker instead of headphones. But the interesting part here is the MATLAB Bode plot of the resonant circuit gain and phase. This is what you're going to be dealing with. It doesn't matter what type of system you're doing, it's on the resonance. The sharper the point, the narrower the bandwidth, and it's easier to miss. However, you get higher gain. And the other system is your phase crossovers occur right at the maximum for both the voltage and the current. And that is a very tight resonant point. I'm going to show you a few other charts where it's a little more sloppy. This particular one is the center of the AM radio band. And the inductor is 4 microhenries, and the capacitor is 6.3 nanofarads. Input current is 100 microamps, and the resonant voltage is 40 millivolts, and the resonant current is 2 milliamps. So Q factor is the resonant current divided by the input current. So this system has a gain of about 20, which is a very high Q system. Getting back to Tesla's work there now, he didn't go in that direction. Basically, he only used the tuner and the antenna. He gets rid of the detector and the output stages and swaps out an inductor with an electric motor rather than a fixed inductor. And then he reduced the operating frequency down to, from radios with about megahertz down to power frequency, which is 60 hertz. And then he increased the power levels from milliwatts to kilowatts. And this chart shows his basic resonant patent way back in 1901. And the first cut shows the motor and the capacitor is similar. However, there's differences. In the patent, he uses the old terminology, condenser rather than capacitor. He uses mica for the high stable dielectric. Polycopylene works much better nowadays. And we may need a transformer for impedance matching in the middle of it. That's to be determined yet. And you use a mechanical device to do the chopping of the circuit. We call it an interrupter or switch. I'd use a PWM chopper circuit, which is all electronic, does the same thing. And in the next process, we'll take a look at resonant tank circuits on basically how they work for resonance. This is electrical schematics. You have an inductor which has a series resistance, and it's shunted by a capacitor. Now the input current just goes straight through the inductor, and that starts the resonant system. The resonant current only goes back and forth in this loop. So you have to have a little bit of input current to start the resonance. Now the resonance is the main current. The Q factor determines the ratio between the two. So you want a small input current and a very large resonant current to make the system work. The math equations are over here. You have the resonant voltage divided by the capacitor impedance equals the current. And in the inductor, the difference between the input current and the resonant current divided by the impedance of the inductor, and then I use S-plane for the Bode plots and all that, which is equal to the omega frequency, which is 2 times pi times frequency. And from that, you get the 2 equations, and then next chart. Where'd we go? Yeah, there it is. You can.
So, Mike, I'm sorry for interrupting. You're still stuck on the slideshow. Maybe did you share a window? Maybe you shared the wrong window. It looks like it's still stuck on slide number 1.
Uh-oh, I wish you would have told me that sooner. Hang on.
I'm sorry, sir. I didn't get, somebody mentioned it in chat. There we go.
Okay, well, we'll go down the list this way then. It looks like we're not working on slideshow mode.
Okay, that's the problem. Yeah.
Okay, let me see if I can make this a little bit bigger. And we'll just go that way. And we'll just run down the list manually then.
Yeah, I'm sorry about that. Somebody mentioned
I
that
should
chat.
back up because you've missed
Okay.
You've missed a whole bunch of the stuff.
Yeah, go for it. No, just go back. If you want to start over, that's also fine.
Well, I'll start right here. This is basic radio theory. You have a transmitter and a receiver and a medium. This is flipping now?
Yeah. And now it's on transmission media.
Yeah, okay, good. Then we'll just keep going. Transmission media, basically, it's been called various names through time. Ether is what you guys use most of it. It's also gone by essence, space, cosmic carrier field, electromagnetics are over on the religious side, the heavens or the water. Digging into it a little bit, it's a lossless elastic media of infinite field strength through which both matter and energy can pass. It has both scientific and religious aspects, and only part of its properties are measurable. In particular, the permittivity, the permeability, and the resistivity. And then we'll go to radio receivers here, starting with a crystal radio. And the 4 basic parts, you have the antenna, the tuner, the detector, and the output. Let's see, where are we here? I gotta manually advance this. Okay. There we go. And then to get a regular radio, they add a couple more stages, intermediate frequency booster and an audio frequency booster, and you get a regular radio, and it runs the speaker instead of the headphones. But the primary part here is the tuner and the antenna system, which we're going to talk about. This was the most important chart in this section, is on resonance. This particular one is the middle of the AM frequency band, which is megahertz. And points I want to show is when you have a very tight Q, in this case it runs at 20, the phase shift, both the voltage and the current all line up at the maximum points. The red is the voltage, the black is the, or I got it backwards, the black is the voltage, the red is the current, but they all line up and the phase shift is there. Now, it has a very narrow bandwidth, so it's easy to miss. And when you start off, it starts with just a rounded edge, and as you tighten the Q up, it goes to a peak. And then the bandwidth narrows. That's one of the key points of resonance that you want to work with. Now, what Tesla did is he threw out most of the radio and just worked with the resonance circuit and the antenna. He substituted a motor for the inductor. Now, one of the problems with a motor is it doesn't have tight Q, so he had to do a little bit of work there to make the resonant points. He also lowered the frequency from the radio frequency, which is megahertz, down to kilohertz or down to power hertz. But he upped the power levels from milliamps to kilowatts. And this compares very closely with his original patent. However, the nomenclature that he used for here, he used what's called an interrupter, which was a rotary mechanical switch. He used condensers with dielectric. Polypropylene works much better nowadays. And then we're going to start the tank circuit. This is about where we had problems here. On a resonant tank circuit, you have the input current that flows through the system, just through the inductor. That initiates a resonant current that goes between the capacitor and the inductor, and it just bounces back and forth where the other one goes through. So you need a small input current to go through the resonant circuit to start it, and then from there, the resonance takes place. So you want a small input current and a very large resonant current. These are the two design equations, one for the capacitor and one for the inductor. Only the resonant current flows through the capacitor, but the input current and the resonant current both flow through the inductor. And then I think this is where it dropped out on me. So, okay, you have two equations here, resonant current, resonant voltage, all off the input current. So you have the inductor and the capacitor equations there for the design. And then when you start plugging in the numbers from MATLAB, starting with 4 amps input current, 7 amps, 10 amps, 12 amps, holding at 60 hertz. Your resonant voltage, you get 21 kilovolts, 12, 8, 7, and 6. Now, the two that are highlighted are your power line frequency, 12.47 or 43 kilovolts or 7.25. That's Tesla's design for the power grid. And as you see, resonant current starts increasing and the inductance goes down, the resistance goes down. However, the inductor or the capacitance goes up because you have to maintain the resonance. Now, this is one of the more sloppier ones. As you see, it's not a nice pointed peak, it just rolls off. And then the one is resonance, the other is the current. And the crossover point is down here, so the phase crossover isn't even at the operating point. Like I said, it has a very low Q, so it's what I would call sloppy. Okay, taking the same numbers and running them in the Simulink, that's another one of the engineering tools. I use MATLAB and Simulink a lot to test out my working models. When you put those in there, you put in 12 amps, 60 hertz, and you get the 10 kilovolts out at the 15 amps. And then going along with that, you have to have high voltage capacitors to work with it, all the way from 20 kilovolts to 60 kilovolts. As your input current goes down, you have to make the resonance work harder, and the voltage goes up. Okay, the conclusions from the tank circuit. The small input currents will generate very large resonant voltages, but not very much resonant current. The voltage is higher than the current gain by about a factor of 100. And the resonant frequency, up here, is determined, and in order to make it go, you have to do matching. So we may have to put a transformer in there in the middle, which is the next section that I'm going to talk about. So we've talked about the radio part a little bit. Now we're going to get into the reverse engineering of Tesla's design. And for those of you that haven't heard, it's rumored in books and stories on the web that Tesla drove an electric-powered Pierce Arrow back in the early 1930s. What I did, I took a few of those stories off the web and looked for any facts or truth in them that would make a engineering drawing or specifications. So couldn't resist this picture. This is a 1931 Pierce Arrow, the car that he motorized. His quote there from 1892 that electrical power is everywhere present in unlimited quantities and can drive the world's machinery without coal or gas. That was his dream, I guess, to make it go. And he certainly thought it was possible to power a car with that system. So digging into the stories, I got 4 stories off the web there. And you're probably going to get tired of hearing it, but we'll start with, it says in the summer 1931 there, Tesla got an alternating current holder of the patents, and his nephew, they went to Buffalo and installed an electric motor, 80 horse and a Pierce Arrow. And all the red stuff there is data that I highlighted that would be engineering material. And so they had a black box, 24 inches by 12 by 6, and had a 1.8 meter antenna, a couple of metal rods, and a dozen vacuum tubes in it that he used. And it ran a motor 40 inches long, 30 inches diameter. And the story goes that Tesla inserted the metal rods and announced we have power, and then proceeded to drive the car. And then we go to the next story, which the details are a little bit different, but the overall part is pretty much the same. This story has one gross error there. Tesla didn't work for General Electric. He worked for Westinghouse. Him and Edison didn't get along. But anyway, it says he took out the gasoline engine and put in the 80 horse alternating current motor. No external power supply. At the local radio shop, he picked up a bunch of electronic stuff, put it in a box, 24 by 12 by 6, and fired it up, and they went driving around. And then we go to another story here. Each one has a little bit of different details on it. This particular story here mentions that it's got special tubes, and that he had to use the 12-volt battery in the car and electric starter because it wasn't a self-starting motor. And skip to the last one here. This one mentions the 240-volt motor operation and gives the dimensions in metric. Probably get tired of the story, so we'll dig into the details. I lost the cue. Went too far. Let's see, 31. I'm down at 40 here. And there we go. Okay, so taking the highlighted data from those 4 stories and trying to piece together some engineering specifications from them. This is what I come up with. 80 horsepower AC induction motor. That translates to about 59.7 kilowatts or 74.6 bars. 1800 RPM at 60 hertz is a 4-pole motor. It says it was fan-cooled, external sealed housing, and it only had 2 leads coming out of it, so that'd be single phase. What it doesn't say or didn't come out is it's either high voltage or high current for those heavy wires. It did say it wasn't self-starting, so he only had the run coil, which is what he resonated. The problem is if he had the start coil, the minute the start coil would kick in, it'd throw it out of resonance, so it wouldn't run anyway. One of the big unknowns is the power factor on the motor. Going to more modern data, power factor varies from about 0.75 to 0.8, so I picked the middle of the road about 0.8. If he's running at 240 volts, he's going to be pulling 310 amps, which is pretty thirsty. If that voltage went up to 480, he'd be down to half of that, about 155 amps. Now the dimensions of the motor, as listed, was 1 meter or about 40 inches and 65 centimeters or 25 and a half inches diameter. Plugging these into the electric motor equations, to get the running resistance, you get the voltage times the power factor divided by the current, you get 0.6178 ohms. Inductance is a little bit different. You get the voltage times the sine of the angle divided by the omega frequency divided by the amps. You get 1,229 millihenries. Horsepower comes out to be volts times amps times power factor divided by 746, which is 79.9, and RPM at 60 hertz, and 2-pole pairs is 1800. And when you put all this together, you get the running impedance of the motor for both 240 and 480. Comes out to be 0.771 ohms, or with the motor 480, it's 3.096 ohms. And then the next chart is on pole pairs and 60 hertz operation. Now I highlighted 60, assuming that's what he was running at. However, you could run at 90, 120, or 180 hertz by changing the number of pole pairs in the engine. Now, for comparison, the closest I could find was this motor. The problem is nobody builds single-phase motors greater than 15 horsepower anymore, so that 80 horse would be a orphan. Standard electric motor sizing nowadays goes in 50, 75, and 100 horsepower ranges. So the closest one is this 75 horsepower, 3-phase, 1800 RPM fan-cooled ball-door motor. And the nameplate says power factor is 0.87, it's 3-phase, runs at 230 at 169 amps, and 460 at 84.9 amps. Which of course is much lower current than single phase. However, it gets you on weight. The weight is 907 pounds, which is about twice the weight of a gas engine. Looking at the mechanical specifications, it's 27.6 inches long and 19.1 inches in diameter. Comparing that to Tesla's motor of 40 inches and 25 diameter. The diameter is close, but it's about a foot shorter. So, the differences on that might be older technology, or you might have included the transformer down in the motor housing. We're left with 3 unknowns here, which is the input frequency, the operating frequency, and the power factor. None of those stories mention anything about that, so there's a few unknowns you got to fill in. But, going on the design. Now take a little detour to her here on the impedance matching. Like I was saying, there's a possibility we got to throw a transformer in there. Dealing with standard utility transformers, like I said, 7.25 and 12.47 kV are standard power grid frequencies, which is also Tesla's design. And these were all built by Westinghouse. They're 240 volt center tap transformers from 5 kVA to 100 kVA, so that would be no problem for him to pick one right off the shelf. Doing a little detail on design on transformers. Your output voltage is a function of the input voltage divided by the turns ratio. And the current is just the opposite. The output current is increased by the turns ratio, and then the output impedance is the input impedance divided by the square of the turns ratio. So, depending on what your input and output impedances are, you can balance those with a transformer. Digging down into some of the details, now this is looking at from the low power side, the 725, 310 amps on the output and 10 amps on the input, 240. Calculations show 2975. The brand name or selling point is 30 to 1, and for 480 it's 15 to 1, and the calculations come out pretty close to that. And in doing the comparison between the numbers here, calculate the numbers, 7.5 kilovolts, 30 ratio, it's 238, which is close enough to 240 to run. For the current, 313, 311. Now, this is it a little bit on the impedance. This comes out at 0.98, and the other one is 0.77. Now, as you raise the voltage up to 480, it gets a little closer. The voltage comes closer, the current comes closer, and the impedance comes much closer. So either one of them is close enough to run, so the system will still work. Now, loading this up into MATLAB and running the coding plot on it, as you see, it's not a very tight queue. It's very wide bandwidth, and it doesn't line up very good. The main point is the difference is maximum here, the maximum there, the crossover points there. However, it does maintain 90 degrees phase shift, so you are at resonant point. That's one of the key points is you have to have 90 degrees phase shift to get a standing wave. And then I dump it over into Simulink and check it out there using the same component values. So you put in 10.25 kilovolts on the resonant voltage, and you get the 377 volts out. That's 30 to 1 reduction on the transformer. And then the same thing with the current, 15 amps in, and you get 440 amps out. And then we do it one more time. We'll just go through these kind of quick. This is at the higher voltage level, the 1247. Same thing, only this one is 51 to 1 and 26 to 1, and the calculations are close enough that it's not going to be a problem. Doing the Bodhi plot on here, it comes out a little bit closer. You see the curve is a little tighter, the bandwidth is closer, and the points are starting to line up a little bit better. This one is still way off the maximum. So, based on that information, going back to his original design, required a impedance matching transformer in the system. So, putting that in there, you now have an identical system to his basic design. The next step is to work on the controller. We have the motor and power system pretty much nailed down. Now we got to do a little reverse engineering on the motor controller based off of the same stories. So we'll start digging into the details of that. taking the data off the stories. It says Tesla built the box, so that would be custom design. It contained 12 tubes that he brought with him. Curiously constructed ones, so that's definitely non-standard. It says 3 of them were 70L7, so that's standard manufacturing. 2 removable, 3-inch removable rods. That would be iron ferrite. 1 6-foot antenna. Now here we get into a little problem. At 60 hertz, 6 feet is much less than a quarter wavelength, so there's going to be an impedance matching problem there. And it says it had 2 heavy duty leads, so if that was 240 power on the motor, you're going to be looking at impedance matching through 7.25K down to 10 amps. And dimensions of the box was 24 by 12 by 6. So the dimensions of that box are way too small to hold a 75 kVA step-down transformer, so it was probably located in the motor housing, which made the 2 heavy leads that went up to the box high voltage leads, not high current. So the next step is to do a block diagram on the controller based on what was in the story. So they had a speed pot, which was the accelerator, and that changed the phasing of the reference oscillator. And then you had 2 half-wave power drivers that alternated the resonant circuit. The blue is the high voltage, and the red is the high current side. And then for running tubes, you have to have a B plus supply, so you have to jack up 20 to 12 volts into 70 or 100 volts or so. And now comes the hard part, is trying to design this tube with vacuum tubes. So I had to dig out my 50-year-old college textbooks to see what I could come up with. So we start with the power supply. Basically, it's a DC to DC converter that took 12 volts to 70 volts. And so to do this with tubes, you require 1 dual triode with a 12-volt heater for the multivibrator, center tap transformer, and a couple of rectifier tubes with either 6 or 12-volt heaters. So when you throw that together, this is sort of what it looks like. What I did to find tubes, the oldest tube manual I could find was a 1963 book. And I used the discontinued 8-pin opticals, assuming those were standard in 1930. So we had a 12SN7 and a 6X5 for the rectifiers, running a multivibrator into a step-up transformer. Nowadays, they just call them DC to DC converters. They're a little square box. Nobody cares about them. Next step is to do the reference oscillator, which is going to run at 60 hertz. So that's going to be a couple of triodes. That would be your 70L7s, heater power, 70 volts, about 100 volt output. Now, the phase shifter, you're going to have to phase shift either one or both of the grids on the multivibrator to kick it off the resonant point. And that's controlled by another tube, which would take its signal from a potentiometer, which would be the gas pedal. And then when you get to the power driver section, you're going to have 2 half-wave power drivers, which take 12 amps in from the battery and jack that up to the high voltage. And so what it turns out is those 3-inch, quarter-inch diameter rods they were talking about with ferrite cores for the inductors, the spike inductors, which takes the 12 volts in and jacks it up to the kilovolt range. And the curiously constructed tubes that were mentioned there wind up to be Westinghouse ignitrons. And I was never able to find an exact spec. Closest I could get was a 1938 Westinghouse Ignitron WL-654 rated at 480 volts and 12.5 amps. Going back that far, data sheets are pretty hard to come by.
putting it together, what it looks like, you have another volt vibrator here with a little bit bigger tubes, and you have to generate about 100 volts to fire the ignitrons over here, and then you have two big spike inductors with ferrite cores, and what would happen is the system would start on 12 volts, and as it got going, you put in the cores, which would start jacking the voltage up, and the end result was you get about 7 kV out the back end, and then that goes into a step-down transformer into the motor. Now, little side issue here, the ignitrons, it's a gas-filled tube, works as a controlled rectifier from the 1930s. Westinghouse was the original manufacturer, and they had the trademark rights for ignitron. Now, Tesla would have had access to these tubes because they were from Westinghouse. They're the predecessors of modern-day SCR silicon-controlled rectifiers. Basically, they would had a tube was sealed with a pool of mercury in the bottom, which was vaporized when struck by an arc from the igniter. But some of the pictures, you can see the puddle of mercury down in the bottom there, and they ran hot with a blue glow, and the bigger ones were actually water cooled. And the EPA thinks mercury vapor and fluorescent lights is bad. They really love these tubes. Conclusions: Tesla's resonant system can certainly run, composed of the antenna, the LC tuner, transformer, and AC motor. He didn't break any electrical rules. However, the controller probably gave him a lot of problems because the tube circuits are not stable, so they would tend to drift. So you'd have to keep rebalancing the system to keep it in resonance. However, a three-phase system is far more efficient than single-phase, and FETs are much more efficient than vacuum tubes. And we'll move on now from the reverse engineering over into trying to duplicate a model. So next one, we'll start working on a model that uses the same basic principles. The first thing we do is we scale down this 80 horse motor to a 1/22 horsepower motor. For a demo model, this reduces the complexity, size, cost. Besides, 1931 Paris arrows are hard to come by, not to mention they're extremely expensive. So what we come up with is a little fractional horsepower AC shaded pole induction motor, and the second detail there shows the shading coils. Basically, they're short circuits, and that off balances the field, so it's self-starting. Digging into the specs on this little guy, it's 1/22 horsepower induction motor, so it's 33.3 watts or 56 bar, 3,000 RPM, so it's just cold, 60 hertz, fan cooled, enclosed, no. 2 leads, so it's single phase, self-starting because of the shaded poles. However, it suffers from a low power factor because of the shaded pole starting system. It's down to 0.59, 115 volts at 0.488 amps. And then we basically do the same thing, run through the electric motor equations. Take 115 volts. Power factor divided by the power gives you the resistance, and the phase angle and the omega gives you the millihenries of the inductance. Horsepower is 1/122.3. Number of poles, pole pairs is 1, so it should run at 3,600, but because it's only running at 3,000, there's high slippage because of the low power factor. Okay, what we come up with is the motor run impedances. When you put all this together for 115 volts, it's 140.24 ohms, and then the imaginary ohms are 189.96. So when you combine that, you get
236.12 ohms is below. And then we're going to talk about the Q factor. One measurement of the Q factor is the imaginary impedance over the real impedance. The other one is the resonant current over the input current. And when you run the numbers, you see it's fairly low. The Q factor is 1.335. And if you looked at those Bode plots, you see it's a very wide, shallow curve. It's not a nice, tight resonant point. Calculating the phase angle, you get a minus 53.7. Now, what you're shooting for is a Q of as high as you can get. Infinity would be preferred, which says that you hit a tangent of 90 degrees, which generates a standing wave. Now, that's theoretical. The closer you get to the 90, the better off you are. If you get 89.5, you're probably doing pretty good in the real world. Now, when you plot this is the Bode plot of it, and you see the crossover point is way off to one side, minimums and maximums are off, and so therefore your resonant point is going to be a compromised position because it's a low Q resonant system. And so for starters, that's what I have to work with. So then we check it out on Simulink using the same impedance part numbers and that, and what it comes out with. Put in 370 millivolts, you get out 163 volts. After a couple of cycles of startup, you get 1.1 amps after a couple of cycles of startup. And going back, comparing Simulink and the MATLAB, they don't agree 100%, but they're both close enough to run. One says the current is a little bit lower and the voltage is a little higher. However, the peak numbers is 370 on amps and 163 on volts, and the motor will run off those numbers. So now we go on to the controller design, which is very similar to what Tesla had, only this is going to be built. There's no speed pot. We're just going to use a fixed 60 hertz reference point, and we don't have to jack up 12 volts because we're running with FET, so I can design the whole thing off 12 volts. So it's a little bit simpler and a lot more efficient. And when it looks, oops, the wrong way here. Let's try that. Okay, this is the schematics of that. We bring in the 12 volts, do a little bit of power filtering. We run it down to an op-amp oscillator. Runs into a FET driver, 2 power FETs that alternately fire through a transformer. You have your capacitor here, your resonant motor here, and your antenna system right there. And then we feed back the voltage through a system here to shut down the chopper if it starts getting higher than 115 volts. Then we move on to the resonant antenna system. And digging into the engineering details on a quarter wave vertical whip antenna. Normally, you have a quarter wavelength, so if that quarter wavelength is 6 feet, you're going to be running at 41 megahertz. Now, excuse me, at 60 hertz, a quarter wave antenna would be 776 miles tall. That's twice the orbital altitude of the space station, so it wouldn't be very portable. Well, the way you have to work it is you have to load the antenna to shorten it electrically. So you have to put a loading circuit down at the bottom of the antenna to make 6 foot resonate at 60 hertz. Now, it can be done, but it takes other components to do it. You have to use discrete components or lump components because normally it's done with tuning stubs, but even at 60 hertz, those are too big. So what we do apply an LC circuit down here, resonant cap, resonant capacitor, and then you have your antenna's radiation resistance and antenna capacitance. You have to make everybody happy on resonance or it doesn't go anyplace because you're dealing with an antenna. And doing a quick plot on that, see the red is the radiation resistance. Now that changes with frequency. Your operating point here is 60. Now the antenna capacitance remains fixed. And so you have your loading components. The dimensions on the antenna are 6 foot by 8-inch diameter. And your loading values, the capacitor is 13.96 microfarad. And your inductance is 503.9 millihenries. And it looks like it'll balance that at the 60 hertz point. Now for the fun part here, where you actually build it and take the data, that's the part I like. So putting this together, these are a couple pictures showing the working model. The box itself is just a little simple thing. Okay, you got a 6-foot antenna here, you got a power supply, the fan running there, and the scope showing pictures. And then we'll zoom in on that. The operating frequency is a cross between a square wave and a sine wave, so it's a little bit square wave like that. We're running 12 volts and 3.6 amps from the DC power supply, goes into the converter box, comes out as AC, and then the fan is running there. Getting the scope pictures now and digging down into the details. Okay, there's a lag here, something working there. Okay, first thing I did is I just took the motor and plugged it into the wall and took measurements of it. Line power, 163 volts peak comes out to 115.24 volts. Calculated is 115. For the amps, same thing. Calculated or measured is 0.493. Calculated is 0.488. Phase angle measured was 54.32. Calculated 53.57. Line frequency 5988 versus calculated. So we're all close enough to run. And that's a picture of it showing the phasing and the voltage and the current. Then we take a little bit of lag here. Then I take, this is a scope picture off the resonant inverter running, and you can see the wave shape is not sinusoidal. There's some second harmonics in there through the chopper frequencies. You get beat frequencies in the chopper. The main point is the resonant phase is not anywhere as close to 90. It's 11 degrees. They're almost lined up between voltage and current, so it's not going to resonate very well. But it shows 12 volts, 3.6 amps. Very low Q factor. Then I did one thing just for the fun of it. I went and took the resonant system and plugged it back directly into the wall and measured what it is. What you see is the current is very chopped up because the resonant bars goes back on the power line. Now, if you studied any Tesla stuff in his Colorado experiments, he did a high-powered test where he put back kilobars on the line and actually blew out the generator. And I just did that to see what it looked like electrically, having standing waves on the line, and it doesn't like it. Now we'll talk a little bit more about the Q factor. This is the secret ingredient, if you will, to make these systems work. Now, the calculated Q factor for this system is 1.355. The calculated one is the imaginary impedance over the real impedance. The measured is the resonant current over the input current, and they track fairly close, but they're not identical.
So for the real system, it's highlighted in red, and then I did simulation for increasing the Q factor from 3 to 5 to 7 to 10. And as you see, the phase shift is getting closer and closer to 90, which is what you want. Power factor goes down, the resistance goes down, the inductance actually goes up just a little bit, not much, it changes some. And then back to the plot here. And you see that nothing lines up very good. It's all spread around so that the Q factor is fairly low. And resonance, when you run the thing, the resonance is only supplying 30% of the power, which is 180 mils, versus the total load of 487. So it's still 2/3 on the power line, not resonance power. So then I took and done some simulation. This one jacks up the Q factor to 5. You start to see things line up. The crossover point, maximum and minimum, are all starting to line up. At this point, resonance is supplying 80% of the motor power, or 390 milliamps, versus total power of 487. So to make this thing even run, you're going to minimum, I would say, is a Q of 5. Now then I took it up to 10, where now this one, everything lines up real nice. You got your crossovers, your beats goes almost to 0, crossover exactly at the operating frequencies. And this one, resonance is now supplying 99% power, which is 480 milliamps, 487 required to run it. So this is the point Tesla is running at. You had a Q of about 10. And then we'll talk about the conclusions here of all my tests building. The antenna was not working very well because it's way low frequency, so we're going to have to top load some capacitance or increase the resonant frequency on the antenna. If we went to a higher frequency, up to say 20 kilohertz to 100 kilohertz, and use beat frequencies to PWM it back down to 60, the antenna would work much better. If you use smaller components, you can probably get the higher Q factor. Because you have to inhibit what's called self-resonance if you want it to work. Simulation shows it can be done, however, the real world and simulation don't always agree. That's where the engineering comes in. Conclusions, the demo proves that the induction motor will run off the resonant power system, so I've cleared one hurdle. However, we had a low Q factor, which just about equal inverter losses. So we didn't generate enough power for standalone operation. We determined that we're going to have to be in the range of about 5 to 10 on the Q factor with much better antenna. But the two main points is the demo does prove that Tesla's resonant design is valid, break any rules, no black boxes or black magic involved. And based on this research, my engineering experience, working demo, the rumored accounts, I'd have to conclude he actually built it and drove it. And then this leaves one open item that I will close with, calling the $64,000 question was transmitting. As there's no such thing as a free lunch in engineering, that resonant power has to come from somewhere. If the receiver is working correctly, being assumed by all the radio rules that the transmission is valid, there's an operating transmitter because the receiver can only produce transmitting signal. Old engineering is saying the devil's in the details. If I have more than too many of them, if there's any questions, we'll try and answer them. Figure out how to keep this thing.
Wonderful. Okay, no, I got it. I lost my mouse too. So, hey, let's do this. Let me. Oh, you went to screen share. Okay, look at that. Yeah, I put my sweater on. I'm freezing. that time of year. So first things first, everybody, let's put this gallery mode. Let's give a big hand for Mike Gamble. Mike, thank you very much, sir. Thank you.
I'm happy to present here. Nobody's throwing me out of here for my flying saucer pitch last time, so I guess I'm doing pretty good.
No, I think you did amazing. So let's do this. Let's go to Q&A. Let me start with Eric Hermanson. Eric, go for it, sir. And he just disappeared. Wait, did I hit the wrong button? Okay, that was vaguely terrifying. Okay, so I guess who has a question next? Okay, so let me go and allow participants to unmute themselves. Michael Boyd, sir, go for it.
Hey, Mike. So I got a question, but I put, if you would you go into the chat, and I put a circuit drawing for you. It's at 2 minutes before 3 p.m., which I assume that's my time in California. So it's what's called a self-resonant battery circuit.
Okay, that sounds interesting. I don't know how to get chat up here, so I would have to.
You know what? I see that. Actually, I see that in chat. So yeah, Mike, it should be down at the bottom. There should be a little chat icon. See that green share screen button? Yeah. Right next to that. There's a little button labeled.
It says chat. Okay.
Yeah, it's labeled chat. That'll pop it up. Then you may have to scroll up a little bit. Yeah. So you could probably save that for later. But Michael, is there anything you could describe?
Well, it shows it's supposedly based on Tesla's design, and what it does is it uses a self-resonance between 4 batteries, so that they can achieve what's called over-unity. So they'll produce essentially more power than the Earth. The more power, the bigger the load, the more efficient the battery becomes.
Okay, I got it open. It says it won't load. It says the administrator has to do it.
Oh, okay. Hey, maybe you could open it, Tim. You're the administrator.
Oh no, yeah. Well, let me see here.
You had to throw it in my email. That always goes through.
Show in Finder. Hang on. So let me upload. Let me see if I can re-upload this thing. Okay.
So, Tim, I don't want to monopolize my time. Could you guys?
There we go. Yeah, I just uploaded it too. It's just a JPEG image. So, but yeah, that's there in chat. Okay, so Michael, thank you, sir. Let me go to Harold Tavares next. Harold?
Yes, I have a question for you. Granted, the internal combustion engine with a drivetrain is the most successful and best-selling propulsion system of all time. Now, if Tesla created all that and it's that good, very promising, what you just described, how come, modern manufacturers like Tesla, the electric car, they have not duplicated the initial Tesla system to bring it into the market today, especially when it will help the environment and the global situation on the climate change?
Well, I would love to see it done. I'm working. This is one of my side projects, along with gyroscopes on propulsion systems. Started on this. One of my engineering buddies brought in a book about Tesla, and there was a chapter in there about this electric car that he built, and it really got my enthusiasm and interest. And ever since then, I've been working on it. I've spent 5 years of engineering on this thing, and I'm just starting to show reasonable gain on the thing. I present this at the Tesla Tech conference every year for the past 5 years. 4 years before I could get break even on power. Last year I made 5 watts, so it's not easy because of the resonance, which is probably why nobody has worked on it. Now you're having similar problems with your lifter systems and resonance, and it's pretty much the same.
Oh, Mike, I just did a request for you to start.
Yeah, we dropped out here. Hang on a minute.
There we go. You're back.
But yeah, anyway, it's also not that well known. A lot of books on Tesla don't even mention it. If you look it up on Wikipedia, they say it's all a joke. That it never happened.
Okay, and so I mean that on one side they say it never happened, there is no evidence, and the other side there is some evidence because you are presenting a logical explanation that makes sense that it may be true. I mean, what side are you on? Do you think that eventually if the resonance problem is the issue why we don't have it today? But obviously Tesla, when he did it with his car, did not have that problem. So where is the disconnect there?
He's the expert.
Yes, Tim, it's John Reed. I have a question for Mike Gamble.
Yeah, jump on in, and then I'll go to Eric right after that. But yeah, go for it, John.
Yes, Mike, I had to step away from the presentation, which was excellent, a couple of times, and I may have missed it. But the antenna that you're speaking about that you made your model with, were you designing that to receive electromagnetic waves, or did you try to look into some other form of energy input? You know, some people claim the ether or some other form of energy input besides electromagnetic waves. And I'm wondering if you explored any of those alternatives, or if you were just looking for electromagnetic wave input.
To start with, just plain electromagnetics.
Okay.
Before I go to the fancier stuff, we get the basics down.
Sure. But maybe I was wondering, a lot of people claim that Tesla's engine was working on something other than electromagnetic waves.
Feeler waves.
Yeah.
Well,
do you know of anyone who's been exploring those alternatives?
No, I don't know of anybody that's pursuing his electric car or resonant electric motor car system except me. I would love to find. There's a couple guys that are trying to duplicate it. I talked to them last year down at the Tesla Tech conference. They want to try and duplicate my numbers. I said I'll be happy to help you as much as you want, because everything I publish here is in public domain. I don't try to hide anything.
Thanks so much, Mike.
Mike's doing a great job.
Yeah, Mike, thank you. Let me go to Eric next.
Oh, hi, Mike. Thank you very much. I have a really quick question first, because I did want to talk about the antenna. What's the frequency of the photons that the kinetic antenna is tuned for?
Well, the antenna is tuned for 60 hertz.
60 hertz?
Yeah.
Okay, so it's going to pick up photons with 60 hertz. Okay, so I'm just looking at a frequency chart here. We're very, very detailed one. Just wanted to know what else is in that range.
If you go higher, you get a lot. If you put a spectrum analyzer on an antenna and do a sweep, if you get up into the radio band or the higher kilohertz, you get much more energy floating around to grab than at 60 hertz, which is one of the problems.
I'm just wondering, is there anything possibly supplying the energy from a conventional source? When Tesla was around, there was no cell towers, of course, but even with cell towers, that's not going to give you that much energy. It's not concentrated like that. But so the main question is, and this might sound like a dumb question, but I really don't think it is for several reasons. Did Tesla or have you or anyone ever tried to test this in as tight or as pure of a vacuum as possible? I know that you say it'll probably still work, but just have you ever tried it?
I wouldn't even know how to do a vacuum unless you got in outer space. I've done a few experiments up on the space shuttle where we grew stuff up in space, but I don't know how you get this up there.
Well, I don't know. I don't work with vacuums very often, but it just seems like if you had a vacuum that's large enough, powerful enough, you could get a pretty good vacuum on Earth. Just stick it right in there.
Well, Boeing's got some big vacuum chambers I've worked with. You put satellites in them, but I don't think it would do anything one way or the other for this.
Right. Okay. And I know that
if it had a steel cage, it would probably work as a Faraday cage, in which case it would probably wouldn't work at all because it would short it out.
Okay. Thank you.
Yeah, thank you, Eric. Let me go to Michael next. Michael?
Hey, I sent you an email with that file attached to it.
Okay. I'll dig into that when I put the Zoom down. I can't get it open right now.
Would it, Tim? Would it be possible for me to share that?
Well, yeah, if you got it up on your screen.
Well, I could do it, but Tim has to.
I know. It's got to go through him. Yeah, I know.
That's the problem. So.
I'd be curious to look at it and see.
Well, just do it offline. We got what I'm asking about is basically is this something you think we could reproduce? I have a number of the components that I've purchased, and I've been trying to figure out from the circuit diagrams certain of the semiconductor components, if we can get those components nowadays, because there's some circuits there that I'm not familiar with that I was hoping that maybe you could understand the symbols they're using. Okay.
I'll take a look at it. Anything that mentions Tesla usually gets my interest. I'm very curious on the work he's done.
Yeah. Hey, Tim, did you get my message that I sent you?
Sorry about that. You emailed the circuit image to Mike, and could I let you screen share?
Yeah, because he can't
screen share it. Yeah, go for it. Go for it.
Okay. You see that?
Yeah, well, I see a blank screen with your name on it.
Oh, you don't see you don't see the circuit?
No. There you go. Okay.
You see it now?
Yeah, I see it now. You got 4 batteries. Okay. And it looks like you got a round robin system, rectifier bridge for a load. Big capacitors in there.
And it looks like in the middle there you see timer input.
Yeah.
I assume that's like it's some kind of square wave that's going into the thing.
Yeah, you got a whole bunch. Yeah, these the 4 transistors there. You got AC coupling through a transformer coupled, and so there must be a sequential deal there. Looking at it.
So basically, one battery's discharging while the other battery's charging, and they're basically going in a loop pattern.
Yeah, it's a round robin system.
Right.
Yeah.
This is similar. There's it's gonna have phase locking with the 6 coil segments in the middle, so it has to be an odd number, like 5 or 7. This is here in the moment. I'll show you what I've been working on. Which
5 there. I see 5.
Well, I don't know. Let's see. There's 1, 2, 3, 4, 5, 6. Like if you go to the timer input, you have your first coil. Okay. System 2, second, third, fourth, fifth, sixth.
You're right.
So that you'll have the waveform will get caught, or it'll get phase locked within the with the even number. So it's like it's something I had to stumble across or working on in the Manellis circuit, which is similar to this. So I'll show my thing here in a moment.
Okay, well, I'm just curious. I'm just want to see if there's something I can build to make a better battery. So that's all I was asking about. I'll stop.
You got a lot of power diodes there for switching that heavy current. So,
well, where's the what do you mean? You're talking about input voltage has to be a heavy current.
well, the output of the battery is going to be like 400 amps. I'm assuming these are car batteries.
Right. So,
you got those diodes that have to handle 400 amps at 20 volts. So you're going to have some pretty hefty diodes in there. And the transistors are probably going to handle half of that, just looking at it. So,
right.
I don't know why they're transformer coupling. I don't understand why they want to transformer couple them, unless there's some phase lag between the transformers. Because you can use optical couplers, which is a lot easier.
Huh. So maybe there's a way to reproduce this with more modern components.
Oh yeah, the old way of isolating transistors or any electrical system was transformer coupled. And optical couplers work much better. I mean, you go 4,000 volts in those things.
Oh yeah, I've used them before. They're real high volts, and they're fast too.
Oh yeah.
Yeah, no, I agree. Yeah, this looks like that's why I was saying. Just look at the bridge, how they drew the bridge.
Yeah.
That kind of tells me this is some old circuit design.
Well, that's true.
So okay, thank you for that.
It would probably work, and if I had a little time to play with it to figure out what it does, it's a round robin sequencer of some kind. I have to figure out what switching logic on it. There's a lot of diodes that are being used as OR gates.
Right. Well, you got the drawing in your email.
Yeah. Yes.
So okay, thank you for your time. I appreciate it.
Mike?
Yeah.
It's John Reed again. I just had a quick comment. You had mentioned earlier in your presentation that you had a hard time finding some items, and probably others have publications, old publications, and that kind of thing. And I don't know if everybody knows about it, but there's a website called AmericanRadioHistory.com, and they have hundreds of all of the old technical manuals from the early 1900s up through the 50s, etc. Virtually anything that's ever been published on radio or technical aspects.
Question.
That's where I got the Ignitron data. It only went back to 1938.
Question. Do you guys have access to any old radios that might have any of that legendary red mercury in it by chance?
I don't think radio's ever had red mercury. I think you're thinking of something. Red mercury was something completely different. Right?
No. I'm talking to, but it's mostly over in the former Soviet Union ones, but they're from like the 1920s. There's a couple of YouTube channels that pull it out, and it's right by the antenna that there's these vials of red mercury in them.
Well, there are some old tubes that had mercury in them. Ignitrons were one, but there were also some amplifier tubes way back in the early days that had mercury in them. But I don't know about red mercury, but
that would be interesting to see.
And that's mythological, anyways. That's like what they call it, a white unicorn. But yeah, no. Well, I don't remember what the idea was. Red mercury was supposed to be some kind of nuclear explosive type thing.
Well, that's the stuff the Germans used in the Bell.
Yeah, supposedly.
Tim, I'm gonna have to show you some videos from Conspiracy Land there sometime.
Can we get that URL again? I'm actually shopping around for a manual for some equipment.
Is that the Unihedron? Is that Eric posted that one? Yeah, I think that's chat, Mark.
The one for
American radio history.
American Radio. It's I'm sorry, I was on mute for a minute, and It's called AmericanRadioHistory.com. All one.
I've muted myself over the Zoom right now, so they can't hear me talking over them. So I'm not being rude, but YouTube can hear me, and I agree. Unicorns existed. I am a man-bear unicorn, so there you go.
Yeah. Well, so let me see who would like to ask more questions. Let's take a look here. Other than URL related questions, because we're putting all those in chat. I've got lots of them in chat here.
Bill's waving his hand.
Oh, is he? You see, okay, this is a Zoom thing. I can only see like the first 5 people on the screen. Everybody after that, I can see you, Mike. I can see you speaking. I can only see the first 5 people. Yeah, go for it.
Hi, Mike.
Howdy.
Yeah, good presentation. You know, in the mathematics, when you look at, you know, some of these resonant situations here, that when you're at a resonant frequency, your resistance becomes dominant. Okay.
Sure does.
And but what with these type of systems, where the phase between the voltage and current has to be 0 degrees, but in these type of systems, it's not. It has to be like 90 degrees out of phase between the voltage and current.
Yep, sure do.
And that's where you see this effect occur.
That's the secret ingredient.
Yeah. And you know, when I looked into Tom Bearden's work, you know, I'm not sure if he brought it up, but I've been hearing this term of the law of squares. I don't know, have you ever heard of that law of squares? Like in a John Cyril work?
Yes, the law of squares is mathematics. It's
Not in the real world, you know, or the application thereof.
Okay, well,
it's kind of a quantum, right?
Where that comes in at is opposing forces with electric or magnetic charge. In electric fields or magnetic fields, you have to have this opposing field action. And what comes into play is this law of squares. And it's like the conventional equations no longer apply, that now you're working with the scalar component. And Tom refers to it as the gravitational field component. Okay, that's what really comes out of the scalar work, are gravitational waves. And when you get to this resonant point, you know, as I mentioned before, it becomes dominant. Okay, the effect, you don't see that scalar effect if you're outside of resonance. Okay, it becomes a conventional system. But when you fall into this resonant situation, then the dominating component there is this gravitational component, because you're actually pumping the field. Okay, it's either the electromagnetic field or on a mass, and that's where this thing about what Tom spoke about, you know, in his lectures. And then you get this new form of electricity that seems to come out of this. It's like a longitudinal electromagnetics, which seems to come out of this. And it's a whole different set of rules that seems to apply. Okay, and that's what we see in our tech. Okay, is this? It seems to be like another form of electricity.
Is this like Tesla's cold electricity, for instance, or plasma-based electricity?
Yeah, because you're not working with conventional field theory. You're working with something that's like 90 degrees out of phase. And that's why you have no temperature in space. Okay, because you're working with an impedance. We know what that impedance value is, but there's no temperature associated with that field. There's no temperature in magnetic fields, you know, for example. And that's what I find really fascinating about this. And so this concept of law of squares seems to come into play when you set up these opposing field action. And the is what's called longitudinal electricity. And so that's a whole area that has to be explored.
I just to add in I've seen those same mathematics in Marco Rodin's vortex-based electricity and mathematics a lot too. The law of squares playing out into it.
Like Tesla worked with converging electric fields, Rodin is working with converging magnetic fields. Okay, so that phenomena is going to show up. And when you set that system in resonance, then a whole set of different rules seem to emerge out of it. And what we see coming out of this is, really weird stuff. I mean, it's not conventional. It's not simple. It's like a whole set of other mathematics need to come into play here. And conventional theory, it doesn't show up in conventional theory. They say, well, you got the zero vector, but there's no scalar component. They took it out of the mathematics. But if you put that scalar component back in, guess what? There's your gravitational component. And if you put energy into the system, it becomes gravitational. If you take energy out, it becomes anti-gravitational. Okay? And that's what we see in like the forward sweep device, various devices that people came up with over the years. So, and your waveform is going to look very different, as well. You'll see a conventional voltage sine wave, but then the current waveform is going to look very different. Okay, it's going to look very different, and you try to analyze that conventionally, and everything just falls apart. You can't do it. So you have to go back to the old mathematics to see, there's that scalar component that comes up. And it works perfectly. Okay, the damn thing works perfectly. Yeah. So I just wanted, to mention that you can't use conventional modern physics to solve gravity. It just doesn't work. It's not there. It's been taken out. So I just wanted to make that comment, about this.
Well, thank you, Bill. Thank you. And, so, Mike, I don't know if you have anything there, or if we should go to the next question, or we'll go next question. Who has another question for Mr. Gamble?
Mike, what became of that car, the Pierce Arrow, in history? Did anybody buy it? What became of that car? Do you know?
I have no idea. The last, if you read those stories, it was stored in somebody's barn, and that's the last anybody heard of it.
Boy, that would have been an interesting find, getting that car for all the history behind it. Well, too bad. Yeah, nobody found it. Hey, thank you. Great presentation. Good information. A lot of inspiration there for future research on Tesla technology.
Yeah, well, that's what I spend my hobby time on is anything Tesla.
Well, keep on at it. You're doing good.
Let me see. Let me go back to Michael Boyd.
So, my question, Mike, do you think that there's a relationship between, or what do you think is the relationship between a standing wave and self-resonant states? Well, that standing wave is self-resonance. As long as the wave's traveling, it doesn't have a chance to build. But once it's stationary, then each cycle builds upon the previous cycle and just pumps itself up. Isn't that how a linear accelerator works? I think so. I'm not much on nuclear physics, but I believe that's how a lot of the cyclotrons and stuff work. They just keep running in circles, and each time around the track, it gains energy. Cool. Thanks. That's my question. disappear?
We're
Counting on me,
Hi,
Tom.
Mike. Go ahead. I just have a general question, not specific to the conversation or to your presentation, which was very good, by the way. If I could have some time to talk about it, if now's a good time, or I can wait till everybody's questions are done.
Well, go for it.
Well, Mike, I've learned a lot from you. You know, when I first came on these conference calls, I'm a little bit shy. It's kind of hard for me to listen up and start just talking my heart out. But because I've got some issues, but I've worked through those. COVID's been hard on the family. I lost the love of my life in September. Stuff. I was hoping to see you guys at Tesla Tech because it was here in Albuquerque. I'm only like 40 minutes away from Albuquerque now.
Well, I'll be down
But anyway, I'm making a big move. Good. I want to see you. Well, I'm making a big move this year. I'm moving out of my shell. I'm the gravity alchemist, I call myself. I'm coming out of the closet this year with a propulsion device that I'm making big claims about. And I've already incorporated, I've made an LLC. My CPA is on board with me. My CPA's son is a master's degree in electronics, and he builds propulsion systems for the Navy for certain things. But, and I explained this to him, and he's pretty on board. He's just got to find out that it's not a conflict of interest with being a subcontractor to the Navy. My idea is real simple. You guys have a lot of knowledge about theory, waves, all this. Mine, and I explained this in detail, and I talked to Ron Keto about, I talked to you first about liquid momentum wells. You didn't have a lot of information, but Ron did, and Ron says, liquid and self-balances. When you spin it in a torus vessel. So, without nobody wants to sign any NDA agreements, and my score advisors told me I got to get NDA. Now I'm looking for someone because I've also hired a grant writer, so I'm going all out with this. I'm going to get a grant either with SpaceWorks or seed funds from National Science Foundation, the Navy. I don't care. I just need some funds to move ahead with the project. And because I am excited about it, and I'm going to send you guys a link in the chat to my landing page. You were talking about in 1926, my grandfather built a gyro motor just 70 miles south of Goddard. At the same time, Goddard was building the rocket. I've got pictures of it on my website now. I've got pictures. I've got newspaper clippings. I got everything about my grandfather's gyro motor. It ran on gas. They ran on air. They ran on oil. You can see the newspaper clipping. So, I mean, it was a big deal. It was a big deal. And that was my own grandfather. So I know where I get all these ideas from. They're coming from him, I guess, genetically, because I sold insurance for 44 years. When I got out of insurance, I look back and I think, I'm glad I don't sell insurance. But I love science, so I've been educating myself. So when you told me that when a reaction wheel is running on a satellite, it always rotates around its center of mass. Well, my system, I figured out how to change the center of mass in a spinning disk, bifurcate it from its center of geometry without violating Newton's third law, and I can do that 50 or 100 times a second. Now, how far I bifurcate the center of mass from the center of geometry and then rotate it 1 pi radian, it moves that far in Cartesian coordinates. And if you do that, like if you did that a foot and you did it 32 feet, 32 times a second, you've got a Newton force equal to Earth's acceleration.
Now I'm talking about Einstein's idea of what acceleration is. You know, it's just a. Einstein said it was a pseudo force because it's time, space, and all that with mass. But mine's more just looking at it from a Newtonian perspective. And basically, it's what my grant writer's telling me is that I need a physicist on my team that will sign a non-disclosure statement. I have the non-disclosure statement. I need a physicist, and I'm waiting for this master's degree electrical engineer to see if he can do it. He wants to. Like I said, his father is my CPA, who just incorporated me. I incorporated myself as Southwest Creek Engineering and LLC, and so there's my CPA's dad retired from JPL, and when he retired, they gave him a plaque with a moon rock on it. I mean, and they say, "You remind me exactly of our dad." So, I like propulsion. This thing, I really have a good feeling this is going to work. And I'm reaching out to the community. I'm reaching out to you guys, anti-gravity, scientists, engineers, experimenters. I guess I'm an experimenter in helping to build the next generation of technologies. Well, I'm boldly saying right now that my idea is going to work. And I remember I talked with you and Tom. I said, Tom, mine will go from launch on the surface to orbit, and it doesn't have to reach escape velocity.
Bill, this is John Reed here. I just had a quick question. Have you built a working prototype model by chance?
No, I have not. It's hypothetical right now. I've got it all in. I built a demo model for this electrical engineer to explain how it works. So this is my claim. The motor runs on electrical energy. The motor reduces the complexity of construction compared to rockets. The motor on the spacecraft can accelerate the craft to attain a position in space without reaching escape velocity, as long as there is electrical power. The motor makes a spacecraft hover by balancing the Earth's gravity with a linear Newton force pulling the craft 9.8 meters per second in the other opposite direction. And the motor does not violate Newton's third law of motion. Now that's my novelty that I figured out. How do you get around? You can't get around Newton's third law of motion. It's a law, man. But there is a way to bifurcate the center of mass from the center of geometry without violating Newton's third law, and that's the whole thing why this would work. And the motor can accelerate a spacecraft faster than 10 meters per second squared. The motor can accelerate a spacecraft in friction or frictionless environments, such as microgravity, without mass ejection. There's no mass ejection. The motor
based on the previous presentation you gave.
Yeah. Well. So let's try and rein this
no,
back.
I'm not giving it away.
Well, no. Let me try and bring this back into Mike's presentation.
I'm just trying to. I'm almost done.
Okay.
Okay, I'm sorry. I'll talk to you guys later. But if there's somebody that wants to reach out,
I believe in you, William. I believe in you.
Well, William, I would say, we have the open discussion. We do have the open discussion coming up, and
well,
so
you guys think because I don't have an education, that maybe that I don't.
William, it's nothing like that at all. Let's finish this discussion in an hour and a half after the presentation is done. Is all he's saying.
William, that's all. I'm just trying to focus it back in on Mike. That's it. We've been,
Okay, well, I'll talk to you guys later. I already asked Mike if it was okay. He didn't think to object. Okay.
Yeah. I know. Well, it's good. I just,
this is being really vulnerable to you people. So.
Oh no, it's fine. It's fine. Yeah, I just want to focus it back in a little bit so that we get him all this time.
Will, don't go back behind the wall. We're just saying we have one more presentation scheduled. Then it's open ad hoc parts where we can go in and talk for hours on what you are saying because there's much substance to it. And thank you for coming out with it.
Yeah, put it in. Thank you. Okay, thank you again, William. Okay, so let me go back and see. Do we have more questions for Mike? I know today we've been
one question for Mike.
Yeah, go for it, Harold.
Okay, Mike. Can you discuss the Boeing is using the electric motor with the power supply, Tesla power supply that you were discussing right now? Are they using that in space to power some of the gyroscope with that electric motor, with that setup, as you just described?
I don't think anybody's using it. They run gyros with electric motors in space, but their power is coming off a solar panel. This resonant power system that I just presented here, I don't think anybody's working on it. I would love to find somebody that's working on it to work with them. Two heads are better than one.
How long ago did you get that particular idea?
I've been at it 5 years.
Oh, okay. So you did not get it when you were working at Boeing. No. If you would have been working at Boeing, if you would have got that idea, the resonant motor system that you discussed now, let's say 10 years ago when you were 15 years when you were at Boeing, would you have used it to power a gyroscope in space?
I don't think Boeing would even be interested in it. They go for fairly conventional stuff. Anything like weird science, they're not really interested in.
All right, thank you.
I couldn't sell them my flying saucer engine from last pitch. They weren't interested in that either.
Oh, okay. Thank you. Very honest answer. Thank you.
And Harold, thank you as well. Let me go to Nils now. Nils, sir.
Thank you for Mike for the presentation. Mike, we're both engineers, and I assume we both agree that having a resonant circuit perfectly resonating, or even going with Bill Alex idea of voltage and current 90 degree out of phase, will not produce any extra power. It will always produce less than what you expect.
Well,
and my question about the Tesla motor or the car, did he have a transmitter nearby, near his house, or something?
That was my last chart. Who's transmitting? Last year, 2 years ago, I broke even on power. That the power in equaled the power out. Last year, I was 5 watts to the good. The input power is 5 watts less than the load. This year, I'm trying another method, and I will be presenting that down at Tesla Tech in August if I get it running by then. That's my goal.
Right, but you know that 5 watts out of a 1,000 watt device, that's a very small percent. It's 0.5% or something. So you can just have a measurement error. You know, what is the 5 watts?
It's 5 out of 30.
Oh, 5 out of 30. Oh, okay, that's significant. That's significant.
Yeah.
But Tesla didn't have any transmitter near his car when he was driving.
Nope. Called an ether power.
Mike, do you know what frequency he was at? He was at 60 hertz?
No, I think he was up higher. That's one of my proposals in the modifications. I think he was running up higher. 60 is very hard to get components to resonate very good.
Do you think he could do 8 hertz? 8 would be difficult, wouldn't it?
I don't think you could get the problem is the parts get so big as the frequency goes down that the losses kill you.
Well, the reason I asked was when I was, that was a long time ago now. When I was in college, my college library had a book on Earth's electrical system. They had stuff in there by Tesla. They were talking about 8 hertz is the natural cycle. And he was playing with that. So
That's my gravity pitch right there.
Yeah.
7.06.
yeah, I think that was probably what it was. Yeah.
It's the von Karman resonance, and that changes. It's, or no, excuse me, not von. The Schumann resonance. It changes. It goes from like 6 up to 12.
5 harmonics.
There are 5 harmonics in the Schumann resonance.
Yes.
Okay. I mean, I've studied I've watched the Space Weather News presenter, and they, the L shells are around the planet, or Van Allen belts are part of that. So like when the planet gets really whacked with, really hit with a strong CMB.
Yeah.
Okay.
Sorry, we're getting a lot of echo from this lab.
Okay. But anyway, it's just the von Schumann resonance. I know it fluctuates. There's a couple people out there that are watching, or they have it on. There's websites for it. So yeah. All right. Anyway, I yield.
Mike, do you have the circuit for the 5-watt device online anywhere? I can study on top of it.
I don't have it online, but Tesla Tech last year's presentation has a video of it.
I'll check it out. I'll look for it.
I could send you a copy of the pitch if you wanted, but if you get the video, you get the more of the presentation. It's like, it's like this one. Just having a piece of paper doesn't tell you a whole lot.
Okay, so I can find it online through the conference. Right?
Yeah, Tesla.
Or do I have to pay to subscribe?
You can TeslaTech.org is the website. But if you send me your email, I can email you a copy of just the pitch. But that doesn't tell you, as much as you get from the video.
Okay. All right. I'll check it out.
Okay. Nils, thank you, sir. Let me go back to Michael Boyd.
Hey, Mike. So I sent you another email, and what I'm asking about is, why batteries recover after a load is removed?
No, but it's probably something with a spike.
So I think it has to do with the chemical reaction in the battery, but it seems to be a factor that applies to capacitors as well.
You get a spike or a pulse when you put a load on or remove a load on an electrical system. I guess you would call it electrical inertia or something like that.
Yeah. So what I'm asking about though is if that would be a possible way to create a resonance, because there's going to be a time factor there.
Well, that's what I showed in that inductor capacitor circuit. Is you have to have a little bit of current flowing into the thing to kick it to get it going, and then if you get it tuned right, that's when you get the big power.
Right. So I'm wondering if that's part of this over unity in that other prior circuit drawing I showed you.
That is probably how it works. Is by doing a round robin type system where each battery picks up the load and then it's disconnected, added, that those spikes are starting to add up.
Right, so it reaches a certain peak and then it switches to the next battery.
Yeah, it just goes around in circles.
Gotcha. Okay, thank you.
Wonderful. Okay, so who else has questions for Gamble? And we are getting close to the top of the hour, so we could, if nobody raises their hand, I could just start on the Hutchison thing.
Go for it.
Okay, well let me do that then. I'll put this back on gallery. Everyone, please give Mr. Mike Gamble applause for a wonderful Q&A session as well as a detailed presentation. Thank you, Mike. I sincerely appreciate it.
No, I appreciate being allowed to pitch at your conference here. You seem to have me back fairly regular. So.
Yeah, well, you have a ton of material and it's really great. It's really detailed. Okay, so let me do that. So what I'm going to do now is I'm going to mute everybody out. Okay, and let me see. Yep, there. Okay. Yeah, I'll spotlight myself for everyone. That way I won't get lost. Okay. It's a little weird looking at myself in reverse, but that's fine. So I'm not going to introduce myself. I'm Tim Ventura. I'm the moderator. You guys all know me. And let me find my stuff here to start out. Okay, so what I'm going to talk about today is the Hutchison Effect, in particular material samples. Okay, that's what I wanted. Okay, so everybody, let me share my screen. I'm just going to share the entire thing. So what I'm going to start out with is, this is an old video of the Hutchison Effect. Now this is 23 minutes long. So I'm not going to play this entire thing. I will jump around a little bit in it. This isn't the one I thought it would be. But so this is a cup of water. Can you guys hear me okay, or is there background noise from the video? No noise. Okay, I didn't hear the. Okay, sorry, I'm getting noise on my end. There we go. Okay, so in the late 1970s, early 1980s, George Hathaway and John Hutchison basically used a lot of high voltage electrostatic equipment. It was almost entirely in the electrostatic realm, right? Very little magnetism involved. A lot of Tesla coils, DC offset bias type stuff. And what they found was, as John was able to tune this equipment in his incredibly crowded environment, for instance, this image right here, that is a metal file that is heated cherry red. And it's kind of apparently done it on its own, and they weren't using enough output power in that test to make that happen. So you can see that, I mean, again, it's difficult to tell, but that's basically a piece of steel that's got sparks coming off it. It's cherry red. So that's one example. One of the things that you're going to see in here, you will see stuff move spontaneously. You guys have probably seen all of this on TV. But this is basically the original Super 8 footage. If you guys are wondering why this footage looks so crummy, much of it was shot originally on Super 8 film, right? These are old film cameras. So it was later transferred to VHS. And then I have some that was restored as well. So what you can see there is a piece of metal that just lifted off, flew around the table. There's another one.
Joey, thanks for joining in.
Into the air.
Don't you worry. The stream is not ending anytime soon.
Pieces of metal, and they're moving around spontaneously. So those are some of the things that we have. Let me fast forward a little bit. So again, a heavy piece of metal moving on its own. I'm not sure if you can see that. It's kind of twisting back and forth. I'm going to fast forward. Here's a good one. Okay. This is a metal wedge. Basically, it looks like the center of mass of this wants to take off the table. It's just a little bit too heavy to lift off completely. That's why it's balancing on that thin edge. So that would be presumably some kind of gravitational effect or something. That's one example. Here's another one. I'll fast forward. believe that bowl is plastic in this case. It is next to a metal, some kind of a bearing holder or tube or something like that. The bowl is just kind of moving around on its own. Again, this is from all of these different effects. Let me see. Bowling ball, yeah. This one, you guys may have seen this on TV. And what I'll do in a minute here is I'm going to put on a cleaned up version of this. This is the original footage. Yeah, because you can barely even see it. So that is it's not a bowling ball. That is a cannonball that John had because he collects stuff like that. I believe that's something like 60 pounds. And at some point, let me see. You can barely see it here. It's lifting off the table. 60-pound ball. We're about 30 kilos, right? So that's just lifting off and flying around. Okay. Here we have a cup full of liquid. The liquid starts to bubble and boil. You see that? You kind of see the bubbling happening there. And for some reason, part of the liquid starts to literally just rise out of the cup. No reason whatsoever. And the cup took off. So whatever it was, it took it all with it. And you know what? I'm gonna stop this video. Let me stop this one, and let me get the other one for you. This. Okay. There we go. Okay. Yep, this is a 2-minute video. I'll just play this one all the way through, and you guys can see kind of the best effects. So this footage was actually transferred to VHS and cleaned up, and then I got this from the film producer many years ago. This has been used in several TV specials. That's a fluorescent bulb. It's lighting up on its own. Not that interesting. That's pretty easy to make it happen. He's just using that to test. That is the metal file. It's been cleaned. That is a bowl flying up. A bleach bottle that is closed, spontaneously compressing. Drill bits. You saw water lift off. 7-Up bottle lifts off. These are all different materials. That's the cannonball. There was a wrench there. In terms of wattage, John runs all sorts of different things. I believe he runs stuff that's all the way down from 50 watts up to several thousand watts. That's one of the material samples, the knife in the block. That's another material sample. So what I'm going to do is after this video, I'm going to dig into these material samples a little bit more. That was tinfoil. I think that was ice, I'm not sure. Broom handle. That is a solid steel ingot. If I remember right, that's actually part of an axle that they tested it on. So again, a lot of this footage was shot by George Hathaway. I think John may have shot some of it. But you can see we have all sorts of stuff lifting off and flying around. So I have some links. There we go. That's the end of it. Okay. And in fact, I'm going to paste these links into chat right now. That way I don't forget. I'll put them in there for everyone. So John Hutchison, again, for most of you guys, you probably already know this. John Hutchison has been incredibly well documented by the media. And in fact, probably the biggest issue there is John's work in the media goes back to the 1980s. So that Super 8 footage, he has lots and lots and lots of footage. The links that I pasted in there, I believe that I've been able to collect pretty much all of the Super 8 footage. When you add it all up, there's probably like an hour to 2 hours. And that's longer than it seems because a lot of that's short segments. some of it's stuff that was captured by various TV crews. And so, like, for instance, in the 1990s, you had a lot of Japanese stuff because the Japanese would send out TV crews to John Hutchison's place. And so it would be on their broadcast. They would get unique effects. So anyhow, that is that presentation. But I wanted to kind of show you what was there. And let me see. And now mine looks... slideshow. There we go. Play from start. Perfect. Okay. So, again, slightly disorganized. What I wanted to do was the Hutchison Effect materials analysis. In 2005, I went up to John's house in British Columbia, New Westminster, twice. I also went later in 2006, 2007, and I believe 2008 and 9. So I've been to John's place. I've spent probably dozens of hours with him. I've been to his place 4 or 5 times. I was able to see his stuff up front. I also have a lot of acquaintances and colleagues that have gone up there. I tried to study this as closely as I could. I've never personally seen the Hutchison Effect. I'll just be upfront about that. But I was able to see the materials effects. He had 50-gallon drum almost full of various samples that he's tested over the years. So we'll start with aluminum with embedded steel. All of the photos in this, by the way, these are all my photos. I can vouch for them personally. With some of these, I actually ended up with a scratch on my camera lens because I got the camera so close that it actually scratched metal. So this is a block of aluminum embedded wood. So they had a piece of wood that was on top of the aluminum, and it actually sank down into it. So what you can see is they very carefully cut that aluminum piece in half, and inside of it, you can see the wood. So when John let me examine this, you can see I got that camera as close as I humanly possibly could. You can see there's the wood, and the top and the right. Down on the left, I changed my filter a little bit to pick up the wood grain a little bit better. As you can see, there's an indentation in the wood. Actually, I did that with my fingernail. I wanted to make sure that it was soft, and it was. And it wasn't burnt either. You can see that the inside of that wood is embedded in the metal, and it is unburnt, right? Now, aluminum has a pretty high melting point. So to do that that's pretty insane. So this is a perfect example of gellification. You have 2 substances that absolutely should not mix together, and they are, and the flammable one is not burned at all. Okay, and let me see. Sorry, I got the title on that one wrong. This is the knife. You saw John holding this one up in some of that TV footage. Again, he hung on to this. I got to examine this very carefully. This is another block of aluminum, an incredibly high melting point, and you have a piece of steel that is completely melted into it. Again, it's that gellification effect. So here are a few different close-up shots. I was trying to kind of show you guys how this looked. Again, what they did here was they used a high-speed saw to cut this in half, and they were able to get mostly right down the edge of the knife. So they cut this, but that's why it looks the way it does. This sank in and jellified. They literally just sawed the thing in half, and that's kind of what it looks like on the interior. You can see that there's no scorching. There doesn't look to be any heat marks at all. That's very common with his stuff. You get lots of jellification and deformation, but you don't get heat marks. There's no like, you don't see any rainbow patterns on the steel or the aluminum. Nothing to indicate that it's been heated or cooled or treated in any way. Okay, here are a few more of the knife. These are just kind of close-up shots of it. This is very solidly embedded in there. We tried to pry it out. It won't fall out. They're not welded together. They're jellified together. Okay, so aluminum bar, jellification, separation. I wanted to show you this one. These are probably out of order a little bit. This is the end of a solid aluminum beam. This is what it looks like after the Hutchison effect. So this beam, again, I held this. This is heavy. This was, I believe, about 3 inches wide by 2 inches tall. This is not a little toy, right? This was basically structural beam. And as you can see, it has jellified, and you can see that the jellified part almost looks like putty, and I'll show you why in just a moment. Okay, and here's close-ups of the end, and again, you can see that it's jellified, and this is why it looks like it's been pulled apart, because if you look, if you made something out of Play-Doh, you would expect it to look like that. This is what it started as. This is something that the TV people never showed also. This is something that I found. So this was a single block of aluminum, single beam of aluminum. And it jellified in the middle and puttied apart. And these are the two remaining pieces. It did this on its own. Again, you can see a lot of deformation. What you don't see is a lot of heating marks. You don't see scorch marks. You also don't see tooling marks. It's just did this on its own. And if I remember right, he has video of this happening somewhere. These are some more close-ups of the end. It's pulled apart like putty. So one of the important things that I really wanted to stress for you guys is, and this is what I noticed when we examined this, metals all have crystal domains, right? And it varies, you know, the size, the orientation, and all that of these domains of the metals, it varies depending on the metal. But one of the things that I noticed repeatedly with all of Hutchison's samples is the metal domains are very disrupted. They're very screwed up. And you can see in these photos, there's a granularity to it. Hopefully it transmits well enough that you can see that, but you'll be able to see the recording. So there's a granularity to the metallic domains that doesn't normally exist. These are created process blocks of structural aluminum, right? But when they're done, the domains are all messed up. Here are some more photos. Again, these are the two pieces. You can see that they've curled a little bit more after they came apart, which is interesting. So after they finished pulling apart, the effect continued for a while. This is an extreme close-up of what I was trying to tell you. Again, I should apologize. This is kind of the limits of where my camera was at. This might have been the one where I scratched the lens. What I was trying to do was show you as closely as possible how those actual domains are messed up inside of the metals from this effect. Here are some more close-ups. Again, you can see this granularity to it. The best way to describe it is almost like sand. It almost has like a sand-like texture to it after it's done. You know, it started out polished, and at the end it almost feels like sandpaper. Okay, and so this you can get in the recording. This is something that was never on TV. Actually, John let me photograph these at his house. George Hathaway did spectrographic analysis on these samples. So this is the virgin material. This is what it started as. They took a block of that. They took a sample from that block and tested it, and George found some trace materials there, right? So, and again, you guys can catch this in replay, and I actually have photos of these. Yeah, the photos are linked there, I believe. Yep, they are. Yeah, they're in the Flickr albums. Okay, so this is the affected area. Now, one of the things that you'll notice is, so the aluminum, the ALK, is that potassium, something? The trace amounts of that have declined substantially, and you have much higher trace amounts of other materials in that affected area. So again, I'm going to back up there. That's what it looked like originally, right? And that's what it looked like after Hutchison Effect changed it. So there was an actual spectrographic change. There was a change in trace elements in this, as well as the domain disruption. Okay, so now I want to go to a steel block. This is one that he let me, again, this was just one of his many samples. You can see that, again, there's a lot of domain disruption here. In this one, it kind of powdered and fell apart into 3 different sections. And I tried to get some close-ups of it. If you'll notice, the granularity is a little bit different in the metallic domains. And I thought that that was interesting. Steel, aluminum, and brass, they have different, they tend to disrupt a little bit differently, I guess. That's the best way to put it. And so in this case, again, this kind of spontaneously fell apart on its own. If I remember right, they did capture this one on film. Okay, so that was pretty straightforward. Oops. And next, I want to go to a steel cylinder. This one has made several TV appearances. Again, if I remember right, this originally was part of an axle, but I could be mistaken. This is if I remember right, a high carbon stainless steel. And you can see lots of erosion. You can see also a little bit of what looks like rust on it. Now, this sample has been around, and John lives near the oceans. There's some salt air. So it's possible that this corrosion happened after the fact. He let me photograph this. I mean, we're talking 15, 20 years after they actually filmed it. So, but that is what it looked like. And there are two halves to this cylinder, and that's important. That's very important to mention. So the reason I mention that is, again, on TV, they would show you the materials disruption. What they wouldn't show you is that these things tend to fall apart starting in the middle, which is probably related to the wavelengths he's using. It doesn't always happen that way. Sometimes it starts at the end. But one of the things that I found from Hutchison's materials, from talking with him, is if he takes a block of aluminum out there, it will start to disrupt in the middle. It's some kind of a waveform reinforcement. And that's something that none of the media people talked to ever captured. So again, that's our stainless steel, high carbon steel. There it is, Hutchison stainless steel. Okay. And I don't have the original sample assay for that, but this is what it looked like after the fact. It's saying, oh, no obvious change between, the main body and the affected end. Okay. This one next is a brass bar. This one has also made many TV appearances. This one has been to Japan many times. So brass, you can see the domain disruption appears to be minimal, but the actual sample itself looks, it's completely trashed. It looks like it's been cut with an axe or something, but it hasn't. That all spontaneously happened. Again, if I remember right, this happened on film. If you'll notice, I mentioned that this effect tends to start in the middle. You'll notice that this bar is disrupting starting in the middle. And these are some close-ups of the metallic structure of the brass. And you can see there's not really any heat indicators there. Doesn't look like it's been burned or scorched or blackened. Again, these were just about as close up as I could get it with my camera. So this is the brass sample. This is the virgin material with George Hathaway spectroscopic analysis. And that is the affected area. And once again, you can see the amount of the major impurity changes and the minor impurities are more pronounced. And that was something that apparently happens quite often. So one of the notes that I should make in this is some people have suggested that maybe there's some kind of nuclear transmutation going on inside of Hutchison samples. That has been one of the suggestions. Another suggestion, and I think George may have made this, is that natural impurities in these materials migrate either towards or away from the site of the effect. So when the material jellifies, the impurities congeal, right? Almost like surface tension on water. And so that's another theory. So either there's transmutation happening, right, which conventional science would say is unlikely, especially at those power levels, or alternatively, you have impurities naturally migrating within a jellified substance, the same way that you would have like DNA segments move in agar. They do a DNA test. Okay, so this is another one. They had penny on top of a block. It sank into the block when it started to gellify, and it sank in. They had it near the middle, and that's where it started to crack at as well. So again, you can see there's not really any indications of tool work or heating going on there. And I tried to get some close-ups. John lives in BC, so of course it's a Canadian penny. Now, at the time, and I'm not sure what year this was either made primarily of copper or primarily of zinc. And it's always going to be a mixture of those two. So you've got copper and zinc mixed in with aluminum, and you can see that the aluminum is, in fact, adhering to the penny. So you've got two completely separate materials that appear to be bonded to each other. This isn't particularly notable. This was on the back of that sample. This is the stamp of the manufacturer. John showed this to me, so I wanted to capture it. So basically, whoever manufactured this bar basically put that stamp into it, and that's their trademark. And I think it also shows the purity level or something like that of the material. It shows the material type. Okay, and these are some more close-ups of that sample. And again, you can see that penny is melted right into it. It doesn't look like there's any tooling or anything like that. I was able to change the filters a little bit. That particular camera, the camera I was using had some infrared capabilities. So I tried to shoot in both normal and IR, try and pick up a little bit different spectrum. And that's what I got. Okay, and again, a few more shots. I should apologize for having to turn these on edge. They were originally right-sized. You can kind of see from a distance what that looks like. Again, the effect started in the middle of these bars in every single instance. And I find that particularly interesting, right? Especially for people who say, oh, well, it's a hoax, it's this, it's that, it's the other thing. Well, it is interesting to find these notable pieces that no one has reported on. And one of the things that's important is the Hutchison effect either starts at the end or in the middle. And when it comes to these blocks, it seems like it always starts in the middle. And that's almost regardless of the material. The brass started in the middle, you have aluminum starting in the middle, and that round cylinder piece that I showed you, that started in the middle as well. So, okay, so now we have aluminum bar jellification and partial separation. This is kind of a repeat of what you've seen before, this separate aluminum bar, except in this case, you can see that the jellification started, it began to spontaneously pull apart, and then stopped. Now, what is interesting in this, you may ask yourself, well, okay, are they pulling these apart? Does it turn into a jelly, and then him and George touch it? They don't touch it, actually. I've seen clips where these effects happen. You may have as well on TV. This effect will start to happen. It will lift off the table and pull itself apart. So this is not something that they're creating by pulling it apart like putty. It is doing that on its own without any assistance. Again, this is very similar to the other sample that pulled apart completely. This one has only done it partially. You can see significant disruption to those little crystalline metallic domains. You can see what looks like a putty effect happening. And there are, again, no marks of tooling or heating. Okay, a few more shots. Again, my apologies for having to flip some of these on their side. And actually, that's my last slide. That's it for that screen share. So let me see. I'll end my slideshow there. So one of the things I should show you, since I showed you all those photos, you guys can get all of these on Flickr. This is where I loaded these. They've been hiding there for several years. See, only 68 views since 2012 when I put them up. These are all of the spectrographic analysis that George Hathaway did. Oops. And these are the actual metal samples. This may be interesting for you because there are a lot more than I put in this slideshow. Here, I will maximize this so you guys can see. I did not show you these. If I remember right, this is a piece of tungsten. The reason I didn't show you these is these photos are older. Gary Stevenson gave these to me. These are relatively small. Yeah, see that on the screen. So they wouldn't have showed well in the slideshow. But basically, they're pieces of tungsten that melted at room temperature. So again, this is just kind of a survey, and the link to this is in chat. Okay, and then let me see. The other thing that we have is, well, I would say go through these and take a look. We have some stuff by Harold Burke that he shot. I also wanted to run you through the photos really quick. This came out of a much larger file, and I don't have time to run through this today. But let me magnify this up for you. I'll go through it real quick. So you've got John in his apartment. These are mostly from the 2005. I had Mike Schaefer, who comes to this conference sometimes. Mike Schaefer was there. That's Harold Byrne. Harold Byrne used to be the Canadian rep for the Disclosure Project. He passed a few years ago. I had a few other folks who went up as well. This is in 2005. So while we were up there, I also shot 2 hours of interview footage. That's just John goofing around. Again, you have to keep in mind, he's a bit of a practical joker, and he is very much a free spirit. There's Harold, Mike, and actually a colleague that I used to work in the .com industry with. That's Harold's son, Brian. These I can show you guys. Okay. So these are some views from outside of John's apartment. Now, again, if you've seen him on TV, his apartment was legendary. And probably not in a good way. He had the fire marshal over several times. You can see that there are chains. They made him install chains to secure things. And in fact, they had to check the structural integrity because he was on the second or third floor. I think he was on the second floor. And he had enough weight on this thing to probably break through the floor. But fortunately, it was a very heavy-duty building. Okay, there's Harold. I'm going to skip around a little bit. Harold was taking photos too. I believe that is a naval antenna of some kind. John would go down to the harbor and they would just give him stuff. That is a machine gun. Because in Canada you can buy those and store them at home. That he may have created himself. That's the outside of his lab. Let me see, I'm going to fast forward through some of these. Yeah, so he was on the second floor, I believe, of the 3-story building. I have a lot of repetitive shots in here. It was at the time I didn't know I was going to go back up. It was a 2.5-hour drive from Seattle. So actually, I'll start at the beginning here. So that was John's legendary door. His door was on several TV shows as well. You can see his CIA sticker there. I believe John Alexander, as well as some other folks from the CIA, actually showed up. So John was not with them, but that's all right. This is just some of the equipment. So if you can imagine a 1-bedroom apartment, and these walkways, most of these are like a foot to 18 inches wide. Everything is full. A lot of this is just surplus naval equipment. A lot of this stuff is just for show. That's one of the chains they made him install. Now, most of these photos, I should just mention this, most of these are shot in night mode. His lighting really sucked. When he had TV crews come over, the TV crews would bring their own lighting and set it up and trip over each other. And I mean, again, an 18-inch walkway is insane. When I did my interview with him, he actually kind of kneeled down, and I was like at this weird angle, and then I had the camera in IR mode. And so you can see these are some of the shots. He talked to me for like an hour that way. He had like a cot that was in a corner. It was like under a machine that he slept on. So that, if I remember right, that's an old naval compass. Most of this stuff didn't actually do anything. Most of the stuff at John's apartment didn't do anything. What it did do is, if the Hutchison effect is some kind of an electrostatic effect, the big thing to keep in mind is his apartment complicates the area because it re-radiates everything. So it may be impossible to recreate the Hutchison effect normally because it may come in part from the structural setup of that apartment, and it was really random. I mean, it was a junk job. So this is a, I believe that's a Tesla coil. I believe John made one of these. That may be the one that he made. Let me see. There's the compass. There's the Tesla coil. Sorry, here's my spot. That is some broadcast equipment. That's a sideways shot. You can see the chains securing things. In that case, the chains are securing it to a table that is near the floor. Top of the compass, broadcast equipment. I wasn't able to shoot everything. I mean, his apartment was pretty insane. And again, just, more toys. And those are the samples. Let me see. I think that was pretty much everything I had for John. Yeah. Yep, that was it. So those are my photos. So yeah, I would say, guys, if you want to watch the whole thing, I'll just pop it up real quick and show you what I have. I should apologize for not being super structured. I've done presentations in the past where I run through them and they're a little bit more coherent than this. I'm just going to show you. This is happening. I believe I shot 2 of these. I'm not sure if they're both up online. That's Gary Stevenson, who you all know very well. You can see John, he's kind of crouched down. He was actually hiding underneath a piece of metal that was kind of in his walkway. And I had the camera kind of positioned for me. And then we just tried to shoot some other stuff as well. My goal of going up there was everybody who goes up to John's apartment in New West, all these TV crews, as well as other folks, you had a lot of wealthy people who go up there. They would shoot hours of footage. You can only see a minute or 2 online, And so my goal of going up there was I wanted to try and capture what is it like at his apartment, in his lab, with his samples, and talking to him. This 1 minute to 2 minute thing is not helpful. It doesn't help you understand what might be happening. So that was the reason that we went up there and did this. And so that's that one. Let me see. So you've already seen the master. There are a couple of other interesting ones also. I put these up. This is probably worth watching. So this is, again, Super 8 video. George Hathaway shot this to document here. So this in this video, George is going through and literally describing the different pieces of metal. A few of those, in fact, right in front of him, you can see the brass bar. So a few of those. There are a few there demonstrated that I did not see. John had more that he didn't show me. It was just too busy. That may have been the wedge that was standing on edge. I'm not sure. So George goes through and describes all of those. So that one is probably worth watching if you want to learn more about it. And there was, let me see. I have John Hutchison describing it too, but I am not sure where it is. In those links, this is my other interview with him, if I remember right. Nope, that's not the right one. I've shot 2 interviews with him. Here's the other one. just so you guys kind of know what's in those links that I dropped. And again, this is just talking to John. So he's really good for interviews. He's a talker. John is brilliant, but the thing to keep in mind about John is he is very much a tinkerer. He is not a physicist. And so the physics that he knows comes mostly from other people who have investigated the effect. John's focus has really been on creating it, experimenting with it. And my impression is that it doesn't happen that often for him, right? So there's that. There is one more that's probably worth showing you. I was going to come back to this, but I'll just put it up. I'm not going to fast forward through this all the way. No, wrong one. Harold Burns. This is mostly sound. I'm not even sure if you'll see it. Harold Burnt was at John's house. Again, Harold lived about 20 miles from John. He hung out with John quite often for a period of time. Harold was at John's house filming. And if I remember right, yeah, there you go. There you go. That's the effect. So what's important to notice here, this one never made it on TV. He sent this to me. Here, let me see if I'll back it up. Harold was filming. John was experimenting with his effect. Now, what I need to explain is the equipment that's moving there is chained in place, floor-to-ceiling chains, right, structural supports. The effect is happening from that tube, that light tube, that cathode ray tube or whatever. They were experimenting with that to see if anything would happen, and they're running different voltages into it. Those equipment racks, you can see they're still vibrating. That's, if I remember right, that's something like 3,000 pounds of equipment. That's like a ton and a half of equipment. So what Harold actually called me he was so excited. He actually called me and said, "Tim, you're never going to believe what happened." And I was like, "Okay, what?" Well, he described the situation. He said, "We're testing this tiny little light. John has this thing hooked up to it. And, this was one of the last times that John did this because the city officials actually got upset with him. They had asked him not to experiment with the Hutchison effect because it was pissing off his neighbors. And he decided to test it just to kind of see what was going on. And they ended up with that. And it shook the racks, and in turn shook the whole building. So, okay. So let me remove the spotlight. That was just about half an hour. I hope that was okay. So I'm happy to do Q&A on this, and I will unspotlight myself, and I'll just answer Q&A as well as I can. Okay, Michael, go for it, sir. Oops, just disappeared.
So,
oh, there we go.
So that was very interesting. So I especially enjoyed the last part because it seemed to suggest the source of what we might be observing there. It appeared that what he was playing with there is what's called a pi string. You ever heard of that?
Yeah, I believe so.
Microwave oven?
Yeah, and now that was later. I'm not sure. So what I can tell you about John's equipment is he has had 2 up to 3 Tesla coils going together simultaneously, not always, but sometimes. He has worked with Van de Graaff generators. He has also worked with naval broadcast equipment, right? Stuff that should never be fired up inside of a house. But so he's worked with a lot of different stuff. The Klystron is an additional piece. He would have to be the one to tell you how often he used all of those together. What I can tell you is, again, the piece to remember is his stuff is primarily electrostatic. There's very little, like he's not using a lot of magnetic coils. The closest he gets to a coil is like a Tesla coil, right? So it's primarily electrostatic, and it is in a building that is packed to the rim with metal. So whatever kind of field effect he's creating is incredibly complex because it's all re-radiating.
So when you say static, you're not saying he's applying direct current. It looked to me like he was using AC.
He's using both. He's using both. And if I remember right, I think the effect has happened most often when he's using like a Van de Graaff, which puts a DC bias on like the entire room, right? So you use a Van de Graaff, and then you use then he would use the Tesla coils also, you know. And he also had tunable. One of the things that they've talked about was he had tunable knobs on some of the radio equipment, and he would say he would start to turn the dial, and the effect would happen, you know. So one of the things that and the reason I mention that is Colonel John Alexander from SRI, and I think John was working with the CIA at that time too, or something. They sent a team in the 1980s to investigate what was going on there, and they spent, if I remember right, about a week with them, and they saw the effect happen. If I remember right, that they wrote a report on it and said at the time, in fact, what they call it, there was a story written about it called the Poltergeist machine. They believed that it was some kind of a machine-enhanced psychic power, if that makes sense. And what I had said to them was, I'd said, because I talked to John about this later, and I said, why did you pick that? Well, part of it was, at the time, SRI was getting paid to find psychic stuff, so everything they found became psychic, right? That was, yeah, you know, that was part of it. That was, you know, they were the remote viewing guys, so they were psychic everything. But the other part was, I felt like I've known people who were hands-on, and like when John is turning those dials, he could, you know what I mean? He could feel, yeah, you know, and that's not just him. That's any machinist, right? My ex-wife, my first wife's father was a machinist. He could turn a dial and know when to stop turning it by hand, and that's something that no PhD physicist is going to know. It's
you got to do it. You got to actually do it.
Yeah,
it's a failure. You gotta fail over and over and over and over and over again, and then finally get it right. And then you have to repeat it, and it's the repeating part that's the most difficult. It's go back and get it and do it again, okay? And so, but my other observation was that when you looked at a ferromagnetic material like steel or iron, or if you looked at aluminum, which is not ferromagnetic, you know, you can't pick it up with a magnet. The non-ferromagnetic materials look like they're the ones that showed the domain structure.
Yeah.
The ones that the ferromagnetic materials, they were amorphous, and when you looked up close, it looked almost like it had melted at the molecular level.
Well, and it's interesting that you mentioned that, because the only theory, and George Hathaway experimented with this too, he went away from this idea, and I never understood why. But so chemical bonds are all electrical, right? I mean, when you get down to it, chemical bonds are all electrical, and it's all based on valence orbitals. It's all based on that outer band electrons, right? They share electrons, even in metals.
Right.
And my thought was, just like a microwave oven, if you have enough frequencies and resonances, and it's random, you might be able to bump those valence electrons out of position, and you would permanently bump them, right? Because, you know, so the orbital might be here, but you're shifting that orbital over here. It can't bond chemically, so you might have a solid that would turn into a jelly.
So I'm curious if they weighed these objects before and after Hutchison Effect, and was there any effect on the weight? So the reason I'm asking that is it almost appears like, for the example where you, before and after the aluminum bar, you have a higher concentration of dopants after. It's almost like the aluminum is disappearing somewhere.
It's possible.
Away, but I would think that would show up in the weight of the thing after. So do you know if there was any before and after measurement of the that I don't know about.
I
don't want to monopolize my time. So
Oh, okay. Well, yeah. Let me go to Aiden. Did you have something? Because I'm getting some echo.
Yeah, a couple. In one of the photos with the aluminum and the bar, it looked like there were the little dots. So, did you see any of the photos that correlate to Bob Greenyer's presentation and the EVOs?
Oh,
I mean that was a very he did
Great
get into
question.
Hutchison stuff, and then the other thing was like circa 2013-14, there was a Hutchison video of like a bar on paper towel, and then it just goes and it disappears and shrinks, and I mean it's gellifying, but I can't find it anymore. So yeah, those are my questions.
okay. Sorry, I'm gonna mute you out temporarily because I was just getting really bad echo. So yeah. Oops, sorry about that. In terms of, let me see. I didn't see the more recent video, the 2014 one. I haven't seen that at all, so I can't speak to that. The paper towel that you mentioned. And sorry, what was the first question again? I just blanked out.
EVOs, Bob Greenyer's EVOs, and it briefly in one of the slides where you're doing a close-up of either like the wood or the aluminum with the knife in it, you can see these little, it looks like there were little dots or trails or something going through the metal, which would be a second data point for Greenyer's presentation and hypothesis, or so.
Oh, sorry. Okay, let me. I just muted you out so I could answer. So with EVOs, that is not something that I know about. But what I can tell you is, historically speaking, because I was on all these news lists. So not Bob Greenyer. I think he came later. But Ken Shoulders and John Hutchison were like best friends. These guys emailed each other 4 or 5 times a day for like years. I mean, so Ken Shoulders and John Hutchison. So you might ask John about that, and John would probably say yes. He could probably give you a ton of information on EVOs because he was really close with Ken Shoulders. So I hope that answers the. Let me go to Charles. Charles, go for it, sir.
Yeah, thanks. I'm a big fan of John Hutchison. I've tried to convince him of the Graviflyer. It's the Hutchison Effect, but he's not convinced yet. I did see on his eBay channel before it went down, he was selling some of the samples. I actually bought some for $150. I wanted to buy their bench from him, but he sent these other samples free. And they're like mentioned some of the files that are strangely magnetic.
Okay, so that file, I wonder if that's one of the ones that's glowing.
Possibly, yeah. I haven't been able to see it in the video, but they've also kind of cut off some of the edges that have already been where they broke. I can't really compare it to some of the videos to see which one it is. But yeah, in the future, I plan to study it under scanning electron microscope at my university, part of my PhD in electrical engineering. But right now, the university's kind of closed down, so it's hard to get into to study it. But did he ever offer to tell you any parts then when you saw him?
You know, I think he offered to give me some. If I remember right, he offered to give me some, but I declined. To be honest, I wouldn't want to separate his collection. I know that sounds weird, but he's got, you know what I mean? This was several years ago, though. He was doing a lot more TV and radio. This was before he sold his lab, before he moved. So things are kind of in a different position now. But yeah, I think if I remember right, he offered to give me some. And I said, well, really, for me, the photos were more valuable. That was the value, you know. And the thing that was exciting for me was that was the first time I was aware of that anybody really took the time to do close-up photos on the metals. So.
Yeah, no, he's been trying to sell them on eBay, but he recently took down his eBay after 2,000 objects sold and 100% feedback. But there was some issues with his paperwork. eBay updated their rules for what would be allowed to have an account, so he didn't qualify anymore. He's still selling them on his Facebook.
Oh, I was going to say
lab investigations.
Yeah, I was just trying to think like what eBay rule would that violate? It would probably violate all of them, you know.
National security.
strange alien parts that have been modified by Lord knows what, But no, it's cool that you got some of the samples. I would bet you if you put them under an electron microscope, at the very least, you would find massive disruption. What my gut tells me is that it's electron orbitals, right? It's like sticking it in a microwave oven, more or less, except that it's at high enough frequencies, and it's not just one that you would have to affect. You would have to affect probably, like in iron, you probably have to affect like 10 or 20, and then depending on how much of it gets affected, they can't bond, and it behaves like jelly or a liquid. And then of course the minute you turn the field off or it moves outside of its sweet spot, then those orbitals bounce back to normal and nobody can tell what happened. So let me go to Mark next. Mark,
You should let poor Gordon, because he's holding his hand up physically.
where's he at? Oh, Gordon. Okay, let's go to Gordon then. Gordon.
I'm muting myself. Hi, Tom. Yeah, you kind of touched on what was going to ask with the comment you made there. My sort of knowledge area is materials sciences and stuff like that. One of the things that immediately struck me looking at the images was there seems to be some sort of potential induced form of non-Newtonian rheological behavior. In other words, what you're doing is changing a solid into a different format with some sort of phase shift that's induced, and then it goes back to being that solid in different format, and then the whole structure of the thing has been interfered with and messed about with to appear then in the state that it appears. And you might even find that the whole sort of metallurgy of the thing has actually changed a bit to.
Oh, I would imagine, yeah.
That is extremely interesting. That's probably what these CIA guys were interested in, because the potentials for a directed defense or attack weapon of some sort that could adopt that or include that would be of extreme interest to military side.
I think, I would agree with that. I think what's more interesting is if you could imagine being able to weld metals with no welds, right? Or construct an airframe out of one solid piece of metal, right? By just bending it and shaping it, and so yeah, I think, that was kind of where I ended up, was if it was the electron orbitals, and you could basically, it was like you were simulating different materials, and maybe you could be simulating materials that never even existed, simulating new substances, right? Because if you could make iron behave like it's half this or half that or something like that, it's something new. So yeah,
I can do that with products at the moment. Products that I've not experienced in optics, and one of the products I'm involved with for the last few years, and no longer involved with it, is a contact lens you stick it in your eye. Inside that contact lens is a material substance that's semi-solid, and then what happens is when you're here in the body, actually, it's eye movement and pressure that actually uses that non-Newtonian rheological principle to actually change it into a dry eye drop, which is then fed into your eye.
Oh, there you go.
That's very similar to the sort of metamorphosis change that's happening in these images you're actually going in.
Well, the other thing that is interesting, I think is very notable, is so when I got into John's work seems to be very closely related to the Philadelphia experiment, the way it was reported, right? Now again, that's our modern day Flying Dutchman tale. So it's hard to know how much is true and how much isn't. But it is interesting that the Philadelphia experiment story started in the 1950s, and the main outline for it was written in the 50s, and then in the book in the 70s, it was written down by Berlitz and Moore. And so here John comes 5-10 years later, and he's actually demonstrating the same effects using similar
Base change,
equipment.
and you've got these stories of guys that have actually come
Melted into the deck, yeah.
melted into the ship, yeah.
You know, and it is very well documented that they tried something on the Eldridge. You know, in fact, the ship, I have photos. Maybe I'll do a presentation on that. They have photos of the Eldridge. It's still even after the military surplus got sold, it they ended up with the Greek shipping company. They had enormous power cables, like enormous conduits. We're talking like, I don't know, 8-inch copper cables, right? Like, and they would just been sliced off because something had been removed from the ship. This was on the outside of it, and then on the inside of the ship, I do know. I'm digressing a little bit, but people ask why the Eldridge, right? Why would the U.S. military pick that destroyer escort? It was actually one of the first electric drive ships that the Navy made, and if I remember right, they had something like 200 megawatt generators, and so what you could do is you could actually redirect those generators. I think they were turbo diesels. You could redirect those to a coil system, and they had a coil system on it. It looks like they added one, but it originally started with it had enabled Gaussian coils in it. So the entire body of the ship was wrapped in coils. So yeah, there were a
Tesla
lot.
and Einstein that were supposed to be involved in that experiment.
Yeah, and there was a lot of research that went into it. And in fact, John Hutchison worked with, I forgot his name, he was one of the guys from the Ghost Hunters program. One of the questions was, what was the Navy trying to do? And they said, well, they were trying to make a ship invisible to X-band radar. And they were trying to do that by impedance matching on the hull, right? And so John and this other fellow tested that with a scale model, and they tested the block of iron, and they were able to do that. They were able to impedance match and make it visible to the K-band radar, if I remember right. It was the use of time. I think today is X-band, and that wouldn't work. But for World War II radar, yeah, they were able to make it visible. So, okay, well, let me say thank you, and let me go to Bernie after this. Bernie, go for it, sir.
Ooh. Hello, thank you. Sorry about that. That was an awesome presentation, and I am very jealous that you got to go to John's work lab back in the day there.
Thank you. I'll try and do something in the future that's more organized. I just wasn't sure.
You're being way too hard on yourself, Tim. You were. It was an amazing presentation. I don't think anybody can argue that. I've been talking to John. Baroness Carla Knipchen Hutchinson on his latest YouTube channel, and he's agreed to come on to my podcast here, and I'll try to arrange it with Jeremy so that we can do a joint interview. And seeing how it is 2022, don't be scared off by John's cross-dressing. I have a character called Crypto Bender that is a fembot that is a half female mannequin, half Bender head. So hopefully he's comfortable with that. Whatever, you know, who knows, right? It's like, even if you're exposing yourself to that sort of radiation, how it might affect the mind, right?
That's good. That's a good point. Yeah, that is. He has definitely absorbed a lot of RF over the years. There's no doubt about that.
Right. So if he
yeah,
wants,
that's good. You know, I would say send us over the link, right? Send us over when you get him up on your podcast. Send us over.
Yeah, ahead of time I'll arrange it. So I'll try to get you on there too, Tim, for sure.
Everything that I talked about today is really old material. I mean, I know he's done several things in the last few years. I haven't stayed up on it. I talk to him occasionally. I've been trying to get him to come on, and he has said sooner or later he will.
I'll talk him into it. I'll twist his arm, or Carla's, either or.
It's been over a year at this point, so I just said heck no.
But yeah, in the past just the week alone, he's posted a video of him salvaging on a diesel submarine as well as a destroyer. So wherever he's based right now, one of the navies is helping him out and letting him take some pretty high-end material there. So it will be good to get updates from him.
Well, Bernie, thank you.
Thank you, Tim.
So let me give the Harold next, sir.
Yes, excellent presentation, good information.
Well, thank you.
My question, I have a two-part question. The first part is, when those pieces of metal are lifting up in the mid-air, well, it looks like an anti-gravity effect, something like that. I mean, has anybody theorized about that?
Yeah, in fact, one of the first, it's kind of one of the more famous papers that was written about it. George Hathaway wrote it. It's called the Hutchison Effect, a lift and disrupt system. So it's interesting that when you mentioned it lifting up, that's exactly what George called it, a lift and disrupt system. The disrupt is the jellification part of it. And what's interesting is, I've got my theories about the material samples, right? I could be right, I could be wrong. I have never heard any good theory about the anti-gravity effect. I've never even heard a bad theory. I mean, nobody has a good guess. I can tell you, the skeptics have said that they flipped the room upside down, which seems a little ridiculous, or they simulated a room in a box, but that seems equally ridiculous. And it's also not practical. It wouldn't explain. For instance, you have waters. They're not water. You have liquids that flow. You saw one of them. You saw a liquid that was flowing against gravity. But it started to do that from the ground, right? And so it's, if you flip the room upside down, it would just fall out. But that's not what happens.
Yeah, and my second question is, does anybody theorize that might be used for a gravity generation, let's say, in a spaceship? You know how it floats up, but if you put it on the other way, that means the vacuum of a space, it will form, for example, gravity effect, in which the astronaut, for example, on the spaceship would be feeling the effect of gravity because something is putting those up. The same thing can be done.
Yeah. I think it would be easy to use that if it was more understood. And again, I've just never heard the good. I think when you have something like the Hutchison Effect, part of it is everybody likes to grab examples like that to prove their own theory, right? So you've got 20 or 30 different people who are like, that's the Hutchison Effect, that's what I'm doing, that's why my thing works. They use him as an example. But I've never seen anyone dig into it and say, this is why this levitation effect happens. What I can tell you is it affects metals, plastics, it affects liquids, solids. It seems to affect all sorts of different things.
Tim, it's George Hathaway here. You might direct them to my book.
I would love to, George.
Might be some explanation.
Yeah, well, and George, if you'd be open to it, would you be open to speaking on this? This is your bailiwick. I'm a horrible reporter compared to you.
No, there are other questions before me, so I'll sign out until the appropriate time. But I can answer some questions should people be interested in asking.
Is Tim? Are you asking if you'll do a presentation in the future? Is what you're asking, correct?
Well, yeah, George. If you would be open to it, I would love to have you on do a presentation. Or if anyone has questions for George, if you'd be, So, do you want to do this since we have George with us? Does anyone? Yeah, I see Jeremy Reese is getting excited. Jeremy, would you like to ask a question for George?
Probably lots of people.
Well, yeah. We have access to a bunch of equipment at the lab right now, and I was curious. We got to do an experiment and try to test this on some block of aluminum or something, and that's what the metal that he used in that experiment was, aluminum, right?
Are you asking me what?
Yeah, I want to know specifics on metallurgy for setting up an experiment, and I want to know specifics on what kind of equipment we should be.
That would take a long time.
Well, they could probably learn from your book, right, George?
Yes.
Oh, there goes my idea.
Might be a better idea. Go through the book, which is called the Hutchison Files, and I think it's 1991 to 1995, something
integrity research, and he's selling the book at the moment on my behalf.
Okay, and I'm going to write that down as well. So the Hutchison Files 1915, integrity. But now, George, the majority of your work was in the 1980s, right? When you guys analyzed this.
That's correct.
Yeah. And then, hopefully I didn't get any facts wrong. I've had to kind of piece things together, and it's been quite a while since I've covered this.
Well, there are a few stretches here and there. I should say that my involvement was in the late 80s and the early 90s. And that was the time when the most interesting effects were going on and the most material was being produced, the most unusual levitations, which I saw some. I saw metal breaking apart, and I saw weird stuff happening with liquids and semi-solids, along with other people, and tried to document it. But then, as time went on, into the late 90s, John was involved with other folk. Our involvement with John Alexander had stopped at that time. And then as the 2000s broke, John became much more involved with media and was much more interested in, thank you very much, Tim.
Oh, yeah, sure.
Much more involved with trying to retrieve, I should say, his innate gifts, which unfortunately, in my opinion, had dissipated to a large extent. And he was no longer able to perform, you might say, the same kinds of feats that he had been able to in the time that I was involved, which happens with others as well, of the same mindset, you might say, or the same kind of approach, a conscious approach, and a conscious affinity to the machinery that he was using. And I get into that a little bit in the book, too. So, anyway.
Has anyone continued this work, or do you know of anyone that has also replicated this work, or anyone that has worked, or you guys just worked, just you and John, and then that was it?
No one attempted to do the kinds of analysis that I did, even though my analysis was with rather crude equipment. Tim might have, according to your intro to this, and Mark's intro to this meeting, Tim was going to show some scope traces. Unfortunately, I wasn't able to get on right away.
Oh, yeah, and I did, George. I did show those. Those are the ones that you gave to John, and then he let me photograph those. So
yes, and they're reproduced, some of them in the book. I was surprised that no one actually took the time, first of all, to believe that there was something unusual going on, and secondly, to try to instrument it better than I could, and try to determine what, at least electromagnetically or electrostatically, was going on. Unfortunately, that didn't happen, and it has not happened since, primarily because, in my opinion, John lost the ability to affect the metal in the way that he had during the time that I was involved. There were some minor effects, as Tim has shown in some of the presentations tonight, after the 2000, the late 1990s. But to answer your question, Jeremy, no. I am not aware of anyone who has been able to have an effect in front of them, as I had, have some equipment, as I did, in a space that would allow some kind of coherent measurement, which was barely possible with me, as you saw with Tim's presentation of how dense that at least that lab in New West was. And I didn't do tests in that New West lab, but I saw it. I was there for sure. So sadly, no one has picked this up, and I'm afraid to say that the likelihood of someone actually being able to test and measure what John was able to produce has basically vanishingly small.
So one more question. I thought in some of the older videos it said that people from the U.S. Navy sent some scientists there to observe the work and take note of it at some point. When did that occur, and any details about that? Did things stop working mysteriously after they visited the lab? Or
you may be referring to what Tim presented with Colonel Alexander. I'm not sure whether that is what you're referring to. I am not aware that there was a specific U.S. Navy deposition. There certainly was that John Alexander put together a team from Los Alamos, and that was the team that came up under my supervision and my associate Alex Pizarro, who were working with John, and we had arranged with John Hutchison. We had arranged with John Alexander to come up and try to figure out with some of their equipment, which was very minimal, because most of them didn't believe that they were going to see anything unusual. So they only brought the most not primitive, but the minimalist equipment. And that was in the early 90s, as far as I recall. Most unfortunately, due to John's mental state at the time, he was so concerned that he wanted to make a positive show, you might say, that the only thing unusual that happened was that a transformer blew up and a few things fell over way at the back of this large warehouse that we had arranged for these demonstrations to take place. The folk from Los Alamos, two of them were believers, including John Alexander, that there was something unusual that had happened. And the remainder of them were either neutral or one was highly skeptical. And the one that was highly skeptical was a physicist who John Alexander had arranged to come. And this physicist put the kibosh on it, said, "This is total crap. We didn't see anything that John and George had claimed that we would see, and therefore we should give up." And unfortunately, although John Alexander wanted to pursue it more, we were not able to continue with that contingent from Los Alamos. Other folk had come up from time to time, as Tim has talked about. They saw this or that very minimal activity, nothing like what Alex Pizarro, myself, and a couple of others, as I mentioned in the book, actually saw with their own eyes and touched the material, gave John pristine material to put into the field and have it destroy itself or lift up. So unfortunately, I guess the long-winded answer to your question is that the group from the U.S., the Los Alamos group, went away essentially empty-handed.
Now, George, if it's okay to ask, do you subscribe, because from what you're saying tonight, it sounds like when you say he's lost the effect, do you subscribe to this idea that John has some kind of a psychic connection to it?
Yes, that is the only remaining reasonable, given what I know about electromagnetism, which is a fair amount, but I'm an electrical engineer, and I've studied really wild electrical and electromagnetic effects in my past, and I've also studied
the effects that the mind can have, if you might say, or the consciousness can have on materials, not John's, but others, that as if I have 5 possible explanations, 4 of which are so-called electromagnetic, one of which I'll remind you in the book was by Tom Bearden. He claimed that he figured out what was going on, and I don't subscribe to that. But if you give me 5 possibilities, one of which was some kind of consciousness connection, which was amplified perhaps by the electrostatic fields or something like that, I'm not saying that is it. I'm saying that is the most reasonable one that fits all the parameters that I'm aware of. And therefore, if you are not you, the John Hutchison, are not in the mindset that has produced these kinds of effects in the past, they won't occur, no matter what kind of material, no matter what kind of fields you concoct, Tesla or Van de Graaff or KU band or whatever. And that was borne out by the fact that early on, John suffered, before I met him, and I knew him, but before I actually met him, from some somewhat serious mental health disorders, I'll put it mildly. And he had some, let's say, pharmaceutical assistance. And during that time, he was suffering. And it was during the time he was suffering that most of the effects, of the strongest effects, occurred. As he became more and more, you might say, normal by the use of some pharmaceuticals that helped him out, he lost the ability. Slowly, it pinched off. And as he became, you might say, his now John Hutchison self, playful, energetic, a bit screwy, you might say, as Bernard has talked about, the effect disappeared, or at least minimal. And so, and this has happened, I've followed this kind of thing in other folk as well. It's not unusual. Well, thank you. And I've never heard that piece of it before, but that does explain it a lot more, I think. Well, it gives you pause to think, at least, that if the mind is in a particular state, perhaps of agitation or of a heightened emotional state. You've heard where, it's well documented, for instance, that someone who is very slight of build, perhaps a woman who sees their child about to be run over by a car, can lift the car up with one arm and exhibit extreme feats of what you'd consider unusual capability in a super agitated state. And this might have been associated with what John was able to produce and concentrate on.
So like a higher consciousness.
Because it's, I've heard, and that was my concern about the SRI stuff, was I always looked at it like cart before the horse, because they went out hunting for psychic stuff. But the way that you're describing it now, it's a much more rational approach, I guess, to
Yeah. I guess I'm just even more confused, because it's like I'm asking for some keys. Like I was expecting like a frequency range, or a certain voltage, or some some limit that you
energy.
Is there a list of the frequency range anywhere?
But it's like you're telling us that the secret to this is to take drugs and change your mind state and do telekinesis. And
No, what I'll answer your first question. I was with John long enough that he went through about 4 or 5 different iterations of his setup. He started with Tesla coil A and Van de Graaff B and a medium wave oscillator C, and the next and stuff happened. Then he moved to he removed one piece and he put another in, a specially wound coil. Then he when we moved him from his Lynn Valley operation to another location prior to the one that I was talking about with regard to the U.S. folk coming up. He had a different Tesla coil. He wound his own new, larger Tesla coil. He actually got rid of the Van de Graaff. He used a different kind of AC RF device. He still got the same wonderful activity. So the stuff that I documented, you might say, is just one little slice at one time of one setup that showed an amazing effect. Then he would change it and do something else, and he would get the same effect. Of course, it would take a long time, maybe 6 hours, as he was adjusting, as Tim was saying, adjusting this and that. Who knows what he was doing? Was he thinking about something while he was adjusting? Was he actually considering that, adjusting a frequency of some naval device made a difference? I don't know, but that is why I am concerned that people try to grasp a specific experimental setup to see whether they can reproduce the effect. More power to you if you can. Wonderful. That would be great. My concern is that so many people have tried this, and I know since 1997 or so, and the early 2000s, 3 or 4 folk that I know have tried to set up the same kind of thing that they saw in one instance of what John set up, and failed completely. I mean, there's absolutely nothing happened as one would expect, you might say. In my opinion, they were missing a fundamental ingredient, and that was maybe something up here, or someone else is up here, or wherever you want to locate consciousnness.
And of course, the physicists are going to ask, well, if we're emitting something from our brains, how do we measure it and how do we detect it? And there's this whole thing of biophotons. I don't know if you've heard of these.
I've gone through it all.
Anyway, it might be something worth looking into in connection with it, but it's certainly
or the Killerian frequency, is it called? The Killerian frequency? Killerian, there we go. That's the one.
Yeah.
Sorry to interrupt. Is there a documented wave list of the frequencies John was working with? I'm just interested for my own electrolysis experiments on what ranges maybe to try. Just putting into trying to get some more transmutations out of the electrolysis that I'm currently doing.
So are you asking me, or are you asking?
Yeah, George, or the community in general. Just either or. I think it goes to Jeremy's
George
question.
Is a million times better to answer any of these questions than I am. I didn't know he would be here, but I'm incredibly appreciative, sir.
George, are you saying that John Hutchison had telekinetic power back then?
I don't know. All I can say is that the best guess that I can come up with is that he did not have telekinetic power, but that he used electromagnetic fields of some sort
to amplify or ride on to do what he did. So it was a combination of the kinds of equipment, the spark gaps producing all sorts of noise, therefore no specific frequency, Bernard, and other and all sorts of other weird and wonderful devices, along with his concentration, whatever it was. One thing I don't know, and I was not there at the time, is whether any of his subsequent experiments after the time I was with him, which was finished off basically in the mid to late 90s, could be ascribed to his own, you might say, telekinesis. In other words, could he move anything without a spark gap going off, without a Tesla coil in the background, without a Van de Graaff machine? I don't know. That I don't know. If that was the case, then you might say, given that someone had made sure this wasn't a hoax and that John wasn't fooling somebody, then you might ascribe it to some kind of telekinesis. But I don't know. George, Mark Sokol here from Falcon Space. Have you had any success with Alciphon working with Daniel? I know you guys worked on it a couple of years ago. Is this the space to answer that question, Tim? You might want to
sure. No, George, I can't thank you enough for joining us. So yeah, I would say go for it. Whatever you want to speak on, sir.
Well, I was assuming that I would be answering some questions about Hutchison too, but I'll answer Mark's quickly. We've had some unusual effects, let's say, but that was quite a few years ago when we had a sample that was dancing around inside an EPR tube at liquid helium temperatures, and so it gave us hope that at least at X band there was something unusual, and we are attempting to gather together some funds to continue the experiments at S band, which is around 3 gigahertz. Okay, and that was with the Ruby sample, right? Yes, that's correct. Okay, was Dan an interesting component? Yes. It was the interesting component.
Okay. Okay. Well, thank you. Yeah. And so, yeah, I guess anyone else with Hutchison questions for George, you know, and again, George, I can't thank you enough. It's truly an honor to have you on APEC.
Okay. Appreciate it.
George, if I may, one question. Since you're describing what you just said, the statement, that equipment plus his mind may have displayed some kinetic, don't you think that if equipment and the human mind can do that, then wouldn't it be like an assembling the equipment that Hutchison had and the human mind that people can learn to use to have personal telekinetic power? In that sense, I mean, would that be that formula by assembling those equipment and train something like that? Would that summarize basically what you're saying?
I would love to have said that. However, I cannot say that for sure, for several reasons. First of all, there is no single setup that John used that you could put your finger on and say, that is the one that you should use, more or less to answer Jeremy's question. That is the kind of equipment that you should use, and then you should try to concentrate or, you know, go into a meditative state or do something like that. I can't say that is the way. Personally, I doubt that's going to happen. First of all, in my opinion, you have to have
that the consciousness part, you might say, has to be somewhat unusual. So the average type person like me, who has, I would say, an average brain, I guess, and an average outlook on life, compared to John, when I knew him, there was stability and astability. I would be the stable one. John, you might say, would be unstable at the time. So how do you judge, how do you measure that degree of difference in consciousnesses? Can you simulate that? Can you come up with some meditative state or something of that nature? I don't know. Can you, and that's only one half of it. Given that my hypothesis, not my belief, but my hypothesis, remember those 5, that the one that has consciousness and electromagnetism might be the best one. I'm not saying it is, but assuming that there's some validity to that one, you got 2 components. You got the mind and you've got materials or fields. Well, how do you set up the fields? When you look at the stuff that the scope traces that Tim probably put up, you can't make heads or tails of it. I mean, there may be one frequency at 300 megahertz or 30 megahertz or something like that, but the next time we tested it, it was all over the map. It was somewhere else. If you got spark gaps and things like that flashing around, you have no idea what at least in John's case, what the fundamental frequencies are that you're dealing with. So unfortunately, it's still all over the map. The only thing for sure is that somehow John needed to be in a space with his materials that he made himself primarily, or he fixed himself, or he had some, you might say, visceral connection with, to have the effect as strongly as he did. And I'll give you another time type example. After I had to leave the situation, he hitched up with, or another group, a couple of guys who wanted to fund him, thinking they would make billions on John's technology for spaceships and anti-gravity machines and things like that. They set him up in a lab, and he was able to do a few things with his equipment in their lab. This was in the late 90s. And they said, it's great. Okay, John, you go away and we'll try to operate it ourselves. So they tried to operate exactly the way John did. They documented how he twisted dials on various machines and where he put the various devices, the Van de Graaff and the Tesla coils and things like that. When he had them in that case, they couldn't do it. They could maybe get a little bit of electrostatic movement, but anyone can do that with a Van de Graaff or a Tesla coil. Everyone probably on this list probably knows quite well. But no way were they able to get any kind of motion or breaking of bars apart or liquids flying around until John came back. Spent about 3 hours. They said, okay, come on back, get in here. It was the next day. We hadn't touched the material. John started to fiddle exactly the same setup, and suddenly things started to go. Not as much as when we were there with him, but he was starting to break metal apart and that kind of stuff. So, in my opinion, that was another sort of confirmation that John needed to be an integral part of this system. for things to happen. I don't know how. I'm just postulating that it might be a consciousness thing, so I don't know, but or maybe he just was so attuned, like that lathe operator, whoever said before, that he could set whatever material, whatever machinery that was put before him into a particular state, and stuff would happen. That I find hard to believe. I believe, at least hypothesize, that it happened. It had to be part of him, as opposed to what he could fiddle with, or in addition to, I should say, what he could fiddle with. So, unfortunately, what I've been talking about just now breaks open all of this discussion about frequencies and wavelengths and materials and types of Van de Graaff machines and all that material. It opens, it expands it into a real miasma of possibilities.
George, can I quickly ask you, as an example kind of what people are saying, like John's psychic ability more? For instance, when I was first experimenting with electrolysis, I just had a D battery hooked up to a little saltwater solution with 2 coils. The battery had been dead for a few days. And then I walked in with my friend and I looked at it. I'm like, it's going to start bubbling. And lo and behold, the SOB started bubbling and we were like, whoa, it actually happened. So is that sort of the example you'd kind of give in relation to John and his experiments?
Well, if you were able to do that under what might be considered control conditions, in other words, repeat it, have someone document it, someone independently, you can't independently try it, because if you're a fundamental part of it, you can't have someone else.
The Schrodinger effect, correct?
Then you might have something. You might be able to claim that there's some interaction between you and the experiment. I'll contrast that to John. Almost every time he was approaching and fiddling with his equipment, something unusual happened. As opposed to, in your case, once something happened. I'm not denying or downplaying what you're saying, but compared to John, John had this ability to eventually have something happen. Sometimes it took an hour.
For sure. That's amazing.
6 hours while we stood around waiting, and he would be testing things with his fluorescent bulb, and he'd be moving things a little bit here and there, and then he'd go back and fiddle with some tuner on a piece of surplus equipment. And Alex and I would be saying, okay, John, any idea when things might happen? Oh yeah, it's almost any time now. And 2 hours later, yep, something happened.
I see how you're saying it's so hard to reproduce John's controlled experiments.
Do you think, George, do you think it might, would you describe him as being in like a dissociative state? When he did
That's hard to say. He was I wouldn't say it was dissociative. He was with you. I mean, he would answer questions. He would be focused on the machine, on the equipment, but he would know you're in the background. And he'd say, "How you doing, guys? You know, it's maybe taking a little longer than I thought." He usually has his headphones on, and he's listening to the static.
So he was almost consciously within the entire room, you're saying? Like, he shouldn't have been able to hear you because his headphones were on, yet he knew you guys were like coming up to ask him a question, sort of thing.
Yeah, I don't know what you call it. I don't think that's dissociative, but
yeah.
Higher dimensional consciousness, almost.
He was, you might say, hyper aware He certainly was hyper aware of his apparatus. He knew because he built it, he put it together, and it was something, so part of him. But he knew that you were there. He knew that the Los Alamos guys were there. He was trying desperately to show them something. Unfortunately, it was too desperate, and didn't work out.
Yeah.
Tim, Harold, yes.
You heard that, we heard all the presentation that Jack Sarfati did about how the CIA was interested in consciousness and how studying the action of consciousness.
Yeah, see, and that was
world. And what George is saying right now, what is your take on that?
So this, and again, George could speak to this probably better than I could, but this goes back to the Stanford research, the SRI stuff. This goes back to remote viewing. John Alexander was involved with the remote viewing, and they were, at SRI, they were investigating all sorts of stuff. And if I understand correctly, that is where their involvement with Hutchison came from, because they said, okay, here's another anomaly we can look at, right? So,
yeah, that was basically it. They were looking for remote viewers. They were looking for clairvoyance. They were looking for anything that would help them counteract the apparent Russian threat of the same the same kinds of things, and this was part of their mandate. And when they heard about, I'd known John separately, and when I told him, and my friend Alex Pizarro, actually it was Alex, I told him through when they were both at not a parapsychological, it was American something parapsychological association meeting. John was there, and my associate Alex Pizarro was there. Alex said, you might be interested in this guy, John Hutchison. He's able to do this and that. And as close as we can reckon, he's probably he might have some consciousness associated with it. That's when John Alexander perked up his ears and said, gee, that sort of fits in with what we're trying to look for. And so he put together the team, John Alexander, to come up and see whether there was something to it, and that they could help the Army in its quest for understanding the role of consciousness in intelligence gathering, in possibly weapons development, I guess, although he didn't say that exactly. But that was how that was the approach that the Los Alamos team under Alexander came up to see John.
George, what do you think is the state of development in that area today? Does it continue, or it stop, or it may be some black box project, one of the black projects? What is it?
Once again, how much time do you have? And this might not be the best place to talk about that.
Oh, okay. Summarize it.
Well,
yes or no?
That would be
exactly.
Yeah,
we have all the time to listen to these legends and stories. It's amazing.
You know what we probably should do is just kind of
book George.
I'll just call this open discussion, but yeah, we'll just kind of let it roll from here. Let me do some questions. Actually, Charlie had a question, so let me go to Charlie next, who's been very patiently waiting.
Thank you. George has me. Yeah, I'm also an electrical engineer, so I'm very interested in the Hutchison Effect. But he recently said in some videos from John Hutchison that he does not believe that his psychic ability is affecting the materials. So I'm wondering what gave you the idea that it was his psychic ability, and where else have you seen that? If creating Hutchison similar effects.
The reason I hypothesize that is, as I brought up before, the system only worked when he was there, and it didn't matter what kind of machinery was put in place, what kind of fields you might say, electromagnetic fields were, as far as we could measure, were in place. It had to be him there. Whether he was fiddling with it, sometimes it would work, by the way, when he wasn't fiddling with it. He just would sit there and suddenly something would happen. So that gave me the idea that this was more than just somebody putting together a unique set of fields by some, coil arrangements and spark gaps and stuff like that. And I had studied and continue to study folk that have abilities. The easiest example is spoon bending, we'll call it. Just think about spoon bending for an example. People I've seen can hold up a spoon and you rub it a little bit, then you hold it up, and on the count of three, Jack Houck, who actually saw John Hutchison do his thing, would have a party and people would get all worked up and get excited, and then he'd say, okay, everyone's up in a state of heightened activity. On the count of three, your spoon is going to bend. And one or two people out of a room of 30 would see this thing bend, including John Alexander, by the way, who did it himself. So that's a minor example of sort of confirmation that there's something weird going on between matter and consciousness, in my opinion. So it didn't bother me too much to go out on a limb as an electrical engineer and say, we're missing something here that John Hutchison and others have demonstrated. I don't know whether that's answering your question, but maybe partially.
Yeah, that helps. Thank you.
Yeah, thank you, Charlie. Let me see. Well, does anyone else have questions? Oh, Nils, go for it, sir.
Right. Yeah, I really love the answers from George here, and that actually answered my question 100% exactly to the point, because I read years ago that Hutchison was able to produce these mysterious effects, but it was only when he was in the room. When he walked out of the room, things stopped working. So I concluded even years ago that this must have been some poltergeist effect from his subconscious. He probably wasn't even aware of it himself, that he was actually, or his subconscious was actually doing it. But now that I heard George address this, I am very happy and very pleased to confirm my suspicion about this. And this actually relates back to Charles and the Graviflyer again. Perhaps there is some subconscious effect here with the Russian guy, where he has some effect on this device levitating from the ground. If there's no real physics or real electromagnetic phenomena going on, what do you think? Or what does the community think?
I could, Nils, I'm going to drift from your question just for a second to address something that Charles brought up that I forgot. Charles said that John Hutchison now and has claimed for some time that he doesn't think his mind has anything to do with it. It was all the apparatus. That is a recent admission by John. During the time I was with him, he didn't know. He was ambivalent. He thought, yeah, that it might be. So as time has gone on, in my opinion, he has gone away from, I don't know, maybe I had something to do with it, to, I don't think I had anything to do with it. I don't know why. But that's maybe an approach to answer Charles' question. With regard to Nils' concern about other folk suggesting or the possibility of people's minds having to do with the levitation of little craft and things like that. Unusual. That's really, I can't answer that because I have not been there. I don't know under what conditions, controlled conditions, these other phenomena have manifested themselves that you're talking about, that is certainly on all over the internet. I don't have a coherent response to that. Maybe someone else does.
But the principle of the scientific method is repeatability. So if you have an experiment and you can't repeat it, or nobody else can repeat it, you got to start asking the questions. Well, maybe there's some conscious or poltergeist effect going on here.
At the moment, that's right.
So you're saying the key is to always have several video cameras running at all times to capture everything, to document it then.
Right, but you got to repeat it. That's the big one. If you can't repeat it, you got to ask some serious questions.
George, do you think, that Hutchison, John, have changed to say no, his mind has nothing to do? He's after taking so many chemicals to straighten up his mind, and now it cannot reproduce the effect anymore. Is that possible?
Or to add in, could it be like a fear of like the word psychic being like a bias compared to consciousness, right? That he's trying to move away from the word like it being a psychic ability compared to a scientific understanding of conscious, right? Where psychic is like the fringe science, and he's trying to move away from that, maybe.
Yes. John, when I first met him, he was not immersed in a milieu of you might say modern science. He had Tesla was one of his gods, as well as Marconi and the early pioneers, and he did not at the time have a strong opinion about him being a scientist, or John Hutchison being someone who can contribute to science. Recently, as time went on and scientists became aware true and false aware of what John was doing, he said to himself, gee, science, I should be talking science, not psychics. I should be trying to portray myself as a scientist, which he was. I mean, he was exploring, he was experimenting, he was doing science. You might say not in the way normally we consider, but he was doing science. And so it may be that as he wanted to portray himself as a scientist and talk the language of science to the best of his ability, he became less and less conversant, you might say, with the possibility of psi or psychic abilities, which I would say is sort of reasonable for someone to, if you're trying to attract it. He always was trying to attract a scientific explanation for what was going on. And to this day, he says, as far as I have talked to him quite a while ago, but I want science to understand. I want to find out what's going on science-wise. And unfortunately, science gets back to him and says, well, get rid of this psychic nonsense mumbo-jumbo. Talk about fields and talk about wavelengths and talk about rise times and that kind of stuff. So John says, okay, I'll try to do that. So he does to the best of his abilities, and sort of drifts away from that weird psychic mumbo jumbo. Anyway, I don't know that. also answers your question.
That does.
George,
Thank
this
you.
has been amazing. It is amazing. I mean, I would say talk as long as you want, or if you know.
I only have about 10 more minutes.
George, can we book you to come back though and do a full-on presentation in the future, please?
Well,
we have a full 2022, so anytime in the next year, you are welcome back to do so around your schedule.
I second that. You should come back.
I'll talk to
Enough
Tim
to
about
say.
that.
Yeah, I'll ask him what his scheduling is, and yeah.
Thank you so much,
George.
sirs.
I can't thank you enough for coming today. I mean, you know, and I can kind of muddle my way through it, but like, really, I'm just kind of coming in after the fact, and looking at like, you know.
I appreciate that. And you've come in later on. I had the luxury or the bad luck, depending on how people look at me, of being there at the beginning and seeing for myself. I mean, I don't think anyone on this list or anywhere else, a couple of guys might still be alive who actually saw it with their own eyes, the majority of the major stuff that happened. But I appreciate your trying to pull together some kind of coherent story, Tim. And if I can help fill in some of the gaps, I'm honored to do so.
Oh, sure. Well, yeah, absolutely. I mean, really, what I came away with was when I visited John, and again, I went up several times, but I noticed that in terms of the samples, and it wasn't you because you did really good documentation, but like, you know, these media channels and, you know, Coast to Coast AM and all that, they would describe this stuff, and it's like they missed a lot of bits and pieces that were important. You know, and like this effect starting in the middle of the aluminum bars, you know, I saw that with 2 or 3 of these samples and some other samples, and I was like, wait a minute, this matters, and nobody's reported this, you know. So
well, I can talk about that a little bit too sometime.
I mean, do you think? I don't know. I just assumed it was some kind of a wavelength antenna idea, but.
I wish it was, but there's no relationship, unfortunately, between the dimensions of the kinds of pieces that John has disrupted, you might say, and the any kind of recognizable wavelength in any of his apparatus or the fields, certainly that I measured. There was no relationship. There was a general geometric relationship, as you're saying. Things would happen usually in the middle, or in the case of one of the files, it would divide into 4 pieces of more or less equal length. Trouble is, they would divide in ways that the magnetism you wouldn't expect if the bar was magnetized the file was magnetized the normal way. So it's really hard to make any generalizations about the relationship between the samples and what his so-called fields were. It'd be nice to, wonderful. Oh, there's a data point we can hang our hats on and say, you know, if I see something that in my lab that has sort of a dark area in the middle, that means maybe I'm reproducing the Hutchison effect. That may be, but it's there's not really in my opinion, a hard and fast relationship. Sorry, I know there's no relationship between the kinds of fields that he was producing, at least when I was on board, and the geometry of the weird metallic activity or even non-metallic activity.
Yeah. Well, and he'd had other things too. He mentioned, what was it? He said there was a glow once. I'm not sure if you were with him with that. If I remember right, he said he put his hand into it or something like that.
Yeah, I got 5 minutes, by the way.
I'm sorry. Well, you know, I don't want to keep you any longer. Why don't we cut it short now, and I'll contact you if you're open to speaking more. But
yeah, well, there's a whole lot about the Hutchison effect. A lot of it's in the book that I hope folk can take a look at, or at least call Tom Vallone, who's been on this program before, as far as I understand. and order the book through Tom.
Can we do a day with George, Tom Vallone, and Michael?
Well, let me
presenting.
let me talk to George, because I know his schedule is busy and he has his own projects and stuff. But yeah, well, so I think for right now, why don't we let George go? But George, let me say very sincerely thank you. It has been an absolute honor, guys. Let me do this. I want to put it on gallery view, and everyone, please give Mr. George Hathaway a giant applause.
All right,
for answering questions that I would never in a million light years be able to answer on John's work. And so hopefully I was able to set a little bit of the stage, but thank you so much. Thank you so much.
Yes, indeed. And, people can email me with questions if they wish. And,
please put your email in the private chat if you don't mind before you leave, George. Thank you so much for everything.
I can tell you it's pretty easy. It's George at HathawayResearch.com.
Okay.
George at HathawayResearch.com. Okay.
All one word.
Wonderful. Well, so let's do this then, George. Thank you yet again. So what I'm going to do is put the hands down, and I want to go to Mark Sokol now, and Mark can give us some lab updates. Mark?
Hey, see ya.
Thanks again. Mark's being a little slow. Maybe he stepped away. What we could do instead, we'll give him a couple more.
Okay. There we go. Are we ready?
Yes. Updates, sir. Please.
One second. I can't hear anything. Can you guys hear me?
Yes, we can.
Yeah.
Hooray! It's Mark at Falcon's Face.
I can hear you now. Okay. Yes, that was quite a presentation from Tim and then George Hathaway showing up. So we have some new updates here from the lab. One of them happened during APEC today. We just received in some new amplifiers from Sandia Labs. There's two of them on the pallet over here. These are 200-watt units, and they cover like literally the entire RF spectrum from 400 megahertz to 12 gigahertz. I was most interested in the 7.6 to 12 gigahertz unit over here, and as luck would have it, it was broken, and we're trying to figure out why it wouldn't be turning on. And just about 2 hours ago, we found some of the transformers on the low voltage section had come loose off of their board, so they weren't given the proper voltage. So we had to solder those back into position. The switches on the front panel were mostly all broken, so those need to be replaced as well. But right now we are getting that red lamp over there, and then eventually the standby lamp will turn on as well. And so it does seem to be working, and there's only 250 hours on the traveling wave tube amplifier, so we should be good to go with this unit. And this is going to be running Alzafon hopefully sometime next week, or this coming week. Here's another unit that I had open just for comparison, because all the low voltage and high voltage boards and everything are pretty much identical between these units. That helped find the problems. Aidan Schaefer over here helped out and punched a hole inside the Faraday cage over there. See that large hole down there? That's where we're going to be feeding in waveguide for our higher power experiments, so the amplifiers can sit outside. We also got a new computer for the lab. This is for getting in all the data and signals and all that kind of stuff. It's all going to be fed into a lab test computer with LabVIEW on it. There's also live video feeds that are going in over here. So all the information is going to be plastered along these two screens as we're running experiments. What else we have going on over here? Aidan Schaefer has his Manelos device, which is going to give us a little rundown on.
The original part of it, Mark 1 is up here, and these are some of the coils which are similar to here. This does have the conditioned ferrite.
Can you just give a rundown what the Manelos device is?
It generates, it's using the Aharonov Bohm physics. So in the conditioned ferrite,
which I haven't
So
got.
what does it do with the Röntgen physics?
Thermoelectric conversion is what
There you
Dr. Ahern has seen, but Mark doesn't have a full grasp of the physics, which was partially in the ferrite. Let me get the viewing film out. Coils upon coils upon coils. So, although that looks pretty dirty, this is preconditioned ferrite, and then I've got to finish getting this coil. I'm not happy with this one, but little by little, I'll probably make another one. And then you hit it with high strength or high voltage, and then it's been reported that I'll start getting a circulating oscillation within the ferrite. I'm not happy with building on the square and the round, so I switched over to the round.
And then you get the oscillation in the ferrite. What happens next?
Well, then it starts, after a while, the oscillation starts, the circuit's tuned and it kicks out every voltage spikes over 180 volts into the system. So it's the original inventor modified the Bedini schoolgirl circuit and turned it into a solid state device. So anyway, this is Mark II. I still have to finish doing some this is my second attempt at it. It's more of a test bed. And then here's the start of a magnetic component. So I still have to degauss this via thermal methods and then create a coil, or maybe this coil actually does work on there too. And then whack and get the exotic state of matter going on in the ferrite. So this one's allowing me to work on the round. You know, working on the round is helping me to work through the squirrel's nest of the Manila circuit, because I have the original technician's report of it from 2012 by Graham Gunderson. So thank you, Dr. Malone, for keying me in. But eventually, you know, nobody else in the group is working on pulling in the vacuum, so this system does do that. I've found that in 2011 in the Tesla Tech conference, there was a Kohler, or there was a German guy back in the 30s by the name of Kohler that had a similar circuit. So over the last, I don't know, well, from the 30s and then Arthur Manellis, you know, there have been a couple people that have been able to have a circulating circuit that produces more electricity, or it changes the domain and is able to pull in electricity from around. So
thermal energy. What part of the circuit is the one that cools down?
It's within the ferrite, or actually
the ferrite being the center disk over there, right?
Right. Yeah, right over there. But the Dr. Ahern, when he was monitoring Arthur Manellis' device, they had a whole bunch of thermocouples spread out in the trunk where he had his system set up, and as it ran longer, it became cooler within the trunk. So
trunk of the vehicle, that is.
Yes.
Okay.
And then the car, you know, after, you know, without being plugged into the grid, it was an electric car, and they had it under monitoring. And when they started the monitoring process, the battery was at 69%, and they came back a couple days later, and the battery was up at 83% without Arthur coming in. And you can look on the Tesla Tech conference. I'm sure Steve Elsick will put it out on YouTube eventually, or you can look through Dr. Balone or approach me, and I'll be happy to talk about it. So just making gradual progress, yes. But the real physics is working with the ferrite, which improving this. And then once I get this whacked, I'll have that exotic state of matter in it, and that's what's doing the work. So
the conversion,
the work, yes.
So here that gives you pretty much a rundown of what's going on. These two units on the bench, we still haven't powered them up yet. Also, for those of you who don't know, we used to be a hybrid battery shop, and Some friends of mine are taking over that business, so there's a lot of free space over here. They moved it over to another building. There's enough space in here to play tennis probably right now. So we're clearing out the lab for larger and better things. Also, I got hit by the COVID, and that knocked me out for a couple of days, and just still recovering from that. But this is basically what we have going on over here. We just managed to get this running just about an hour or two ago. And I'm waiting for one waveguide piece to give us a twist, because right now it's at the wrong plane. And then we'll be able to hook it up inside the Faraday cage and see what happens with Alzifon. We did run Alzifon at 20 watts. That's 20 watts traveling wave tube amplifier. And we measured about 1 watt of power being received in a little saltwater test article inside of the waveguide. And when we tested that using the aluminum samples, there was a little bit of a wiggle on the scale. We're using an analog scale this time, and just putting a camera on that so we can see what's going on. And that's why we're upgrading the lab view and all those other software and hardware upgrades, so we can get much more accurate views on what's going on. But that's basically what's happening here at the lab. Oh, one other thing. This is the gyroscope contraption. Not Gamble, if you're watching, there's 2 of these that are completely built, and they have 2 servos on each unit. There's also the 4-inch gyros that are just about complete over here. We got the motors for these coming in soon. Here's here's one with more material removed, so you get more gyro systems already set up. So that's something else that we're working on. We're just looking for somebody to do the software programming for this project to finish it out.
Awesome. So Mark, that's it for the update then?
Pretty much, yeah. I think Jeremiah might have some stuff to update. He's
Jeremiah, are you with us?
He might not be.
He's not here. No, Mr. Recess, but not Jeremiah Pop. Well, so I think if that's it, let's go to open discussion then. Yeah, so that'll make it official. We'll go to open discussion, and so yeah, you guys don't need to raise your hands for questions. Just anybody who wants to talk, jump in. Try not to step on each other's toes.
Well, Tim, you hit a home run by picking John Hutchison Effect. That's a great way to open the
Thank
year.
you. You know, I was really nervous though, and the reason is, I don't know nearly as much about it as George does. So when George appeared, I got really excited because I was like, oh my God. I mean, he worked with John closely for years. He was there at the beginning, you know. For me, I came in much later, and I didn't realize how much psychological stuff was involved with that. So that helps put that in context, I think, you know.
Well, in a way, that also brings, what Sarfati were talking about, how CIA was interested in consciousness and the effect of consciousness controlling matter in the universe, something the military wanted. And so here is a wonderful connection. I didn't know about it myself. Now I know a lot more. So yeah, that would be great if you bring that guy back, and Sarfati maybe comment, expand on that. I mean, are they both connected, do they collaborate with each other, Sarfati and him and George?
No, they don't. I mean, they all know each other. But to my knowledge, they don't really collaborate. Jean is very much a tinkerer, and Jack is very much a physicist. So they're just on different ends of the spectrum. It's probably, it's difficult for them to communicate. I mean, George would probably be the best mediator, and I know he speaks to Jack. I know that they know each other, but with John, I know that they've spoken, but they speak different languages. I think that's the challenge.
Okay, well, that's good, but you hit a home run. That's good. I hope the rest of the year is going to be this good.
Yeah, well, we're working on it. We're working on it. I know Mark and his group are working really heavily on stuff too. So we have a lot going on.
And I hope that this year Mark has a lot of good stuff, because with all those toys that he's been assembling, very soon he's going to start making experiments and producing a result. So we'll all be looking forward to that.
Yeah. No, it'll be exciting.
Tim, did you already have the episode with Bob Greenyer on, or is that yet to come?
No, that's up. Actually, if you go to the altpropulsion.com website, it's I think it's two conference sessions back.
I missed it while I was out moving my grandma in BC. But
it's up, and so I've also changed the way I do the videos a little bit, which is kind of good and bad. I used to have that playlist feature, right, where you could select which one you wanted from the playlist. And what I'm doing now is I create those playlists. They're still up on the old AAG website, but the big difference is I'm rendering our APEC videos in 4K. The actual Zoom file saves at around 3K, so it's in between, right? It's in between HD and 4K. I'm up rendering to 4K, and then I'm putting in chapter markers. The only downside is when I put those on YouTube, it takes about 5 days for it to render them. So I still use the playlist for the first couple days and then swap them out.
Would you be interested as well, as I get going with my 24-hour streams and whatnot that I'm going to be doing APEC on me helping you upload your stream to APEC itself so you can go live with this, and then as well later how you edit it and then re-upload it on? Would you be interested in doing that?
Potentially. I would say just email me and I'll
figure
out what we're doing there. So
yeah, I got this thing I found on the Hutchison Effect on a skeptics. Someone who's skeptical about it, and it's here. I'm going to read this thing. Hutchison has been profiled on the Discovery Channel, the Learning Channel, National Geographic Channel, Is It Real, and Nippon Television. He's also featured and discussed in various fringe science newsletters and websites. There is even a website devoted to his various hoaxes. Of course, some people take Hutchison seriously. For example, Mel Winfield, who I don't know who that is.
Yeah, Mel Winfield did the nucleonic research. So Mel Winfield had kind of an alternative explanation. Mel knew John.
I'm going to read. He claims that he came up with the Hutchison effect first. Its proper name is nucleonic energy. According to Wikipedia, nucleonic energy is a technology concept developed by Canadian autodidact and inventor.
Autodidact, yeah.
Autodidactic?
Energy obtained from
Autodidactic?
the momentum of nucleons, protons, and neutrons within an atomic nucleus. Whereas gravity dictates the spin x of nucleons are oriented towards the center of the Earth, nucleonic energy allows for the axis to be reversed or directed in any desired direction in order to produce all forms of motion.
I'm not even sure if Mel Winfield, let me look him up. I'm not even sure if he's still alive.
Allows the Magnus effect to take effect on the nuclei, presumably cause levitation. So, the Magnus effect is, hold on.
Yeah, it wouldn't be the Magnus effect. That's the spinning ball that creates the low pressure over it.
Yeah, exactly. It has to do with the motion of a spinning object in a fluid.
Yeah. So yeah, with Mel, there may be possibly that. To be honest, though, when it comes to Hutchison, I would say the absolute best qualified person to speak on it is George, hands down. George probably knows more about it. In fact, George definitely knows more about it than John does.
Well, I just think it's cool that we look at all perspectives when it comes to something like this, and there might be a grain of truth there, like you say, Tim.
I can tell you, in terms of those material samples, what I've always felt was that it's valence electrons, and it's just bumping them out of their orbitals, right? And it's resonant frequencies bumping them out of their orbitals. That part of it, I feel like, okay, that explanation kind of seems like it holds water. But the rest of it, especially the levitation and the other effects that he's had, I couldn't even begin to speculate.
What I think is going on, what I'm kind of concerned about is, and I actually have most people don't realize that non-ionizing radiation is dangerous too. I mean, when we think of radioactive substances and neutrons and protons and alpha, gamma, and beta radiation, non-ionizing radiation is harmful too. In fact, that's what your microwave uses, is a non-ionizing radiation to heat your food. But there's a lot of research that has shown that low levels of non-ionizing radiation can be harmful to living things. And basically, I have some close friend who died of blood cancer, and he was a ham radio operator, and he spent his many years sitting in front of his radio transmitter. And, there's long-term effects of exposure to this stuff that people don't take into consideration. And as I was in my work, I was always scared the shit out of me. I would do whatever, even if the first thing you learn in precautionary principle and risk assessment is called avoidance. You avoid the risk. And so a lot of my friends, though, they were more laissez-faire about it, and it caught up with them later. And so I think there's a lot of problems with when you're working in this kind of field with exposing yourself to stuff that can be harmful. And I think it's good for us to reflect on that when we're discussing this. It's kind of like when Ron Keto was talking about his experiments and using benzene rings, that kind of stuff scares the hell out of me.
Well, Michael, have you ever looked up what you were talking about with the ham radio operator? Have you ever looked up cell phone exposures?
Yeah, actually I have. And I actually, I have this group called, a nonprofit, it's called Californians for Renewable Energy, Inc. The purpose of our group is to sue the government over energy projects. And I've sued the EPA on one, and I've sued a bunch of different government agencies. That's my hobby, suing the government. And so, but what I learned, we sponsored this group called StopSmartMeters.inc, which is StopSmartMeters.org. And basically what brought it to my attention was when they started forcing people to get these wireless smart meters installed in their house. And I noticed, I looked at the one, I live in PG&E territory, and PG&E was making this meter, and I noticed it didn't have a UL mark on it. So being a compliance guy in the industry, that kind of shocked me. And then I learned that this thing was hitting, depending on where you had it, it was like over a watt of this RF. And so the thing is, that's what brought it to my attention. Then there were all these people were getting sick. They put them in, and they actually had this physiological effect called electrosensitivity, where people that get exposed, they can't be in a radiation area. So they'll go to where they have the radio telescopes. That's where they'll move, because the radio telescopes are in zero Wi-Fi regions. You know what I mean? So there's a lot of we don't know. And that's the part that scares me the most, is what we don't know. We can see these wonderful things, new discoveries, but what's the risks involved?
Yeah, no, it's a good point. It's a good point. And with the cell phones, I've seen pros and cons, right? And that's the problem. You've got people who are like, nah, it's not a problem, but there were other issues too, if I remember right. One of them was
I forget what they call the tumor, but you get I have a friend, her son spent when he was young, in his teens, he would spend just hours and hours on his cell phone.
Yeah.
And actually, some of those cell phones, those 900 megahertz cell phones, were less safe than the 2.5 gigahertz ones are for some reason. And so he developed a brain tumor.
Well, but then the other issue is, even if you're not on the phone, and this is one of the reports I've read, even if you're not using the phone, it wakes up and connects to the network periodically. And when the modem wakes up, it connects at full power before it drops back down. So you're getting pulsed repeatedly.
Oh, yeah. Who was it? Snowden talked about it and said, basically you need to turn your phone off because you're getting monitored. Whenever your phone's on, you're being monitored.
So you're saying I should sleep with my cell phone under my pillow, yes?
Yeah. Well, no, Bernie, I would put, actually that was the problem. The problem was it was people who physically kept their phone on them. And they didn't realize that even if they're not using it, they're still getting pulsed because it's waking up, right? It's got to do periodically it wakes up, connects to the network, it checks for new messages. And what they were saying was, I don't remember what brand it was, I don't remember the details, but what they said was when the phone wakes up, it comes on at full power, it does a network connect, and then it drops back down. So they said, if you've got this on you all day, you're getting these pulses over and over and over again. If it's under your pillow at night, every 12 seconds or something like that, whenever it does this.
Yeah, that's why I stopped carrying my cell phone in my pocket.
A centimeter away. You're not supposed to get close. It's not supposed to be touching you. If you read the instructions, the safety thing on it, it's not direct. You don't put it to your ear. You're supposed to hold
Speakerphone.
it about it away for it to be safe.
You've got to talk like way away from it with the speakerphone, and then the Bluetooth. But then Bluetooth, is that just as bad? Even more waves going into you?
Well, the other thing you can do, what I did when I was a Lyft driver, is I had a headset like you have there, and I'd plug the jack into, with just one ear headset, and that way I could shield myself, and then there was still some of the RFs gets transmitted down the wire. So you have to put a little put a little choke, it's called. It's a graphite, it's a graphite circle that goes around it, and that chokes off the RF.
That's
I had
cool.
to go through all that just so I wasn't getting exposed all the time to that RF part. But they don't tell you about any of that.
No.
Michael, you don't recommend using one of these brain enhancers or put magnetic fields in your brain?
Actually, that's a different effect, sir, because that's using alpha. There's
that's the good waves.
7.8 hertz,
frequency of the RF. The radio frequency is high frequency. Well, what you're using there is a low frequency device, and it's actually therapeutic.
Oh, okay.
It's very helpful. My son went through a treatment program doing just what you're showing me, and it helped him immensely. So don't get me wrong. I'm not talking about that. I'm talking about what the cell phone company is trying to sell you.
Yeah. Well, guys, I'm going to step away for a few minutes. I'm going to leave it running so it's up on the machine.
I got to go. My wife's already lost patience with it.
Is it open forum?
No,
absolutely.
It's open discussion. I'm gonna step away. I gotta actually start making dinner.
I have a question for you before you go.
Okay.
Thank you.
The Finnish researcher Podlikov, or whatever his name is, has he had any of his new inventions or new devices replicated anywhere? I'm very interested in that guy.
Claude Power in France, I believe, is the closest, and he has his own theory about why it works, and so everybody kind of changes it to suit themselves, right? I see Jeremy smiling in the camera there. Jeremy, do you have some Claude Power or Podlikov ideas? Wait, that was a big smile. He had a big guilty smile, and now he's being shy.
Jeremy, your mic is
I saw a flash.
Oh, okay. Well,
There we go. Now he's unmuted. COVID, are you still alive with
I just saw
us?
this big smile. I'm like, he's got something.
He's clearly not dying.
No, someone was taking my picture from the background. I didn't see.
I saw the flash. I did notice.
Yeah, and then it took me a while
that's
to
okay.
all my mics, unmute all the mics. So.
Well, yeah. So for me, I would say Podklanov. I haven't spoken with him in close to a year at this point. Oh, yeah, they are taking your photo because you're a celebrity, man. That's why. Oh, and you have a guitar too. Yeah. So you're a celebrity, you know it. That's the worst part.
Documenting his survival.
But it's an acoustic guitar. That's a it's that's like the soft look for the holidays, right? So.
Jeremy, you gotta serenade us now. You can't come back with the guitar.
He's a very good singer.
I want to hear it.
Karaoke, like, really is really. He
Prove you can still sing during COVID. Why are we on lockdown? He's fine. Oh, no guitar this time. Jeremy, you gotta unmute yourself, brother.
I wish I had like an amp or something I could plug into and just turn it on, but I don't.
That's why I have the acoustic down here.
But yeah, I didn't mean to steal the show. I wanted to talk about Claude. I was interested in talking about Claude Poher and Podklanov and
But you're our science experiment of.
play some Bad Brains.
You're a science experiment of the week. You're surviving. You're proving why are we all locked down?
Not dead yet. So 6.5 hours in, guys. So I don't know. What's on the agenda now? You want me to start just jamming up on the guitar?
You gotta sing us a New Year's song.
All right. Let me think. What can we do?
I survived the bioweapon 2022.
I used to dream impossible dreams till I woke up one day and I realized my dreams were dead, replaced instead with a lifetime of failures and of compromise. Oh, but I see things that aren't real. Was it a super virus to kill all of humankind? No, is it a super virus to kill all of humankind from just a strain that another psychopath designed? Oh, but I lie awake. I lie awake. I sit here in the atmosphere and dream of my escape. Discover anti-gravity in a craft that levitates before I die here on this planet of the apes. Oh, that's it, man. That's all I got. I can't remember all the words. But I actually should sit down and write like a whole bunch of them because it would be cool.
That was absolutely amazing, by the way. I loved it. Round of applause. Where's Jeremiah? Hi, chat. Does he have no purple mercury to show us this week?
Yeah, man. Let's have some hope for this new year. We're gonna try a lot of different models and try a lot of different ideas. Michael, thank you for that tip on the new search term, which is correlated materials, strongly correlated materials, and correlated electrons, correlated electron systems. Ton of papers that I am going to be up all night reading about after the conference, now that I have a new search term to look up. This is corrugated electron matter, electrodynamics of corrugated electron matter. I'm going to be diving into this literature.
So is that like metamaterials, like another term for metamaterial, essentially?
No, this is like, well, a superconductor would be an example, or perovskites and stuff. It was saying, but this is like how you can energize, artificially energize different materials like metals and stuff, like Hutchison Effect type effects.
Forward me everything you find.
Am I not completely off on this? So dope transitions in metal oxides, charge and spin ordered states and solids. I'm gonna have to read up on all this stuff and hopefully understand it a little better.
Oh yeah, and you're sharing on your stream, but not in the Zoom, just for everyone in the Zoom's reference.
Yeah. Tons and tons of awesome reading material there for sure. All right, I'm just gonna end the stream there on that song, and we'll go to just private chat and hang out behind the scenes on the Zoom call. So
good call. Happy 2022, everybody.
Yeah, that was an epic APEC to start the year. I think I have more questions than answers from most of it, but yeah, like let's go into. I would love to see some more experimental replications. And what's up? Has anybody else replicated this technology? And Jeremiah was saying that a German lab and also Russians were able to replicate some of this stuff. And I would like some more information on those studies and to know more about this. So. For next time, yeah, I'm going to be studying how to unlock my mind powers and my psychic mind powers, so I can.
You gotta believe in quantum entanglement. The fundamental thing, like you have to believe in quantum entanglement.
That's the key. That's
the key. There's no way.
Things in no time.
Power projection and the law of attraction, right there.
Did you end the live stream?
Yeah, it's over. Ending now.
Oh, I guess I should do the
There we
same.
go. Yeah, why can't we keep the stream running? Because you can jump in the Zoom call. I'm done with the live stream. It's been fun. We had over 100 people watching at the high point, which is really cool.
And then pretty much double that through autodidactic.
Nothing to do today. Sure, there's plenty to do. Speaking of which, what's going on with Mark Sokol and the Falcon Space Crew? He's texting me and asking me when I'm going to come down there to the lab. I guess if we all have COVID, maybe it's all right. But what if they got Alpha and I got Delta, and or one of us got Omicron, and we're just going to be mixing and matching strains and stuff? Is that?
All life is a big old experiment, so.